Then question 4 we have, the graph of g of x is equal to a bracket 1 over 3 to the power of x plus 7 passes through the point negative 2 and 10. We have to calculate the value of a. Okay, so to find the value of a, they've given you a point. So just go ahead and substitute this point into this equation. Negative 2 will be your x value and 10 will be your y value. Okay, so we're saying in place of y, which is g of x, we're putting 10. 10 is equal to, and we have a bracket, the 1 over 3 raised to the power of x, and x is negative 2. Then we have plus 7. Okay, so if you put on your calculator 3 to the power of negative 2, you will see that you're going to get a positive 9, okay, as your answer. So it's really just 10 is equal to, we have a being multiplied by, and the reason why is really because this is negative. When you multiply, we have 1 over 3 raised to the power of negative 2. When you're multiplying this into this number, you know that this exponent has a natural exponent of 1. This number, sorry, has a natural exponent of 1. So does this. This needs to multiply into both exponents. So it's really 1 to the power of negative 2 over 3 to the power of negative 2. Since the exponents are negative, to make it positive, you would take the 1 to the denominator and you would take this to the numerator. So that's 3 to the power of 2 now over 1 to the power of 2. 3 to the power of 2 is 9. 1 to the power of 2 is just 1. So that's 9 divided by 1, which is 9. So we have 9 and then, of course, plus 7. Then we can go ahead and say we finally have a multiplied by 9, which is 9a. But I'm going to take the 7 over. So that is 10 minus 7 is equal to 9a. And so that is 3 is equal to 9a. Divide both sides by 9. So a is equal to 3 over 9, which will give you 1 over 3 if you simplify that. So 1 over 3 is your value for a. Then we have calculate the coordinates of the y-intercept of g. So to find the y-intercept, you're always just going to make your x value equal to 0. Okay, so the graph of g of x now looks like this. G of x is equal to, and then in place of a, we have 1 over 3. So 1 over 3 multiplied by 1 over 3 to the power of x, and then of course the plus 7. Then all we're going to do is make x equal to 0. So this is g of 0 is equal to 1 over 3 multiplied by 1 over 3 to the power of 0 plus 7. So anything to the power of 0 gives you 1. So all of that just gives you a 1. So you have g of 0 being equal to 1 over 3 times 1 plus 7. So when you multiply those two together, they will just stay 1 over 3. So what is 1 over 3 plus 7? You can put that on your calculator. So that gives you g of 0 being 22 over 3. So you can also do it manually, but you're trying to stay safe so that you don't make any mistake. So if this is our value, it means the y-intercept as a coordinate is really just 0 and 22 over 3. Okay, but of course they can see that is the y-intercept that we have. Moving on to the next question. The next question says, consider h of x being equal to 1 over 3. And so the first question is to describe the translation from g to h. Okay, so let's compare both graphs. G of x was 1 over 3 multiplied by 1 over 3 to the power of x plus 7, right? Okay, that was g of x. And h of x now is just 1 over 3, and I think I missed something there. It's 1 over 3 to the power of x. Yeah, okay? So to the power of x. Okay. So what happened? When we're looking at this and this, first of all, you can see that the 7 is not there anymore. So in order to remove that 7, you must have said minus 7. And on a graph, when you say minus 7, okay, so for you to have said minus 7, you must have taken the entire graph of g of x and subtracted 7 from it. Okay, so the entire graph of g of x stands for everything here. The 1 over 3 times 1 over 3 to the power of x plus 7. Then you must have said minus 7, so that would get rid of that. So if you said g of x minus 7, what this means is that you took the graph and you moved it 7 units down. When you move the graph up or down, it will affect g of x. In other words, the y values of this graph. And because y stands for g of x, you're actually moving the graph 7 units down. So that's one thing we know. Okay, it moves 7 units down. Okay, but now that solves the 7 problem. How do we explain what happened here? How did this become this? Okay, so the thing about that is, you see this, you have 1 over 3 being multiplied by 1 over 3 to the power of x. The bases are the same. So if we're simplifying g of x, you could simplify it like this. That part, so of course we have the plus 7, that part, since the bases are the same, the exponent on this 1 over 3 as a number as a whole, the exponent is an invisible 1. So if two numbers are being multiplied and their bases are exactly the same, the base will stay the same, stay 1 over 3, and we will just add the exponents. So that's 1 plus x. Or we could also just say x plus 1. Still the same thing. Okay, so it means that if you simplify g of x, this is how it looks. Now you can compare it. Compare g of x with h of x. Just looking at this part, of course. You can see now that what happened is, in front of that x, that 1 is now gone. You must have said minus 1, and you're really affecting the x. So imagine this is really what you just did. You took the g of x, right? And you went to the x and you subtracted a 1 from that. So what does this mean? This means that when you're affecting the x, it means the graph is either moving to the left or to the right. If you have a minus, it is right. If it's a plus, it is left. So you just have to remember that with left and right. They don't work the same as up and down. Okay, so this would mean that this graph, okay, it moved 1 unit to the right. Okay, 1 unit to the right. And so that's actually the translation. So if we're just describing the translation from G to H, you would say the graph of G was translated 1 unit to the right and 7 units down to form H, okay, to form that new equation. So you can, of course, leave that thing that we said about the G of x minus 7. Okay, so I guess here a mark, something that would really affect your mark possibly is simplifying that, being able to actually see what that actually became. Okay, so that is the final answer. Moving on to the next question. Then the last question for question 4 says, determine the equation of the inverse of h in the form of y is equal to. Okay, so the equation of h was just h of x is equal to 1 over 3 to the power of x. First of all, let's go ahead and replace h of x with y. So let's write it like this. Y is equal to 1 over 3 to the power of x. Then in order to write the inverse, you just swap x and y. So in place of y, we say x is equal to 1 over 3 to the power of y. And then step 2, make y the subject. The only way to make y a subject, seeing that it is an exponent, is to use log. So we say y is equal to log, and then we need a base. So the base is just the number carrying the exponent, which is 1 over 3. So the base is 1 over 3. And the number that we have here is going to be the x. Okay, so that is your answer there. Y is equal to log x with a base of 1 over 3. And that is the last question for question 4. So moving on to question 5. Okay, so now we are on question 5. And question 5 says, consider g of x is equal to a over x plus p plus q. The following information of g is given. So they've given us the domain is x is an element of real numbers, but x is not equal to -2. The x-intercept is k, which is 1 and 0. And the y-intercept is n, which is 0 and -1/2. So they've given us 2 points. And they've told us the domain. So the domain is actually going to help us with the value of p. But there's something you need to remember. The general equation of a hyperbola is y is equal to a over x minus p plus q. Then by them telling us that x is not equal to -2 as part of the domain, that is them telling us the value of p. Okay, so the range would be y is an element of real numbers where y is not equal to whatever the q value is. Okay, the domain is x is not equal to whatever that p value is. So it means that P is actually negative 2. But I'm going to substitute it into this equation, not that, because this equation can be misleading. You see that you have an x plus p here, but the original equation of it is supposed to have an x minus p. If you had taken that and just put it in like that and you end up having a minus 2, you will see that x minus 2 is not what you should have here, because as you can see, you have an x plus 2 here. And that's the reason why, because you're supposed to really use this as your general equation of a hyperbola. It is y is equal to, or in this case g of x is equal to a over x minus. Then we know now the value of p is actually negative 2. That's the value of p. So minus negative 2 and then plus q. And so you see, if you simplify that, we have g of x is equal to a over, and that now becomes x plus 2 because of the minus times minus, and then plus q. Okay, so just be careful with that. Remember the general form of a hyperbola. Then they've also given us other coordinates to help us. So they give us 2 coordinates. Let's use them. So first of all, we're going to substitute the x-intercept, which is k. So we have k, which is the 1 and 0. This will be our x value, and that's our y value. So I'm going to substitute it into this equation. So g of x is y. In place of g of x, I'm putting 0. So 0 is equal to a over, and then we have in place of x, that is 1. So 1 plus 2, and then plus q. That will give us 0 is equal to, we have a over 3 plus q. So this is the first equation we get. You're going to see that we'll have 2 equations. They've given us 2 points and 2 things are missing, a and q. And we're going to go ahead and substitute this other point, n. So substitute n in, which is 0 and negative 1 over 2, which is a y-intercept. Remember, you're putting this as x and that as y. Okay, so we're saying negative a half is equal to a over, in place of x, x is 0. So 0 plus 2 and then plus q. Okay, then we have negative a half. We have a over 2, because that becomes 2. A over 2 and then plus q. So nicely we see that q and q are actually left alone as they are in their equations. So we can make q the subject here. So I'm going to make q the subject by taking this over. And so if you take it over, it becomes negative. Negative a over 3. So the fraction is negative, is equal to q. Okay, then in this one, we're going to take this over. Okay, so we have negative a half, and that becomes negative. So minus a over 2 is equal to q. Then I can go ahead and say this can actually subtract. The denominators are the same. When you are adding or subtracting fractions, the denominator must stay the same. So I'm going to keep the denominator the same. And now I'm going to say this negative 1 minus a, and the denominator stay the same. So that's just minus 1 minus a is equal to q. So you see we have an equation for q and an equation for q. So we can go ahead and say that q is equal to q. So this q was negative a over 3, that's what q is equal to. Negative a over 3 is equal to negative 1 minus a over 2. And all we have to do now is just solve for a. Okay, so to solve for a, you can, since we have a fraction and an equal to, we can just cross multiply. So we're multiplying this and that. Remember, when you multiply this, the 3 needs to multiply to the 1, the negative 1, and the negative a. So when it happens, when you say 3 times negative 1, you get negative 3. 3 times negative a, we get negative 3a is equal to, and then these also need to multiply across. Negative a times 2, which is going to be negative 2a. So we have negative 3a. I'll just take the negative 3a over instead. So negative 3 is equal to, we have positive 3a now, and we still have a minus 2a. And so it means that that becomes 3a minus 2a is a. A is equal to negative 3. So here we have the value of a. Now all we have to find is the value of q. So you can take the simplest equation of q. That would be that one. So let me just move this to the side. So we can say that q is equal to negative a over 3. So negative a over 3. And we're just substituting the fact that a is negative 3. So q is equal to negative, bracket negative 3 over 3. And so that will become positive 3. It's like saying positive 3 over 3. So Q is equal to 1. And there we go. So we have the value of A and Q. So now you can just fill it in to your equation. You see, this was the equation where A and Q were just missing. So A is negative 3, Q is positive 1. So we're just saying, therefore, it means that g of x is equal to negative 3 over the x plus 1. Was that plus 1? No, it's plus 2. Okay, x plus 2. And then the Q, of course, is a positive 1. There we go. Okay, so that was just substituting basically. Moving on to the next question. The next question, 5.2, says write down the range of G. So the range of G, remember, if the domain was x is an element of real numbers, but x is not equal to whatever the value of P is, the range is always going to be y is an element of real numbers, but y must not be equal to whatever the value of Q is. And Q is 1, so y must not be equal to 1. So you can't even put a semicolon, it's still fine like this. And this is because this graph will continue having y values for every single value of y except for 1, because we have an asymptote at 1. Okay, moving on to the next question. 5.3 says determine the equation of H, the axis of symmetry of G, in the form of y is equal to mx plus c. Okay, where m is greater than 0. So they're calling this graph H, but we want the equation in the form of y is equal to mx plus c. So it is the axis of symmetry of G where the gradient is positive. So that axis of symmetry just looks like this. Y is equal to x minus p plus q. You see, it's quite easy to remember if you remember the general form of the hyperbola a over x minus p plus q. So you see that x minus p plus q repeating. That is the positive one, the one with a positive gradient. Okay, so we just have to fill in the value of p and the value of q. So y is equal to x minus the value of p. Remember the value of p, looking at the equation like this, p is just equal to negative 2. It's always, if you see x plus 2 here, it's actually a negative. And we actually saw that already from the beginning, the fact that they said x was not equal to negative 2. See, in the domain, x will always not be equal to the value of p. And so negative 2 is the value of p. So we have minus negative 2. And then q, of course, is your value of q, which is, as we can even see it here. Okay, that is the value of q. It is positive 1. So plus 1. So we have y is equal to x. That multiplies in and becomes a plus 2 plus 1, which is y is equal to x plus 3. That is the equation of H in the form of y is equal to mx plus c. Okay, moving on to the next question. Okay, the question 5.4, which is the last question for question 5. It says, write down the coordinates of k prime, the image of k reflected over H. Okay, so they told us what H was. H was this equation that we have here, the axis of symmetry of G. That's what H is. So if H is the axis of symmetry, let's just go ahead and put that down. Since it is a line with a positive gradient, it's going to be an increasing function. So it's going to look like that. Okay, so read it from left to right. It is increasing. So that is the y is equal to x minus 3. Now we have this point k, the original point, wherever it is. Let's say it was over here, right? So we have k, and the coordinates of k is, they told us what k is. Okay, so 1 and 0. So if the coordinates of k are 1 and 0, then we need to find out what the image of k is going to be. So let's say it was like here. What is the image of k? So it's reflected through this line. This line is kind of like the mirror image. So we have to find out what exactly this point is. Okay, so this is something about reflections. When a point is being reflected over a line, what you will realize is that from the point, the original point, to the line, you're going to realize that the distance is going to be exactly the same as from this line to the reflected point. Okay, so let me actually just push that up a bit. Okay, so from here to this line over here, it's going to be exactly the same as from this line to this line because it's a reflection. And then another thing about this is that you see this new line that has been created, it's going to be perpendicular to the line that this point is being reflected over. And a way that I can explain this is really imagine you had a mirror and you were looking in the mirror, right? So let's say your reflection is here. So your reflection is actually going to be over here, right? There's no way that your reflection is going to be down here because this wouldn't make any sense. So you can imagine it as this. The reflection is going to be exactly in line with your image, okay, with your original self. So it's kind of like this is your mirror, this is your original self, this is the reflection. It's a perfect reflection. And so we see it as just to show that your eyes here and the eyes in the mirror will be at the same exact height. If I drew a vertical line representing the way the mirror is standing as well, okay, you will notice that your eye level and the mirror's eye level will be exactly the same. And so if you see this line between your eye level and that vertical line representing the way the mirror looks, this line is basically going to be parallel to that mirror. You're going to notice that we're going to have a 90-degree angle here. And it's really just showing that the eye level of your original image and the eye level of the mirror's image is really in line with each other and they have the same height. So it's something like that. So the fact that these two lines are perpendicular, and we also know that the distance from this point K to the line and the distance from the line to the new reflected point are exactly the same. This is how we're going to be able to find this coordinate over here. We're going to use the fact that these two lines are perpendicular. We can go ahead and we know the gradient of this line. Because these two lines are perpendicular, we can find the gradient of this blue line. And when we find that gradient, we can find its equation. Why are we finding the equation? So that we can equate the blue line with this line, y is equal to x minus 3, and we can find that point of intersection. If we find that point of intersection, it is going to be the midpoint of your k and your k prime. And we can use that midpoint to go ahead and find k prime. Okay, so the first thing we need to do is we need to find the gradient of this line so that we can find its equation, so of the blue line. So since the gradient of this line, as you can see, is 1, because we have an x here, it's mx plus c, the 1 is invisible. So since the gradient of this line is 1, the gradient of the reflected line, since it is perpendicular to this line, you would find it by saying that that gradient, and let me actually put that in blue, that gradient is going to be equal to, you're going to have to say negative 1 divided by the gradient of this line, which it was perpendicular to. So divided by this gradient, which is 1. So it means that the gradient of the blue line is just negative 1. Okay, so because they are perpendicular. Remember, another formula for that is really just that the gradient of the first line multiplied by the gradient of the second line must be equal to negative 1 if the two lines are perpendicular. So you could have also found it using this. You could have found the gradient of the second line, which is the blue line. Okay, so we have the gradient of this blue line. Now we just have to find its equation. We can find the equation because we have 1 point on the blue line. We have 1 and 0. So we can go ahead and substitute 1 and 0. Now I'm going to use the equation of a straight line that I'm going to use is this. Instead of y is equal to mx plus c, I'm going to use y minus y1 is equal to m bracket x minus x1 because it's just easier to find the y-intercept like this. So we're substituting this point, and I want you to know that this is your x1 and this is your y1. So we're saying y minus y1, which is 0, is equal to m, which is negative 1, bracket x minus x1, which is 1. And so this is going to be y minus 0 is just y is equal to, and then we just distribute this. So negative 1 multiplied by x, which is negative x, negative 1 multiplied by negative 1, which is positive 1. And so this is the equation of this blue line. Now that we have the equation of the blue line, we can go ahead and equate these two equations, make them equal to each other so we can find that point of intersection. Okay, so something I noticed I said that this equation is y is equal to x plus 3, but it's supposed to be x I said x minus 3. It's supposed to be x plus 3. Okay, so now if it's x plus 3, how do we actually find this point of intersection? So we have the equation of this line, okay, of the blue line. And now we have to find this point of intersection. So we can find that by equating this line with this line. So we're just saying that y is basically equal to y. And we're taking this equation, the x plus 3, and we're equating it with this equation, the blue line's equation. So we can find that point of intersection. So negative x plus 1. Then we're going to take the negative 1 over. And so we just have an x here. The negative x comes over and becomes a positive x is equal to. Then we have a positive 1 here. We're taking this positive 3 over, becoming negative 3. So this is 2x is equal to, we have 1 minus 3, which is negative 2. And so divide both sides by 2, and x is equal to negative 1. Okay, so we have the x value of that. To find the y value, you can just substitute this negative 1 into either the blue equations line or even this line, because the point is on both lines. So we can just say y is equal to, and I'm just going to choose this one because it just looks so much easier. So we have x plus 3, and in place of x, I'm saying negative 1 plus 3. Which is, of course, negative. This is positive 2, I mean. So positive 2. So the points that we have here as our point of intersection is negative 1 and positive 2. Okay. Now that we have that point of intersection, all we can do is this. In order to find now this point K, remember that from here to the point of intersection and from the point of intersection to K prime, the distance is the same. So we can use the midpoint formula. So the midpoint formula says that the midpoint is x1 plus x2 over 2, and then y1 plus y2 over 2. And what we're doing here is our x1 and our x2, we're saying the midpoint of this line, k and k prime. So this will be your x1, this would be your x2, okay, because it's the midpoint of that line. This is the midpoint of this entire line. And this is our y1 and our y2. So it means that this point is the midpoint itself, negative 1 and 2. So in place of that m, that midpoint, I'm saying negative 1 and 2. And that this is going to be equal to, and now I'm going to try and find the coordinates here. x1 is 1 plus x2, which is x. So I'm saying 1 plus x over 2, and then y1 and y2. So y1 is 0 plus y2, which is y. So 0 plus y over 2. Then, in order to find the x and the y value, we're seeing it as this. This is an x value. This is also an x value. And they're both speaking about the midpoint of this line. So we're going to equate those. And then we're also going to equate the y value with the y value. So this means negative 1 is equal to this 1 plus x over 2. And it also means that the 2 is equal to the 0 plus y over 2. So in order to just solve for x, we're going to look at the fact that there's a 2 on the denominator. We can multiply both sides by 2 to get rid of it. So we have negative 2 is equal to, the 2's cancel here, 1 plus x. Then take the 1 over, and so you have negative 2 minus 1, which is negative 3. So x is equal to negative 3 here. And here, we're going to multiply both sides by 2 to get rid of the 2 on the denominator, so times 2. Then you have a 4 here is equal to, the 2's cancel, and you have 0 plus y, which is really just y. That means that y is equal to 4. And there we go. That's the x and the y value. Okay, so of this k prime, the x and the y value, k prime, is really just negative 3 and 4. Okay, so as you can see, that's actually a very long procedure for only 2 marks. So maybe there is a shorter route. I have also tried to look for a shorter route of doing this, but the shorter routes weren't really even working. They actually didn't make logical sense. So if anybody knows of a shorter route, can you actually mention it in the comments just to see if there's actually a quicker way of getting this answer? Okay, so that is the end of question 5, and we can move on to the next question, question 6. Okay, so we are now on question 6, and question 6 says the sketched below graph shows the graphs of f of x, which is negative x squared minus 6x plus 7, and then we have c as the y-intercept of f, a and b are the x-intercepts, and d is negative 5 and k. It's just a point on the graph of f. So the first question is to calculate the coordinates of E for 3 marks, which is the turning point of f. Notice that they have given you the equation of f in standard form, not turning point form. Okay, so if it was in standard form, this is how you'd find it. F of x is equal to negative x squared and then minus 6x plus 7 minus 6x plus 7. In order to find the turning point when it's in standard form, there's 2 methods you can use. You can derive this in order to find the x value of the turning point. You can also use another method. Now, I'm going to use the other method because you may be watching this video again at a point where you have not really learned how to derive yet because you haven't really gotten to calculus yet. So I'm going to use this formula. X is equal to, you can say negative b over 2a. And now, in order to find that x value, we're going to take the b. So x is equal to negative, and then b, as you can see, is negative 6. That's the value of b. So bracket negative 6 over 2 multiplied by a, and a is basically the number in front of x squared. That is actually a negative 1. So x is equal to, that will multiply, or you could just put that all onto the calculator. But anyway, it's going to be a positive 6 over negative 2, which is really equal to negative 3. And that is really just the x value of the turning point. So to find the y value of the turning point, you just take this x value and substitute it back into the original equation so that we can find its y value. So we'll say f of negative 3 is equal to negative bracket negative 3 all squared minus 6 bracket negative 3 plus 7. And this is going to be equal to, I'm just going to put that into the calculator. And when I put that in, I get 16. So it just means that the coordinates of E, the turning point of F, is just negative 3 and 16. Okay, so that is for 3 marks. You see there's an extra step that we took. The next question. Okay, then we have 6.2 saying, write down the value of K. This is a nice, easy question. To find K, all you have to do is you see that this point is on the line and it has an x value of negative 5. So substitute the x value of negative 5 into the equation of f and you will find its y value, which is K. So we can go ahead and do that. We're really just saying f of negative 5 is equal to, so this will give us the value of K as the y value. So I'm saying K is equal to, and put this onto the calculator and let's see what we get. And we get 12. So K is equal to 12. Moving on to the next question. Okay, then 6.3 says, determine the equation of the straight line passing through C and D. Okay, so a straight line is passing through C and D. So we have some sort of line and passes through C and D. Because we have 2 coordinates on this line, we can find its equation. So to find the equation of this line, we just need the coordinates of C and D. So C is the y-intercept of the graph of f. You see, it was put in standard form. When it's put in standard form, it's really in the form of f of x is equal to ax squared plus bx plus c. The value of c here is this, and that is your y-intercept. So as a coordinate, this coordinate is the x value of that will be 0 because at the y-intercept, the x value is always 0. And then the y value is literally that 7 because it's in standard form. So 7. So that's what we can take from that. Okay, so we have these 2 coordinates now. We have D, we have C. So let's put them down and find the equation of that line. So C is the 0 and 7, and then D, of course, is the negative 5, and K, which is now 12. So we're finding the equation of the line passing through these 2 points. First, we need the gradient. So we find the gradient by saying y2 minus y1 over x2 minus x1. So I would actually just put them under each other. It's easier like that. I'm going to take that as my y2. So I'm saying 12 minus 7. So 12 minus 7 over x2 minus x1, negative 5 minus 0. And so let's see what this gives us. 12 minus 7 is 5 over negative 5 minus 0, negative 5. So our gradient here is negative 1. Now that we have the gradient, I'm going to use the short equation of a straight line to find the equation of this line. You could use y is equal to mx plus c, but I personally just like to use y minus y1 is equal to m bracket x minus x1. So we know what the gradient is. We know that the gradient is negative 1, and we only just need one more point. So I'm going to take an easy point like c. I'm going to use this as x1 and y1. So that is going to be the coordinates for that. So we're saying y minus y1, which is 7, is equal to m, which is negative 1, bracket x minus x1, which is 0. And so this is going to be equal to, we're saying y is equal to, now I'm already taking in account that I'm going to take the negative 7 over. So I'm saying y is equal to, and let's just multiply this negative in. Negative 1 times x is negative x. Negative 1 times negative 0 is just 0. And then this negative 7 comes over and becomes a positive 7. So this is the equation of the line passing through C and D. You can use y is equal to mx plus c. It will just take a bit longer. Okay, moving on to the next question. Okay, then 6.4 says a tangent parallel to CD touches F at P. Determine the coordinates of P. Okay, so we have the graph of F, right? Then they're saying that there is a tangent parallel to that line CD. CD kind of was like that. So there is some tangent parallel to this line, meaning slanted in the exact same way. So I'll really just copy this line out and paste it over here, but let me change its color. So let's say it is red. So this line is going to pass, it's going to be a tangent to the graph of F. A tangent only touches a curve once. So let's say that is the tangent, it's touching it there. And they're saying that it is parallel to CD. So here we see it's parallel to the line CD. And that it touches F, okay, this graph of F at P. So let's say this over here is that point of intersection P. Okay, so I noticed that I made a mistake in the equation of F. The equation of F has an A value that is less than 0. So that parabola is supposed to be concave down. So you can still follow this explanation. It's still correct. But just remember the graph is actually supposed to look like this. But the explanation is still the same. So I just made a mistake with that F. It's supposed to be concave down. We have to determine the coordinates of P. Okay, what we know about this is we know the equation of F. The equation of F is f of x is equal to negative x squared. And let me just check that again. Negative x squared minus 6x plus 7. So we know this. And we also know the equation of CD. The line of CD is y is equal to negative x plus 7. So this y equals negative x plus 7. What they want us to find is this P, this point of intersection of your graph and this line. And just remember, we don't know the equation of this line. So this is just proof that because this was a June paper, of course, it is a supplementary paper for people who were rewriting. So they definitely expected you to know calculus at this point. You need calculus to actually solve this. So what we're going to do is, in order to find the point of intersection, because we're not really given a lot of information about this line, except that it is parallel to CD, it means that what we know about the line is that we know its gradient. We know that if it's parallel to CD, it has the exact same gradient as CD. So here, the gradient is negative 1. The gradient will also be negative 1 here. Since we know the gradient of the line and we know the equation of the curve, what we can do is find the gradient of this curve. In order to find the gradient of this curve, you have to derive it. So we're going to say f prime of x is equal to, and let's derive this. We're saying the invisible negative 1 here multiplied by the 2, which is negative 2, and then we have x. Then we have to take the 2 and subtract 1 from it, which gives you 1. But you don't have to write that 1. So it's like that. Then we have minus 6x. So minus 6. And what happens with the x is the x has a natural exponent of 1. We have to subtract 1 from that exponent. But if you say 1 minus 1 gives you 0. So this is x to the power of 0. Anything to the power of 0 is 1. So negative 6 multiplied by 1 just stays negative 6. So when we derive this, this is what it gives us. Remember, when you derive a curve or a graph, you're really finding the gradient at any point. So it's kind of like the equation of the gradient. So if we know that the gradient of the parabola is this, but we know that the points that we're looking for, it's on this tangent who has a gradient of negative 1. What we can do is equate the gradient of the parabola with the gradient of the tangent, so that we'll be able to find out exactly where this parabola has a gradient of negative 1. So we're saying f prime of x, and we're equating it with m. So negative 2x minus 6 is equal to negative 1. And we can go ahead and say negative 2x is equal to, I'm taking the 6 over. We have positive 6 minus 1, which is 5. And so divide both sides of the equation by negative 2. And so this gives us x is equal to negative 5 over 2. Okay, now that we have the x value, this is the x value of this point, because only at this point would the gradient of the parabola be equal to negative 1. That's why we equated those two. To find the y value of this point, you would just take this x value and substitute it into the original equation of the parabola, which is f of, so I'm saying negative 5 over 2 is equal to negative, bracket, negative 5 over 2 all squared, minus 6, bracket, negative 5 over 2 plus 7. And you can go ahead and put this all into the calculator and see what you get. And I get 63 over 4. Okay, so it just means now that that point P is just negative 5 over 2 and 63 over 4. Just be very careful when you're putting in the numbers into the calculator and just check that everything is correct. Okay, so that is 6.4. Moving on to the next question. And then the last question for question 6 says, for which values of x will f of x minus 12 be greater than 0? Okay, sometimes when this is put like this, you can actually rewrite this. So instead of saying f of x minus 12, you can take the negative 12 over. And so we have is greater than 12. So we just have to now find out which values of x will f of x be greater than 12. And please note that when they say f of x, they refer to the y values of the graph of f. Okay, so let's go ahead and see where this will happen on the graph. So you see on the graph, we already had, let's see which y value has 12. So you see k is equal to 12 here. And that's where we had the x value being equal to negative 5. So if your x value here is negative 5, I think I can remove that now. So this is negative 5 and 12, right? So it means that we're trying to look for places on the graph where the graph is greater than 12. That's where f of x is greater than 12. In other words, you're looking at this graph, and if this over here, if its y value is 12, so that y value is 12. We're looking for places on the graph where the graph has y values greater than 12. Okay, so greater than 12 would be everything above here. So we're only going to take parts of the graph that are above this line of 12, of y is equal to 12 here. So this would be this point over here, that point over there, that point, even extending to these ones, that point and that point. So you see that it will be everything that is here, everything above here. That's all we're taking, because those would be the parts of f that have y values greater than 12. So let's map this down to the x-axis and see what the x values are. So mapping this first point over here down to the x-axis, this would be, at this point you see that the x value is negative 5 where the y value is 12. Okay, so at this point we have negative 5 here. And if we map this down, so we actually have to find that. So this is actually something we need to find. You see, a parabola is symmetrical on both sides. So Here we have another y value of 12 and we need to find out exactly which x value that belongs to. Okay, so I'm looking at this and I'm seeing two ways of actually doing this and it will still be fine. You could go ahead and take y, right, and substitute in place of this equation. We can go ahead and find out where is y equal to 12 by taking 12 and putting it in place of f of x, meaning in place of y. Then you have to solve for that equation you're going to get. You're going to get two x values. You're going to get one for -5 and one over here. But then there's an easier way of doing this. And let me just see the mark allocation of this question. This question is only worth, 2 marks. So you definitely don't have to go through that long step. There's a quicker way of doing this. The quicker way of doing this is the fact that we know what E is. E is the turning point. And we know that the coordinates of E, we already found that. Coordinates of E is -3 and 16. Okay. So the fact that this is -3 and 16 is going to help us a lot here. So we know the x value. The x value of this is -3. So -3. Remember when I said that the parabola is symmetrical about its turning point? So it means that whatever the graph is doing over here, the graph will do exactly the same over here. Okay, so now that we know what the x value of the turning point is, see that because -5 is the x value that belongs to the y value of 12, we'll be able to find the other x value that also has a y value of 12, like this. Remember, the parabola is symmetrical through its turning point, meaning whatever the graph does on this side, it does the exact same thing on this side. So this is how we can find it. You see, from -3 all the way to 5, what did we do? -3 to 5, you must have said -3 minus 2, and then you got to 5. And it makes sense because we're moving to the left. So you subtracted by 2 to get from this middle to this point. So in order to get this one, okay, which also has a y value of 12, you would have to also do the same thing, but we're moving to the right. So instead of saying -2, you would say +2. Okay, so from -3, if you say -3 plus 2, that's going to give you -1. So that is the x value of that point. See, so you don't have to go through that long way. Check the mark allocation to see if there's a shorter route. Okay, now that we know what exactly that x coordinate is, we can answer them. So we're only speaking about all this highlighted part. So if you map it down to the x-axis, you see this point over here, that's its x value, that's the x value. If you map all of these down to the x-axis, we're going to find now what the inequality here is going to be. We are saying that our solution is x needs to be what than -5. Okay, so the values that we have here, these blue lines, they are values that are greater than -5. So we're saying x is greater than -5. And then when we compare this with -1, which is another endpoint. Okay, so when we reach here, look at the values that we have, the blue lines. These are values that are what than -1. These are values that are less than -1. So or x needs to be less than -1. But the good thing is that you see that they're pointing towards each other. So they're speaking about the same set of values. So we can actually write them together. We can say that x is greater than -5. See, greater than -5, but less than -1. Less than -1. And that will be our solution. And you see, the minute they see that you got -1, you didn't have to go ahead and start calculating all of that. You can if you want to, but I just feel like it's going to take so much longer for something that's just 2 marks. Okay, so in this, really my only calculation, I'll just show them how I got that -1 by saying -3 plus 2, using the fact that, you know, the turning point is over there. So in order to get that x value, I just said the -3 plus 2, which was -1. And then I'll just conclude and say x needs to just be greater than -5, but less than -1. And that's all. So if you did it a long way, you will still get your marks, but in the exams, you're really just trying to save as much time as you can. So in this video, we're going to be working on question 4 and question 5 of the Gauteng 2022 paper 1. So the first question in question 4, 4.1, we are first given f of x is equal to 8 over x minus 2 plus 2. And we are told to write down the domain of f. So for a hyperbola, the domain is always going to be x is an element of real numbers, but x will not be equal to a particular number. X will not be equal to the x value of your vertical asymptote. And that would be it. So where we have x minus 2, our vertical asymptote, or the value of p would be equal to 2, meaning the equation of your vertical asymptote is x is equal to 2. Because an asymptote is a line that the graph will never pass, then we will not have x values of 2 for this graph. So the domain of this graph is x is an element of real numbers, but x is not equal to 2. And so you can think about it like this. So here is your vertical asymptote. It's this vertical line, and it will be passing the x-axis at 2. And that's your horizontal asymptote. So we're just looking at all the possible x values of this graph. So as you can see, this graph, look at a point over here. Point over here will have an x value of that. Point over here has an x value of that. And it keeps having x values for everything really. But then when we get to 2, it doesn't have any x value here because there's an asymptote. And then after 2, it will have an x value somewhere up there. There, it has an x value after 2. And still here, still has an x value after 2, and it will keep having x values for everything, positive and negative numbers, except for 2. Okay, so that's it for 4.1. Moving on to the next question. So the next question, 4.2, is to calculate the y-intercept of f. Remember, when you're trying to find the y-intercept, all you have to do is just make x equal to 0. And that's what we're going to do here. So we have f of x, but in place of x, I'm going to put 0. So this is now f of 0 is equal to 8 over 0 minus 2 plus 2. And so f of 0 is going to be equal to 8 over 0 minus 2 is negative 2. So that's 8 over negative 2. So 8 divided by negative 2 is negative 4 plus 2. Negative 4 plus 2, that's like saying positive 2 minus 4, which is negative 2. So f of 0 is equal to negative 2. And I'm just going to go ahead and leave it like this because they didn't really ask for the coordinates of the y-intercept. Okay, moving on to the next question. So 4.3 says calculate the x-intercept of f. So the x-intercept, we will find that simply by just making y equal to 0. So let's take our equation and make y equal to 0. So f of x stands for y, so we're going to make that equal to 0. So we're saying that 0 is equal to, and we'll have 8 over the x minus 2, and then we have, of course, the plus 2. And now in order to solve for x, we can take 2 over. When you take 2 over, it becomes negative 2 is equal to 8 over x minus 2. And then now, because you have a number here, and an equal to sign in between them, first of all, we can start by making this a fraction by putting it over 1. Then we're going to cross multiply. So we're going to say the 8 multiplied by 1, or 1 multiplied by 8, that gives you 8. And then we're going to also just say the negative 2 multiplied by x minus 2. But remember, the negative 2 has to multiply into the x and the negative 2. So I just like to write it as negative 2 bracket x minus 2 at first. Now, in order to solve for x, you could FOIL in, but you could also just get rid of the negative 2 so you can get closer to the x. So we can divide both sides by negative 2. And so 8 divided by negative 2, that's going to give you a negative 4. And that is now equal to, that cancels, and we have x minus 2. Then we can take the negative 2 over, and so it becomes a positive 2 minus 4 being equal to x. And so x is equal to 2 minus 4, which is negative 2. And so that is the x-intercept of f. And then question 4.4 says, sketch the graph of f, clearly indicate the coordinates of the x and y-intercept as well as the asymptotes. Okay, so in order to sketch graphs, I like to use steps, and I just try to keep these steps consistent. So first, we're going to look at the shape of the graph. The shape of this graph depends on the value of a. So remember, the equation of this function is this, and so it's really in the form of y is equal to a over x minus p plus q. So the value of a, as you can see, is a positive number. It's 8. When a is positive, it means that your graph, since a is positive, your graph is going to lie in the first and the third quadrant. So that we know about the shape of the graph. And then the second thing we can look for are the asymptotes. So when we're looking at the asymptotes, remember we have a horizontal and a vertical asymptote. This one, the P, will be your vertical asymptote. So the equation of that is going to be x is equal to, so it's not going to be the -2, it's like taking the -2 over an equal to sign. So it becomes x is equal to 2. That is your vertical asymptote. Then the horizontal is just y is equal to whatever number is there. So that's just a +2, we leave it as that. So those are the equations of our asymptotes. X is equal to 2 and y is equal to 2. Then the third thing we just have to look for is our intercepts, x and y intercepts. And we know that the x-intercept, we already found that it's actually the same thing really. So the first one, the x-intercept is -2 and 0, because it has to be as a coordinate, -2 and 0. And then the y-intercept was also a -2. But as a coordinate, the x value is 0 and the y value is -2. So that is 0 and -2. And now that we have everything, we can just sketch it down. Okay, so for the graph, I'm just drawing a Cartesian plane that is just going from -5 to +5 on the y and the x-axis. So that's our x-axis and that's our y-axis. And so first, what you can do and what is much better to do at first is to put down your asymptotes. So we first have a asymptote of x is equal to 2. That is the vertical asymptote. So the vertical asymptote is just a vertical line going down like that. And I'll put that in blue. And so here's our vertical asymptote. Also just make sure it is going on as well to infinity. Also just make sure to label it. The equation of this line is x is equal to 2. Okay, because it has an x value of 2, but it has multiple y values. And then we're going to also label the horizontal asymptote, and that one is y is equal to 2. So that would just be a horizontal line passing the y value of 2 on the y-axis. So here is our horizontal asymptote, and the equation of it is y is equal to 2 because it has a y value of 2 but multiple x values. And then we can put down our intercepts. So the intercepts we have -2 and 0. So -2 and 0 is an x-intercept. And we could just go ahead and put that here, -2 and 0. And then we have 0 and -2. So that's 0 and -2. That's a y-intercept. Now all we're going to do is just draw this graph. Remember that because a is greater than 0, your graph is going to lie in the first and the third quadrant. So it's going to lie in this quadrant and this quadrant. So when we draw this graph, it's going to come from the asymptote, close to the asymptote, and then it's going to pass the x-intercept, then the y-intercept, and then it's going to move down, moving closer and closer to this asymptote, but it will never touch the asymptote. So something like that. It's just going to keep moving down like that. And here it is going to be coming from this asymptote, being very close to this asymptote. So that's just a part of the graph that lies in the third quadrant. The one that lies in the first quadrant, you can, if you want, you can substitute an x value like 3, for example, into your graph just so that you can see the y value and then sketch that. But it's not really necessary. You know that if this looks like that, then this one is obviously going to do something like that. So something like that. Okay, so it doesn't have to look perfect. It just has to make sense and have the points that it's supposed to have. So there's checking the shape of the graph that you put your intercepts, your asymptotes, and the equations as well. It's always important to label the equations of these asymptotes. And also, just because this graph is called f, I will just label it f. Okay, moving on to the next question. Then question 4.5 says, if y is equal to -x plus k is an equation of the line of symmetry of f, determine the value of k. So if this equation is the equation of the line of symmetry of f, So just remember, f is a hyperbola, and so it has two lines of symmetry. It has a line of symmetry with a positive gradient, so this one is an increasing function. So you see that as we move from left to right, the graph is increasing, so its gradient is positive or greater than 0. And then it has a one with a negative gradient where it is a decreasing function, so the gradient is less than 0. As you can see in this equation, y is equal to negative x plus k. It is in the form of the general equation of a straight line, which is y is equal to mx plus c. So you can see that the gradient, okay, is actually -1 in this case. So this is the equation of the line of symmetry with a negative gradient. That's what they're referring to. So we just need to find the value of k. What exactly is its y-intercept? Okay, so we have to find the actual equation of the axis of symmetry with a negative gradient. So to remember this, just remember that this is how this works. The axis of symmetry, let me actually draw it in this hyperbola. So with the axis of symmetry, there are dotted lines as well because it's an axis of symmetry, but I'm going to just use a straight line. So it's a line that is going to pass this middle, this intersection of your asymptotes. And then that is the positive one. So I'm only drawing the positive one so that you can see how to come up with the negative one's equation. So if this one's equation is actually just y is equal to, and then we say x minus p plus q. And it's actually easy to remember as long as you remember the general form of a hyperbola as y is equal to a over x minus p plus q. See that x minus p plus q, that's exactly how it looks. This one is just y is equal to x minus p plus q. That's the one with a positive gradient. Then the one with a negative gradient is going to be decreasing, and then it's going to look like this. It's also going to pass this point of intersection. So that one is going to look like this. It is y is equal to the one with the negative gradient. It is y is equal to, and all we do is we put a negative in front of the x minus p. So negative bracket x minus p and then plus q. Then you can go ahead and multiply that negative in. And so it's going to be negative x plus p plus q. That is the equation of that axis of symmetry, or that line of symmetry. So that is the equation. If we know it's y is equal to negative x plus p plus q, then as you can see, all we need to know is the value of p and the value of q. The value of p and q can be found in your asymptotes. You can even use the actual equation of the hyperbola. So here, the value of p is your vertical asymptote. P is equal to positive 2. So remember, I know it is a negative here, but you must always take it's kind of like multiplying it by -1. Always take it as if you're taking it over an equal to sign. And then q is equal to whatever this is. It's just a positive 2, so that is positive 2. So since p is 2 and q is 2, all we're just saying is y is equal to negative x plus 2 plus 2. That's all we have here. So y is equal to negative x and then plus 4. So as you can see now, it's in the same form as this equation. And so it means that k is equal to positive 4. Okay, so sorry for that long explanation, but it was just for you to remember in case they ever ask you for the one with the positive gradient as well. Okay, moving on to the next question. So 4.6 says, determine the equation of the graph which is formed if f is shifted 3 units to the right and then reflected across the x-axis. Okay, so there are some translations happening to f here. First of all, f is shifted 3 units to the right. Okay, when a graph is shifted 3 units to the right, let's look at the equation of f first of all. So if this is the graph of f, when a graph is shifted to the left or the right, that affects the x value. Okay, so that is going to affect that x value. And really all the x values of this graph is going to shift 3 units to the right. And so how we apply that on the equation, this is really what I'm saying here. I'm saying that the new graph, first of all, we have f shifting 3 units to the right. So we have x here first of all. When a graph is being shifted to the right, it's not going to be a plus when you're applying it to the equation. It's going to be a minus, and this only applies to the x. So it does not apply to moving the graph up or down, which affects the y values. Only applies to when you move the graph left or right. So right movement is minus. And so because it's moving 3 units to the right, we're going to say x minus 3. Okay, and let's see what happens when we do that. So we're still going to have 8 over, and then we have x. And then now we're going to have a minus 3. You can put the minus 3 here, or even after the negative 2 is still fine. So I can say minus 2, then minus 3. And then we still have plus 2. Okay, so long, this new graph, f of x minus 3, so long, just looks like this. 8 over x, negative 2 minus 3 is negative 5 plus 2. That's what the shift 3 units to the right looks like. First of all, this is what it does to the graph. Okay, so take it step by step. So we've done that now. Now the second thing they say is that it's then reflected across the x-axis. When something is reflected across the x-axis, imagine it like this. You have a graph like this. If it's reflected across the x-axis, then it means that it's going to form a mirror image here. So it's going to look like that. So if you notice, looking at this black graph and looking at this red graph and see what happened is that here we still have all the same x values for the black graph and for the red graph. The x values did not change. What changed was the y values, because this graph had these y values, positive y values. But now when it's reflected, look at the y values it has. It has negative y values. So when you reflect a graph across the x-axis, it causes the y values to change. Okay, and how we make it change, because you saw that the other ones were positive and then the other ones became negative when we reflected it. You really just multiply the y values by -1 or by a negative. And so looking at this equation that we have, what represents the y values? Just like we have f of x represents y. Okay, it's the same thing as saying y is equal to 8 over all of this. So since this represents y, what we're going to do is we're going to multiply a -1 to the y. So we're multiplying -1 to the y values, but we're not multiplying it to this original equation. Remember, we are working on this one. After translating the 3 units to the right, we need to change all the y values to become negative. So it's like taking this and we're multiplying it by a -1. We're taking f of x minus 3 and we're going to multiply this by -1. So see this as becoming a negative f of x minus 3. Now, what represents f of x minus 3? It is this equation, this current equation here, 8 over x minus 5 plus 2. That is equal to f of x minus 3. So this is all we're doing. We're putting a negative, and then in place of f of x minus 3, we're going to put this equation. As you can see, this equation has 2 terms. This is the first term, and this is the second term, because terms are always separated by plus and minus signs. So all we're going to do is put brackets, and we're going to put 8 over x minus 5, and then we have the plus 2. Then this negative is going to multiply into this. So if it multiplies, the -1 can multiply into the 8 instead. So that becomes a -8 over x minus 5. Then the negative multiplies into the +2, making that -2. So this is your new equation. So if I'm writing the equation as a whole, like what is the subject of this equation? Remember, we made this negative, because this is really it. We made this, we multiplied this by negative, and we shifted the graph 3 units to the right. So it's really negative f of x minus 3 is equal to -8 over x minus 5 minus 2. And that's the last question for question 4. And now we're moving on to question 5. Okay, so now we're on question 5, and question 5 says the graphs of f of x, which is equal to 2 bracket x plus 1 all squared minus 8, and g of x, which is equal to 1 over 2 all raised to the power of x, are represented in the sketch below. P and Q are the x-intercepts of f, so here's P and Q, and R is the turning point of f. Then we have a point A, which is -2, and 4 is a point on the graph of G. And the first question, 5.1, says, write down the equation of the axis of symmetry of F. Now, the axis of symmetry is a line that cuts the graph into two perfect halves. Or you can also see it as it's a line that cuts the graph in a way that they look symmetrical to one another when looking at them between this line. So when looking at the parabola is always symmetrical about its turning point, but the x value of its turning point. So here, if this was the x value of the turning point over here, you will notice that this part of the parabola is going to look exactly the same as this part of the parabola. It's like this is a mirror. And so if we have this part of the parabola, when we see the reflection of it, it's going to look exactly like that. So it's symmetrical about that turning point, but the x value. And so we have to find the x value of the turning point. So the x value of the turning point is, as we can see here, this is put in turning point form. It's put in the form of y is equal to a bracket x minus p all squared plus q. And so p and q will always be your turning points. But notice this said minus p, but here I put a positive p. So that the p always changes its signs. So if we have a positive 1 here, this needs to become a negative 1. And the negative 8, it will just stay the same. Like this is positive q, that's also positive q. So that is what we're going to have there. But this is our x value of our turning point, and that's what we have to focus on. Also notice that they said they want the equation of the axis of symmetry. The equation of that line, since we know this is its x value, negative 1. The equation of this line, it's a vertical line, will be x is equal to negative 1. Okay, so moving on to the next question. So the next question, 5.2, for 1 mark, they want you to write down the coordinates of R, the turning point of F. So the coordinates of R would just be, as we have seen here, this is the turning point. Since we have negative 1 here, the Q value is just whatever is here, okay? And it's negative 8, so we take it like that. So the coordinates of R are just negative 1 and negative 8. So 5.3 says determine the coordinates of P and Q. So remember that P and Q are your x-intercepts of your parabola. In order to find the x-intercept, just make y equal to 0. So this is the equation of our parabola, so write that down. And we're just going to make the y value equal to 0. So we're making this 0, and then it's equal to 2 bracket x plus 1 all squared minus 8. Now, I know many a times in order to solve for this, we go ahead and just expand this, but this takes long and then it leads to factorization. There's a way you can simplify it without having to factorize anything. So we're going to take, first of all, this negative 8 over to the right hand side, and so it will become a positive 8. So 8 now is equal to, then we have 2 bracket x plus 1 all squared. Remember, we're just trying to get to the x. So what is stopping us from getting to the x? The first problem we have is this 2 before the 1. The 2 is a problem. So we can divide both sides by 2, and then 8 divided by 2, that is 4, is equal to, that's gone. Now we have x plus 1 all squared. Okay, now that we have that, we just have to solve for x. To solve for x, the squared is blocking us. So we need to get rid of the squared by square rooting both sides. So if we square root both sides of the equation, you just have to remember this one last thing. In front of the number, you need to put plus and minus because you're square rooting. The positive and negative answer for that will work. So you have to take plus and minus. And so the square root of this, we're going to have positive or negative. Square root of 4 is 2, is equal to, then we have x plus 1 without brackets. And then all we have to do now is take the 1 over to solve for x. If you take the 1 over, it will become a negative 1. I advise that you put the negative 1 in front of this plus minus. So it's negative 1 plus or minus 2 that is equal to x. And there, so now we can now conclude. We can say that x is either equal to, so it's first the negative 1, then we can choose the plus first, so plus 2, or x is equal to, again, the negative 1, and then now we choose the minus 2, so minus 2. And so we're going to get x is equal to negative 1 plus 2 is like saying 2 minus 1, positive 2 minus 1, which is 1. And then x is equal to, or x is equal to negative 3. So those are the x-intercepts. But remember, they want it as coordinates. They want coordinates of P and Q. So we need to also label them. So let's just look on the graph to see, since this is positive 1 and that's negative 3, it would mean that since this one is negative, that's the negative 3, and that one is the positive 1. Okay, so it means that P is therefore negative 3 and 0, and Q is 1 and 0. Okay, so just make sure to conclude if they say coordinates. Then moving on to the next question. Then 5.4, for 2 marks, we have determine the equation of g to the power of negative 1, the inverse of g in the form of y is equal to. So to determine the inverse of the equation of g of x. So this is an exponential. Since this equation is 1 over 2 to the power of x, I'm just going to write it in the form of y first. So y is equal to 1 over 2 raised to the power of x. To find the inverse, first swap the x and the y. So in place of x, I'm going to put, in place of y, I'm going to put x is equal to, then we have 1 over 2. And then in place of this x, we're going to put the y instead. And then now you have to make y the subject. So that's only 2 steps. Swap x and y, make y the subject. In order to make an exponent the subject, you have to use log. So we're going to say y is now equal to, and we're going to say log of the base that we have is 1 over 2. The base is always the number carrying the exponent. So log the base is 1 over 2. And then in here, in the brackets that will be here, we're going to have the x. But you don't have to put it in brackets. You can just say x. Okay, so that is the equation of that in the form of y is equal to. That's the inverse. Then we have 5.5 saying, sketch the graph of g of the inverse basically in the answer book. Clearly indicate the intercept with the axis and at least one other point. So when they're asking for these things, there's hardly any calculation that needs to be done because they're specifically asking for one other point. If you look at the way this graph looked, the exponential function, it had one point. The point it had was the negative 2 and 4. Now when you have an inverse graph, the inverse just swaps. All the x and the y values swap. So the x values become the y values and the y values become the x values. So this point A, when it is on your inverse, it's going to say 4 and negative 2. That's the other point that we have. Then the intercepts that it has. We're going to have to think about what intercept does this original graph have. So as you can see, it doesn't have any x-intercept. This graph doesn't have any x-intercept. It only has a y-intercept over here. So really all we have to find is that y-intercept. And so to find this intercept, if we make x equal to 0, so as you can see, x is the exponent. So if we had 1 over 2, and now we made that x value equal to 0 so that we can find the y-intercept, then we will find that this is going to be equal to 1 because anything raised to the power of 0 is 1. So that is 1. And that's something you're going to notice about these graphs that have a horizontal asymptote of 0. These exponential graphs, their y-intercept is usually going to be 1 when it is above the asymptote. So think about it like this. If this coordinate over here is 0 and 1, and we also have this coordinate A, then all we have to do is on the inverse swap these values. So it means that on the inverse, the intercept we will have will not be a y-intercept because this will swap. The inverse is going to have 1 and 0 instead. And so it's going to be an x-intercept. So that's the first point we have on our inverse. We have 1 and 0. And then the second point is, of course, the swap of this one. So it will be 4 and negative 2. So I'm going to just call that A prime just to show that it is the image of A. So it's going to be 4 and negative 2. Okay, so that is the intercept that they're referring to and the one other point. And now we have to actually sketch the graph. Okay, so now that we have the coordinates down, let's just see what the x and the y-axis is going to look like. Okay, so now I just want to see what my y-axis is going to look like. Just plan this out so that at least the graph will be neat So we can just start at, since we have 0, we have -2. Those are the only y values we have, meaning the smallest y value is -2. So I'll stop at like -4. And then the biggest y value is 0. I can just stop at 2. That's okay. And then for my x values, I will start at, so the smallest one is +1. So I'll start at like -1 and then end at 6. Just so I can go a bit further than what 4 is, and it will just give the graph a bit more form and shape. Okay, it is best to start drawing the y-axis because it just helps you to know exactly where on the page is going to be, and it's just less erasing. Okay, so I'm starting with the highest value so I know where to stop. So 2 going down. Okay, and then, you know, on your page, you'll just be able to erase all of that because you see you don't need that. Okay, so the y-axis is done, and then the x-axis. Okay, and then I'll shorten it a bit. And so this is our x-axis. Okay, so this is what the Cartesian plane looks like. So now we can just plot down the points. So that was just for the axis. Okay, so the first point we have 1 and 0. So I'm going to put 1 and 0. So there we have that x-intercept. And then we have 4 and -2. So 4 and -2 over there. 4 and -2. So I put that coordinate down because it's not an intercept. With the intercept, they will know what that is, but you can also write it down as 1 and 0. And then now this is how to draw this graph. You have to look at this one, and you can actually use your question paper to practice on how your graph is going to look. Because you know where these points are. These points are over here. We have 1 and 0, and we have 4 and -2. You can also just try to put points like that on here as well. Okay, so here are the 2 points that we have. And so to draw this graph, all we're going to do is look at the way this one is. Since this one is the inverse, it's really just going to do not the opposite. It's going to do the exact same thing that it's doing here, but instead, what it's doing on the x-axis here, it will do on the y-axis here. And what it's doing on the y-axis of the original graph, it will do on the x-axis of the inverse. Okay, so now to see what it is doing, let's look at the G graph. Okay, not the inverse first. So this one, as you can see here, let's use a point that we have. Over here, this point, okay, has a negative x value. And the y value is positive. So this one will have a negative y value, and its x value will be positive. So that's what's going on here at this point. It has a negative y value with a positive x value. And then over here, this graph starts to decrease. It starts to move down. As it is decreasing, notice that the x values are moving towards the positive part of the x-axis. So this graph, the inverse, will also start to decrease. And then the y values will be moving towards the positive part of the y-axis. So it's going to do this. And as you can see, this one gets closer and closer to the x-axis. And then the red one will get closer and closer to the y-axis. So it's going to look like that. It's going to slope like that and move closer and closer. So that's what I mean by it's not doing the opposite. What it's just doing is what this one is doing on the x-axis, the inverse will do on the y-axis. And what this is doing on the y-axis, the inverse will do on the x-axis. So that's how this graph is going to look. It's going to come from the top and it's going to slope down. So always use your original graph to practice. So it's going to come from the top and slant down and move closer and closer to the y-axis, but it will never touch the y-axis. So it's going to do something like this. So it's shooting up here and then it's moving closer and closer to the y-axis. Okay, so that is the graph and you can label it G-1. Okay, moving on to the next question. So the question 5.6 says, for which value or values of x is the inverse greater or equal to -2? So remember when they're talking about the inverse, they're referring to the y values of the inverse. If they say g of x, it's y values G-1 of x. That is still the y values of the inverse. So the only reason they'll be giving you -2 is because you have that point on your inverse. So if you look on the inverse, you see we have -2. They want to know for which values of x it's either going to be greater than negative 2 or equal to negative 2. So let's talk about where it is equal to negative 2. So where does it have a y value equal to negative 2? So over here, where the x value is equal to 4. Okay. Then they also want to know where is it greater than negative 2. Where are the y values of this graph greater than negative 2? So here is the y values that are greater than negative 2. It'll be everything that is here. So as long as the graph has y values that are greater than negative 2, we will take them. So this will be the y values we'll take on this graph. We're going to take everything that has a y value greater than negative 2. So that will be everything here that has y values greater than negative 2. Okay, it's negative 2, everything with y values greater than negative 2. And now we're going to find out what are the x values that belong to this part of the graph that has been highlighted. Well, to find out the x values, the first x value we have is 4. Okay, so that is where the graph itself has a y value of negative 2. So it's first here. And then if we keep going, look at how these y values look. It's here, it's here. So we can compare to 4. These are values that are what than 4. These are values that are less than 4. And we keep going. It's still values less than 4, still values less than 4. And we keep on moving on this graph. But then you will notice that it will not go past the y-axis because the y-axis is now an asymptote. So on the original graph, you would have noticed that we had a horizontal asymptote here. Okay, so if I erase all of this, we had a horizontal asymptote of y is equal to 0, okay, on the x-axis. But in the inverse, whatever the x's are, they become the y's. So now instead of a horizontal asymptote, we have a vertical asymptote of x is equal to 0. So that really just means that we will not have any x value that is 0. Okay, the x values will never be 0, and also it will never go past these x values. So this graph will not exist for any x value that is smaller than 0 or equal to 0. So it's really just going to stop here. It's going to be between 0 all the way to this x value of 4. So as an inequality, what's going on is that we have x values that are greater than 0 but less than or equal to 4. And it's equal to 4 because they asked for greater or equal to negative 2. Okay, and the x value that has a y value of negative 2 is 4. So this is the inequality. It's where x is greater than 0 but not equal to 0 because there's an asymptote there, but less than or equal to 4, of course, because they ask for greater or equal to negative 2. That would be your inequality there. Okay, so that's just our answer there. X needs to be greater than 0 but less than or equal to 4, and that would be the answer for that first one. And then the last question is 5.6.2, for which values of x is x multiplied by f of x less than 0. So this is really what they're saying. For which values of x will the x values of f of x multiplied by the y values of f of x be smaller than 0? So to find this, you have to think about what kind of numbers do you have to multiply together that will give you numbers that are smaller than 0, or let's say numbers that are negative, because that's what smaller than 0 means. So if we think about that, if you take a positive number and you multiply it by a negative number, you're going to get something smaller than 0. So this is where I'm saying that the x values could be positive and the y values could be simultaneously negative, and then we'll have a negative answer. Also, the x values could instead be negative multiplied by the y values being positive, and we would also have a negative. And now we just have to find this on the Cartesian plane. So because we're talking about f, we're going to look at the parabola. Okay, because we're speaking about f, let me just highlight f so we can only focus on f. Okay, so here is the graph, and remember this is really all we are looking for. So I've just written it down, and I'm going to put the positives in pink and the negatives in blue. Now, this question is actually one of the simplest types that they can ask you, because with these ones, you really just get to focus on certain axes or certain parts of the axes that we have. So since the first one we have to find is this, we have to find out where are the x values positive and the y values negative. Okay, first of all, let's focus on the axes that have these. So where is the positive part of the x-axis? So where on the x-axis do we have positive values? That would be over here. And then we have to find out where do we have negative y values. So we're looking for y values that are negative. So on the y-axis, these parts have negative y values. And now all you have to do here is state which quadrant this is in. This happens in the fourth quadrant. And then highlight where you see the graph. The graph is over here in the fourth quadrant. This is the only place that the graph exists, in the fourth quadrant. Now we just have to state the values of x for which this part of the graph exists, this. Okay, but just remember the x value of q was 1. We found that x-intercept already. We also found this one as -3. Okay, so this is all we're going to do. We're saying the y values multiplied by the x values. So negative y values, positive x values. Now, the reason we cannot take this, like the one that is on the y-axis, is because over here, this y value may have a negative number. But the x value belonging to this has a value of 0. So imagine what's going on here. We need to find where if you take a y value and you multiply by the x value, it's going to give you a negative number. But over here, the y value is a negative number. We can see that. But multiply by the x value is 0. That would not give you a negative number. That would give you 0, because anything times 0 stays 0. So I just want you to notice that we're not going to take the actual x value of 0. We cannot say x is equal to 0. But yes, we know 0 is a starting point. So we see that this part of the graph, the one that is highlighted in dark green, sort of a color, so that is going from where x is greater than 0. So we can actually just point it out like this. It's where x is greater than 0 but less than 1. And I can also not say less than or equal to 1. And this is the reason why. At 1, the x value of this may be a positive number. But the y value at this point, at q, the y value is 0. So if I multiplied it by a y value of 0, I would get 0, not a negative number. So I also cannot take the actual x value of 1. So the values of x for which this part of the graph exists is going to be where x is greater than 0, but less than 1. So that's the first one that we have. We found this one. Okay, then we also have to find the other one as well, where the x values are negative and the y values are positive. Okay, so where are the x values negative? On the x-axis, the part of the x-axis that has negative values are over here. Here we have negative x values. And then we need to see where the y values are positive. So on the y-axis, we have positive values over here. And now you just have to state which quadrant this is. This is in the second quadrant. Then highlight wherever the parabola is in the second quadrant. The parabola is in the second quadrant, all over here, and then it stops there. Then you see nowhere else in the second quadrant do we have the graph again. So now we just have to state for which values of x this part of this darkly highlighted graph exists. And so if we point that out, let's just see where this exists. It's going to exist here. So starting at -3, and then you see that we have a point over here. That's the x value. So remember, this point over here is -3. Then look at that. These are values that are what? Than -3. These are values that are less than -3. That is the x values for which this part of the graph exists. So in this case, this will be where x is less than -3. Again, we cannot say less than or equal to -3, because at -3, this is an intercept, meaning yes, the x value may be negative, but if you multiply by the y value, which is 0 at this point, we're going to get a 0 and not a negative. That's not what we're looking for. We're looking for where we multiply these x and y values and they give you a negative. Okay, so we also found that one as well. So that will be your conclusion. That is the part of the graph where x multiplied by f of x will be smaller than 0 because we're referring to the parabola. So that's your conclusion in that question. It will just be, therefore, x is less than -3 or x is greater than 0 but smaller than 1. The graphs of f of x is equal to x plus p all squared plus q and g of x is equal to a over x plus b plus c are drawn in the sketch below and have the following properties. So we have a 5 over 2 and 0 is a point on the graph of f. So that's just a point, and we can see that it's an x-intercept. P is the turning point of f and lies on the vertical asymptote of g. So here's P, the turning point line on this vertical asymptote. Then we have the horizontal asymptote passes through 0 and 2, so there it is. And then we have the vertical asymptote passes through 1 and 0, and so that's it. And the horizontal asymptote passes through 0 and 2. The graph G passes the origin. So we can see now that the graph of G also has a coordinate at the origin, which is of course 0 and 0. So the first question is, show that the equation of G can be written as this. So they basically just want us to find the equation of G. Okay, so now when finding the equation of G, there's just something that we need to remember. G is a hyperbola, and the general equation of a hyperbola is y is equal to a over x minus p plus q. Remember, P is your vertical asymptote and then Q is your horizontal asymptote. And you saw that they actually did give us these asymptotes, so we can go ahead and look for them. First of all, we know the vertical asymptote. It's this one over here. And so the equation of it, because it's a vertical line, it starts as x is equal to, and because it passes 1, x is equal to 1. And so we can see that our P value is going to be 1. And we have a horizontal asymptote, which the equation of y is equal to 2 because it passes 2 on the y-axis. And so we know our q is equal to 2. Okay, so since we know these two, we can go ahead and just substitute them into the equation so long. So we have y is equal to a over x minus our p is 1 and then plus our q is 2. Okay, so all we have to find now in this is just the value of a. And since a is the only thing missing, just to find a, we basically just have to substitute a point, because if we can fill in an x value and a y value over here, this will become an equation where we have to solve for a. So let's see what point they gave us on this graph of G. So looking at the graph of G, remember that they said that this graph passes through the origin. And remember, the origin is this point over here and its coordinates are 0 and 0. So that's another coordinate on the graph of G. There's no other coordinate they give you. So let's go ahead and substitute 0 and 0 into this equation. Of course, we'll be substituting this as x and that as y. So we're saying that 0 is equal to a over, then we have a 0 for x, minus 1 plus 2. So now we're going to have, we have the 0 is equal to, we have a over 0 minus 1. So 0 minus 1 is going to give you a negative 1. And a divided by negative 1 would be negative a. And then we have plus 2. And then just to make the a positive and solve for a, we can just take the a over. And so we have a is equal to 2. So there we go. We have everything here. We can go ahead and conclude that y is now equal to 2 over x minus 1 plus 2. And that is, of course, what they told us to find. Okay, moving on to 4.2. So 4.2 says that we have to calculate the coordinates of P. So finding the coordinates of P. Remember, what did they say about P? They said that P was the turning. It is the turning point of F, and it lies on the vertical asymptote of G. So let's see what we can get from this. If this is our turning point and it lies on this vertical line, then it means that this coordinate, since this is an x value, it has the same x value as this over here because it lies on the same vertical line. It's on that line. So the x value is 1 and then the y value, we don't know that. Okay, so let's go ahead and see what else we can find in order to find that P. the equation of the parabola, they gave us that. They gave us that f of x is equal to this, okay? But remember, the original equation of the parabola in turning point form actually looks like this. So that equation actually says that y is equal to a bracket x minus p all squared plus q. That's what that equation actually says. And so I'm going to use it in this form just so that I don't get confused by the way they put it. Okay, so another thing that we can do, so we know there's something that we know here. Remember that P and Q are the coordinates of your turning point. P is the x coordinate of your turning point, Q is the y coordinate. So we know something about the turning point. We know the x coordinate of the turning point. So we know that that x coordinate is P, and then the y coordinate, we don't know that yet. So we can go ahead and substitute that into our equation so far. So I'm going to put in P. So I just have so long that y is just equal to a bracket x minus, our P was 1, so it's minus 1 all squared plus q. Now, notice in this, we still don't have a. So let's look at the general form that they gave us for f of x. They said that, notice that they said f of x is equal to x plus p all squared plus q. There is nothing in here. There's no number in front here that they put. So it means that by default, there's actually a 1, an invisible 1. In front of every bracket that doesn't have a number in front of it, there's an invisible 1 there. So that means the value of a is 1. So we can go ahead and just put that in now. We know that a is now 1. So I'm going to erase that and just put 1. Okay, so now that it looks like this, we can see that the only thing we need to find is just the value of q. And clearly, to find the value of q, you can see that q is the only thing missing now. If we had a point, see an x and a y coordinate, we'd be able to find the value of q. So let's look on the parabola and see if they gave us a point. And I remember they did. They gave us an x-intercept over here. They gave us 5/2 and 0. So we can substitute that into that equation in order to find q. So let's go ahead and do that. We're going to substitute 5/2 and 0. And of course, we're substituting this as this is our x value and that's our y value. Okay, so we're going to say that 0 is equal to, and then I'm not going to rewrite the 1 because 1 multiplied by anything really just stays the same. So I'm going to just start with the bracket. And so we have the 5/2, then minus 1 all squared plus q. Okay, so you can go ahead and just punch this all into the calculator since they're all numbers. And when I put that in the calculator, notice I get a 9/4. So if this whole thing becomes 9/4, it's like taking the 9/4 over because I just want to leave q on its own. So I'm leaving q on the right hand side, and that became positive 9/4. I'm taking it over, and so I'm going to get a negative 9/4. And there we go. So that means we have found q, and we also know what the p value was. So they wanted us to find the coordinates of p. So just make sure to conclude. We're saying that therefore p is the point 1 and negative 9/4. Okay, moving on to the next question. We have 4.3. They say write down the equation of the vertical asymptote of p if p of x is equal to g of x minus 1. So they're introducing a new graph here called p of x, but p of x is formed by saying g of x minus 1. So you have to remember what it means to subtract 1 from the x. So when you add or subtract directly from the x, this is a left or right movement. But now when we have a minus, so have minus 1, then this means that it's going to move to the right, specifically just by 1 unit. It's moving 1 unit to the right. So the thing about these questions, you first have to interpret what's going on. So after interpreting what's going on, let's go ahead and focus on what they want. They don't want the entire equation of g of x. They don't want you to do that to the entire equation. They specifically just want the vertical asymptote. So the vertical asymptote of g itself before, okay, was just, so we can go ahead and look at it. It was really just this over here. That's the vertical asymptote. And the equation is x is equal to 1. So if the original one was just x is equal to 1, And the new one is now saying we have to say x minus 1. We have to remove a 1 from there. And we are interpreting this as it is moving or shifting 1 unit to the right. This is what really happens. We're going to look at on our graph, we need to move this vertical asymptote 1 unit to the right. So it's at 1. If you move it 1 unit to the right, it will now be at 2. Okay, so now since it's at 2, the new equation is going to be x is equal to 2. So that's what happens over there. So let's go ahead and say x is now equal to 2. So you can also just show them your calculation. You can tell them that, you see, you interpreted that it's moving 1 unit to the right. And when you're looking at the Cartesian plane, 1 unit to the right means that you're adding 1. See, that's why you need to always differentiate between the way they put it as an equation and the way it actually moves on the graph. On the graph, 1 unit to the right is plus 1. But when they interpret it as an equation, they will say x minus 1 because minus means to the right, but plus means to the left as an equation, but not when it's actually moving on the graph like here, like when we move this 1 unit to the right. So of course, this equation is just x is equal to 2. That is the new equation of the vertical asymptote of p of x. Okay, so that is 4.3 done. And now we move on to 4.4. They say, determine the equation of the axis of symmetry of G in the form of y is equal to mx plus c if m is smaller than 0. Okay, so they want the equation of the axis of symmetry. This is work that you would have had to study already. You need to know about your axis of symmetry, the points of intersection of a hyperbola. So let's go ahead and look at the graph of G, that hyperbola. So when we're looking at this graph of G, let me just get rid of some of these. This graph of G will have 2 axes of symmetry. It will have one that looks like this. So this one, notice that this axis of symmetry, and let me actually just move it down a bit to make it pass like that. Okay, so it will have this axis of symmetry, and this one is the axis of symmetry with a positive gradient. Okay, and you can see that because the graph is increasing. Remember, you always look at graphs from left to right, like you read, because that's how the numbers increase, okay, on the x-axis. So this is the one that is increasing. And let's just remember, because if you remember the way the equation of this axis of symmetry is, the other one will not be difficult to remember. So this one says y is equal to, and here's where it actually becomes really easy. Remember, the general form of this, of the hyperbola, is y is equal to a over x minus p plus q. So the axis of symmetry, the equation is y is equal to x minus p plus q. That's the one with the positive gradient. Okay, so you see why I say it's actually easy to remember if you remember the general form of this. Then the one with the negative gradient that looks like that one that is decreasing because this line is going down, that equation, so this one has a gradient smaller than 0. The equation of this one is y is equal to, and what we do is we put a minus in front of the x minus p, only in front of those two. So minus, so we open in a bracket x minus p, then we have plus q. Then you can go ahead and multiply that minus in. So it means that the equation is y is equal to negative x plus p plus q. So that's the equation you need to be working with, the one with the negative gradient. So if we put in that down, we have y is equal to negative x plus p plus q. So now that we have this equation, let's go ahead and remember what p and q was. Remember the vertical and the horizontal asymptote of the hyperbola. So in the hyperbola, remember the vertical asymptote was the 1, and then the q was the horizontal asymptote. So p was 1 and q was 2. So we're just going to fill that in here. So we're saying y is equal to negative x plus 1, and then q, of course, was the 2, so plus 2 is positive. So y is equal to negative x plus 3. That's the equation of your axis of symmetry with a negative gradient. Okay, and now we are at 4.5. we are told to write down the equation of k if k is the reflection of g about the x-axis. So remember, with reflections, you just have to think about which axis is it being reflected in and what will change as a result of that. So a simple diagram of this, if we had a Cartesian plane and I just drew, let's say, an exponential function, for example, like that. If this graph, let's call it f, if it was reflected about the x-axis, so here's your x-axis, it's going to look like this. Now notice what changed. The x values are still exactly the same. You see this, it still has this x value as this one's x value as well. The only thing that changed was the y values. So these ones, like this point, has a y value here. But this one that is right under it has a negative y value. So it means that when you reflect something about the x-axis, it causes the y values to change. And really what you just do to the y values is that you take them and you multiply them by -1. So this will happen to all the y values on this graph. Okay, so in the case of g, this is what happens. So also just notice that they're not really asking you for a point, they're asking you for the equation. So write down the equation of k. K is a new equation and it's a reflection of g about the x-axis. So this is how we can write it. K of x is our new equation and it is formed by taking g and reflecting it in the x-axis. Remember, when you reflect it in the x-axis, it causes the y values to change. In other words, you take the y values of g and you multiply it by -1. So it's like I'm saying y values of g times -1. Now, instead of saying y, I'm going to use g of x because g of x really just means y. So I'm saying that is g of x being multiplied by -1. Or you could just write it as negative g of x. So that's the new equation of k of x. So let's apply this into this. Remember, g of x is equal to an equation. So we're going to take that equation that g of x is equal to. We already got the equation in the first question. This is the equation of g of x. This is our g of x is equal to this whole thing. So we're going to just go ahead and substitute this in place of g of x. So saying that k of x is equal to, we have the negative, and then we're going to just open a bracket for g of x. So we have now 2 over x minus 1 plus 2. Okay, so now that we have this, let's go ahead and just multiply this negative into the bracket. So k of x is equal to taking this negative and timesing it into this bracket. Remember that negative is like a -1 and it's multiplying by 2 over x minus 1. So we're just multiplying those numerators. So we have -2 over x minus 1. And then this negative again is going to multiply to the 2 and give you a -2. So that is your new equation of k of x. Okay, so that's 4.5 done, and we are moving on to 4.6. So 4.6 says, for which values of x will f prime of x multiplied by g of x be greater than 0? Okay, so first of all, let's talk about what they mean by f prime of x. F prime of x is the derivative of f. Remember that f is this parabola. If we derive this parabola, let's look at what it's going to become. You first have to just look at the way f looks. It's concave up. So if you have a concave up parabola, when you derive it, it will become a line, but it will be a line with a positive gradient. So it's going to be a line that looks like that. Okay, so this is just something you need to also just remember about functions. So if you derive a concave up parabola, it's going to just become a straight line with a positive gradient. If it was a concave down parabola, it will become a straight line with a negative gradient. And really the reason why is because the parabola is in the form of y is equal to ax squared plus bx plus c. If it's concave up, it means that a is positive. And if a is positive, when we're deriving this, what happens is that you're going to have the a times the 2. The 2 is already positive, so this 2a is still all positive. Then we have x plus b. So you can see 2a is going to be positive. And since this is a straight line, it's in the form of y is equal to mx plus c. 2a would be your gradient. That's why the gradient will always be positive in a concave up parabola. Okay, so we know what that graph is going to look like, which we will draw. But then let's also just understand what exactly are we multiplying together. So when they're saying f prime of x, they're really just speaking about the y values of that graph, of that straight line that this is going to be. So it's the y values of that graph. And g of x would be the y values of g as well. And that needs to be greater than 0. So let's think about the type of numbers that will help us get values greater than 0. So if I take a positive number and I multiply it by a positive number, then I'm going to get a number greater than 0. Also, if I take a negative number and multiply it by a negative number, I'm going to get a value greater than 0. So this is what we need to look for. When we're looking at these, we're going to look for places where f prime of x, the y values of f prime of x, is positive, and for the same x values, the y values of g of x must also be positive. And then, of course, we will also look for the places where the y values of this graph is negative, and at the same time, the y values of this graph is also negative. That's what we're going to look for. Okay, so remember with this question, we're just looking for places where f prime of x is positive, but at the same time, g of x is also positive, and these refer to y values. Okay, so with this now, let's go ahead and first sketch f prime of x, because we don't have that. We only have f of x, which is the parabola. So when we're sketching f prime of x, just remember it's going to be a straight line with a positive gradient. But it is something else we also know about this straight line. You see the turning point over here. Looking at the x value of the turning point, you only focus on the x value. The x value of the turning point was 1. It means that that straight line is going to have an x-intercept at 1 as well. Okay, so this is how it always works. When you have a cubic function, you find out that the point of inflection is going to be the exact same x value as the parabola, the derivative of this cubic function's parabola, right? This parabola is going to also have the same x value in its turning point. And then if you derive this parabola, it's going to form a straight line graph, right? That has a positive gradient, but that straight line is going to have an x-intercept with the same x value as that turning point and as the point of inflection in the cubic function. So we know now it's going to have an x-intercept at 1. So we can go ahead and mark that. It's going to have that, and it's just going to be a straight line that basically just goes like that. Okay, so we're only going to be focusing on G and F prime. So let me highlight them in these colors. Okay, now that we have the graphs both written down, all we're going to look for is the y values of these graphs. So first of all, we're looking for where are the y values both positive. So since the y values must both be positive, we can focus on only this part of the y-axis. It just means we're only going to focus on these two quadrants, the first and the second quadrant. So you can ignore this for now. We're only going to focus on that. So we're going to look for places where these two graphs exist together. So over here already in the second quadrant, you can see we already only have g of x. So f prime of x, that graph, is nowhere to be found here. So we can skip all of this. We're not going to use any of that. Okay, then we can focus on this part, the first quadrant. You can see that both graphs are positive. They have y values that are positive in the first quadrant. Okay, so let's just find out now for which x values this would be. So these are the graphs where they have positive y values, but let's see which x values would this be for. So looking at these two graphs over here, this one has positive y values. If you map it down to the x-axis, look where it points, just after 1. Also map that down again to the x-axis. It's also just past 1. It's moving on the positive side, on the right-hand side of 1. And you can see it's doing the same thing for the straight line graph. These are also coordinates for the straight line graph. If we map it down, you can see that these are values that are greater than 1. They're x values that are greater than 1. So we always have to check. We have to answer them in terms of x. So we're checking for which x values these parts of the graphs belong to. And so this would be where x is greater than 1. So that is one of our solutions. This is where x is greater than 1. Okay, so we found the places where they were both positive. We found that. Now let's focus on the places where these two graphs are both negative. So remember, them being both negative, just we're referring to their y values. So we're only going to look at negative y values, meaning we're only going to look at this part of the y-axis with negative y values. So we're focusing this time on the third and the fourth quadrant. Okay, so we're looking for places where the both graphs exist. First of all, if we check here, we cannot even take this. Unfortunately, f prime of x is the only one here. It doesn't have g of x that has negative y values. If you look at this one and you see the x value that it belongs to, g of x values and y values unfortunately are positive. So we cannot even use any of this part. But if we keep going and we keep going, we need to see where do they both exist at the same time. So if we keep going, you see, unfortunately, this one is negative here, but that one is positive. So still not working. Still not working all the way here. Even here, it has a negative y value, but that one, its y value is 0. Okay. As we keep going over here, this small gap in here, you see now that we have the graph of f prime of x, the straight line and the hyperbola are existing here, meaning they both have negative y values here. So we just have to see now for which x values does this belong to. So where they both have negative y values, so I'm just going to mark the places where they both have negative y values, and that would be all the way here, this here and here at the same time basically. So you see, all for these, they all have negative y values. So for which x values does this belong to? This will belong for these x values. So we're looking at like we're taking this point over here and we're mapping it to the x-axis, mapping that to the x-axis. We're also doing the same for the blue graph, mapping it to the x-axis. And now you can see that this is happening between these two x values where x is greater than 0 but smaller than 1. Okay, so for that one, that is where x is greater than 0 but smaller than 1. Now, I don't know, you may be thinking, why did I not say that x is equal to 0 in this case? Because if you look at the f prime of x, it has a negative value where x is equal to 0. But remember, we need to look at it. We need to account for this for both graphs. They must both have negative y values. And in this case, unfortunately, this graph of g, it doesn't have a negative y value. It has a y value of 0 itself. So we cannot consider that. So we have to say it starts where x is greater than 0, not equal to 0, but smaller than 1. Okay, so that is how to solve that one. So our answer is just basically x needs to be greater than 1, or x needs to be greater than 0 but less than 1. Now, funny enough, if you look at these values on the number line, we can actually write it as one simple answer. Because if you look at these, we have 0 and we have 1. And we're basically saying that x is greater than 1. So if we have 1 here, x is going towards those values. But here, we're saying that x is greater than 0, but smaller than 1. So if you look at this, it's really that x is greater than 0 because it includes all these values except for 1. X is just not equal to 1, but it is greater than 1. It's also less than 1. So you could have also written this as x is just greater than 0, but x is not equal to 1. But I'm sure if you left it like this, it would also be fine. Okay, and now the last question in this question 4 is, for which values of k will the equation of g of x equal to x plus k have two real roots of opposite signs? Okay, so this question is for 1 mark, so I don't think you need any delta or anything like that because it's 1 mark. So it's probably a graph interpretation thing. You have to look at the graph and actually see how this works. Let's focus first of all on the equations that they are referring to. They want us to find for which values of k will this g of x be equal to x plus k? Okay, so will this g of x be equal to x plus k? Let's separate first of all these two equations. We have the equation of g of x, which we know is that hyperbola which has 2 over x minus 1 plus 2. Then we have another equation here, and that equation is x plus k. So if you look at that equation, it's really just y is equal to x plus k. That's that equation. This one is our g of x. So we have these two graphs. As you can see, this one is a straight line graph. It has the y is equal to x, then plus k, because this could move up or down. We need to find out which direction it needs to move first of all. But all in all, we have this y is equal to x. Now, that graph is this line. It's basically this perfectly diagonal line. If you have a Cartesian plane, for example, and you have, let's say, -2, -1, 0, 1, and 2, and you also have the same thing on the y-axis, then this is how this line is going to look. If your x value is, so I'm focusing on the y is equal to x part. So if we have an x value of -2, your y value will also be -2, because y is equal to x. If you have an x value of -1, you have a y value of -1. X value of 0, y value of 0. X value of 1, y value of 1. X value of 2, y value of 2. That's what I mean by it's that perfectly diagonal line. Okay, so this is just for you to know what that line looks like. So what they're doing with the graph of g and this line is that they're equating them, and they want to find out for which values of k will it have two roots of opposite signs. So first of all, let's look at this graph. Let's draw this graph. Since we already know we have the graph of g of x, let's draw this graph y is equal to x plus k, because it hasn't been moved yet. So the y is equal to x line, I'm just going to draw that as a diagonal line that will of course pass the origin 0 and 0, because when x is equal to 0, y is equal to 0 as well. So that is this line. So at first, when we're looking at this line, we can see that it has a y-intercept of 0 and an x-intercept of 0, of course. So that's that y is equal to x. Then I'm just going to include the plus k, because then we still have to think about how to move this graph. Let me change the color to red instead. Okay, so looking at this line, the question, remember, they want for which values of k will it have two roots of opposite signs. Okay, so I know that we know roots as x-intercept, and this is what I kind of do not like about this question. This question has actually shown up before. I think it showed up in a November 2015 paper, and they still use the words roots. And I know everybody knows that roots we only refer roots to x-intercept. But what it seems like they mean is we're looking at this graph, right? And we're looking for the places where the graph intersects with the graph of g. So we're going to look at the graph of g and this graph of y is equal to x plus k. And the roots that they're referring to, the roots of opposite signs, are, remember that they equated these two graphs. So we're looking for the points of intersection, but we're specifically looking for the x values of the points of intersection. And we want the x values of the points of intersection to have opposite signs. So we have to think about how should we move this graph. So I'm going to copy this graph and let's think about moving it down or up and see how we're going to move it in a way that it's going to intersect the graph twice as usual, but then it's going to intersect the graph in a way that the first point of intersection will have a negative x value and the second one will have a positive x value. Okay, so this is the graph copied. So I'm just trying to figure out how do we move it. Let's think about this. It was here originally, right? And when it's here originally, the intercepts or the x values of the point of intersection. Here we have, first of all, a point of intersection at 0 and 0. So this is neither positive nor negative. The second point of intersection that we have is over here. And that one has a positive x value. But we want the 2 points of intersection to have x values of opposite signs. That's the roots of opposite signs. That's what we're looking for. So let's think about moving it down. If you move this graph anything just below what it was originally. So here, this is where k is equal to 0 at this line, because you can see the y-intercept is just 0. If you move it down, meaning we're making k smaller than 0, see what happens here. So if I move it down, look at where it intersects. It intersects over here and over here. Now the problem with this, and the reason I cannot accept this, is because at this point of intersection, let's look at the x value of this point of intersection. It's over here. It's a positive x value. And this one, its point of intersection, is also a positive x value. We don't want that. We want two x values that are of opposite signs. So if you move it down, it keeps on doing that. Positive x value of the point of intersection, another positive x value. So you see clearly moving it down does not work. We need to move it up instead. So when it is here, at the point where k is equal to 0, we're going to just make k more than 0. Just make k greater than 0. So move it up instead. So if we move this graph up, look at where it intersects now. It intersects here and here. Over here, this point of intersection has an negative x value. And over here, the point of intersection has a positive x value. So you can see now these two have opposite signs. The points of intersection or their roots have opposite signs. So we just have to make k greater than 0. And then that's what would work for that. Okay, so for that last question, k just needs to be greater than 0. So I'm just saying that, therefore, in this one, k needs to be greater than 0. Okay, and that concludes it for question 4. And now we're on question 5. Question 5 says, the graph of h of x is equal to a to the power of x, where a is greater than 0, is sketched below. And then we have this point P. It's a point on H. The first question is to write down the coordinates of Q. Okay, I see that they didn't really tell you what Q is, but it seems like Q is the y-intercept. So let's go ahead and find the coordinates of Q, which is the y-intercept. In order to find the y-intercept, always make x equal to 0. So we're just going to do that. Make x equal to 0. So the equation of this graph, h of x, is just a to the power of x. So we're taking h of x being equal to a to the power of x, and we're just going to make x equal to 0. So this is h of 0 is equal to a to the power of 0. So h of 0 is equal to anything to the power of 0 gives you 1. And so that therefore means that q is just 0, that's the x value, and 1 is the y value. And then 5.2 says determine the value of a. Okay, so we know that h of x is equal to a to the power of x. And let's see on the graph, they gave us this point, -1.5. So that's our x value and our y value. So we're going to just substitute that into the graph. The y value is 1/2, and then the x value is, so a to the power of -1. That was the x value. So let's go ahead and just solve for a. Since we just have a to the power of -1, because this is a letter, we cannot make the bases the same. So we can focus on the exponents being the same. So since we have a -1 here, how do we rewrite this in a way that it's going to have an exponent of -1? So if you want to write a fraction as a whole number, just to make it look like a whole number, it won't be a whole number, you can write it like this. If it's 1/2, we're going to go ahead and just take the 2 to the numerator. But the consequence of that is that its exponent is going to be negative. The 2's exponent already here is just a +1. When you take it to the numerator, the exponent is now -1. Remember, it's still like a fraction, so it's 2/1. But if you say anything divided by 1, it just stays the same. That's how we have 2 to the power of -1 is equal to a to the power of -1. And now that the exponents are the same, we can equate the bases. So therefore it means that a is equal to 2. Okay, moving on to the next question. So we have to write down the equation of a to the power of -1. So that's the inverse in the form of y is equal to. So the original equation was y is equal to a to the power of x, but we know what a is now. So that is 2 to the power of x. So we just have to write the inverse in the form of y is equal to. To write the inverse, first of all, you swap x and y. So in place of y, I'm going to now say x is equal to, and then 2 to the power of x instead turns into y. And then now we just have to make y the subject after swapping x and y. So to make y the subject, we're going to have to use log because y is an exponent here. To make an exponent a subject, we're just saying y is equal to, and we're saying it's log of the base. The base is the one that's carrying the exponent, so it's our 2. And then we have x. Okay, so there we have written the inverse in the form of y is equal to. Then 5.4, we have sketch the graph of h of -1 in your answer book, clearly showing all intercepts with the axis. Okay, it's not like I'm using the calculator. I'm just going to make that smaller. Now, when sketching this graph is actually very easy to sketch. And I think many a time students overthink this. You already have things that you need here. You have 2 points. Focus on only those 2 points. You have P and you have the point Q, which is 0 and 1. We're only going to use those 2 points. So since we are sketching the inverse of H, just remember that the inverse of H is just going to have all the coordinates swapped. So instead of having this P, right, the image of P on the inverse is not going to say -1.5. It's going to say 1/2 and -1. And then this y-intercept is not going to be 0 and 1. It's instead going to be an x-intercept, and it's just going to say 1 and 0. Then you just have to know the shape of the graph and how it's going to look. So let me put down the Cartesian plane so we can look at that and only focus on these 2 points. Okay, so here's my Cartesian plane, and let me just focus on the numbers that I should have here. Remember, I'm not really using any other extra numbers. I'm only using things that I have on here. So if I see the number -1.5, I'm going to try and make sure I have that. I also have 0 and 1, so I'm also going to just make sure I have that on both axes just to be safe. Okay, so here is the Cartesian plane. And so now I'm just going to focus on the points that I have on the original graph. So since the original graph has the point -1.5, I'm going to have 1/2 and -1 instead. And I'm going to call that the image of P. So just P prime. So at 1/2 and -1, that's where we have P prime being 1/2 and -1. And then we have the Q. The Q was 0 and 1. So instead, we're going to have 1 and 0. And that's going to be over here. So that is our Q. I'm just going to call that Q prime. And it is now 1 and 0, which is an x-intercept. Okay, now that you have your points down, you have to just look at the way your graph looks. Looking at the original graph, look at what your original graph is doing. So we're looking at the x-axis, and you can see that this graph is coming from the y value of 0. It was closer and closer to here, and then it starts to increase as we move towards the positive parts of the x-axis. So this is the positive parts of the x-axis and the negative parts. So you see what it's doing here. It starts to increase, meaning the y values are getting higher. Okay, so it's increasing like that. What it's going to do on the inverse, it will just swap. It's not going to do the opposite, it just swaps. So your graph is just going to do what it was doing on the negative part of the x-axis. It's going to do that instead on the negative part of the y-axis. So your graph was closer to the x-axis at this point, on the negative part of the x-axis. So on the negative part of your y-axis, your graph is going to be closer to this point. Then as you can see, it starts to increase as it moves towards the positive part of the x-axis. The same way this graph will start to increase as it moves towards the positive part of the y-axis. So it's basically going to do this. It will start increasing like that. See? So it's kind of like tilting your head this way and then looking at it. And you're seeing that from here on the negative part of the y-axis, then you see what it's doing. It's increasing. And so that's what our graph is going to also do. So we can go ahead and look at it here. As you can see, you have a point here and a point here. The graph is just going to do this. On this part, it's going to be coming from here, and then it's going to start increasing and curve like that. So not the perfect graph, but that's basically what it's doing. So it's doing the same thing as what it was doing over here. Also, just remember that the original graph had, as you can see, that we just have a to the power of x. We don't have a q. Since we don't have q, it means that q is actually 0, meaning your horizontal asymptote is at 0, okay, on the x-axis. So it means that if your horizontal asymptote was here on the x-axis, then the inverse is going to have a vertical asymptote instead. So this one, the asymptote would have just been y is equal to 0, but the inverse is going to have an asymptote of x is equal to 0. And that's why your graph over here is just going to be moving closer and closer to the y-axis. Okay, so it's coming from a very close place to the y-axis, and then it starts to increase like that. Okay, so that's 5.4. Moving on to 5.5. And then 5.5 says, write down the domain of the inverse of h. Okay, so when we're speaking about domain and range, let's just look at what happens. If you have an original graph for O and an inverse, the domain of your original becomes the range of your inverse. And the range of your original becomes the domain of your inverse. So it basically just swaps. So if you want to find out what the domain of the inverse is, you have to know what the range of the original was. Let's look at the original graph. We know that the original graph, the equation was that h of x is equal to 2 to the power of x. And remember, the value of q is 0. So to find out what the range of this graph is, remember the range is all the possible y values. If the graph lies above the asymptote like it does right now, as you can see, then it means that the range, the y values, are just going to be greater than your value of q, whatever your horizontal asymptote was. So we already know what q is here. We know q is 0. So it means that the range of this graph of h is y is greater than 0. Okay, so now that we know that range, if we know that this range is y is greater than 0, they're asking for the domain. So it means that this is the domain of this. But we cannot write it as y is greater than 0 because it's a domain. It's speaking about all the possible x values. So it means that the domain is going to be x is greater than 0. So see, it's still the same thing. We're just referring to x values now, not y values, because it's the domain. And then moving on to 5.6, the second last question in question 5. So 5.6 says, hence or otherwise determine the value or values of x for which log base 2 of x is greater than 0. So this is our equation of the inverse of h. So we have to find out where is this greater than 0. It's for 1 mark, so it's something that you have to do on the graph. So let's look at the inverse and look for places where it is greater than 1. Remember, where they say it's greater than 1, they're referring here to the y value. Just like you would have said, h of negative 1 of x is equal to log have a base 2 and x. You can see that this, okay, is referring to this, which is a y value. We're speaking about all the y values. So which places does this graph have y values that are greater than 1? So we have to look at the graph for that. So looking at this graph that we have, where are the y values greater than 1? So we have a y value of 1 over here. And so let's see where that maps to this graph. Okay, so right now I cannot see the graph. I'll just have to extend it. Okay, so this is not the best graph, but it looks something like this. And so I'm trying to first of all find out where are all the places where the y values would be greater than 1. Okay, so over here, this is where the y value will be equal to 1. And we have to find out for which x value this would belong to. And I'm just going to extend the x-axis. So over here, we have some sort of point here, coordinate here, that has a y value of 1. So let's find out what that x value would be. So to find out what x value this would be, you would need your equation of this graph of h of negative 1, the inverse of this, so this graph. And the equation of that graph is h negative 1 of x is equal to log the base of 2, and we have x. So if this is the equation of that graph, let's just find out where does it have a y value of 1. So we can just find out where exactly is this starting. So to find the y value of 1, we're going to substitute in place of y, we're going to put in 1 there. So 1 is equal to, and we have log base 2 and we have x. So here we have to put it in exponential form to solve for x. So in exponential form, we know that the base of what we have is going to be 2. So we're going to have 2 to the power of, now your exponent is going to be what this was equal to. It was equal to 1 because it always makes the exponent the subject. So to the power of 1, and that is now equal to your x. That's how to solve for x. So it's equal to what's inside the bracket. That will be your answer in exponential form. And you can use this to remember this. So now we know that that x value is equal to 2. Where the y value is 1, we have an x value of 2. So all this is asking is for the places where this log base 2 of x is greater than 1. Okay, where does it have y values greater than 1? So let's look on the graph. On the graph, if this is your y value of 1, then below this, all these parts of the graph have y values that are less than 1. We need to focus on the ones that have y values greater than 1. And that will be all these parts of the graph, because this graph is going to keep increasing. So these parts of the graph have y values greater than 1. And so if we map this down to the x-axis, we just have to map it down like this. We map it down, down, and we see now that these are values that are greater than 2. Okay, so not equal to 2, because they want the y values to be greater than 1, not equal to 1. At 2, the y value is equal to 1. So where the y values are greater is just where x is greater than 2. So I'd actually put all of this calculation in that answer. So this is therefore where x is greater than 2. Okay, so 5.7, the last question says, if g of x is equal to 100 multiplied by 3 to the power of x, calculate the value of x for which h of x will be equal to g of x. So remember that h of x was that 2 to the power of x. So we have to equate this and just solve for x. So we're saying that h of x, the 2 to the power of x, is now equal to this g of x, which is 100 multiplied by 3 to the power of x. Okay, so when solving for this equation, please notice that 2 to the power of x and 3 to the power of x, they have the same exponent. So let's try to put them together so that we can write them over the same exponent. So what we can do is, to get the 3 to be on the 2 side, we basically have to get rid of this 3 to the power of x on this side. And the only way to do that is to divide both sides by 3 to the power of x. Then it will be gone. Then we see that these two would cancel. They're gone now. And now you just have 100 on this side. So here you have 2 to the power of x and 3 to the power of x. You can write it as 2 over 3 all raised to the power of x, since they're both raised to an exponent of x. That is equal to 100. And now we just have to solve for x. As you can see, this is a fraction. This is 100. You can't really make the bases the same, so you just have to use log to solve for this. So log makes the exponent the subject. So we're saying that x is now equal to log, our base is still this because it's the base carrying this exponent. So base 2 over 3, and then here we have 100. So we're just going to substitute this and see what we get. And when we substitute this, we see that we get x being equal to, and we can just round off the 2 decimal places, so negative 11.36. Okay, so that is our answer. Okay, so that's it for question 5. Question 6 says, the graph of f of x is equal to negative square root 27x for x being greater or equal to 0 is sketched below. The point P, which is 3 and negative 9, lies on the graph of f. The first thing we have to do is use the graph to determine the values of x for which f of x would be greater or equal to negative 9. So remember, they are referring to a y value of negative 9. So let's just mark the places where this graph, or where the y values of the graph will be greater or equal to negative 9. So if this is negative 9 over here, negative 9 is here, the places that are greater than negative 9 would be above here. So we're taking all the parts of the graph that are above this line. But because it said greater or equal to, we'll also take that point as well and every other x value above it. So let's see what the x values for this are. First of all, where y, or where the f of x, the y value, is equal to negative 9, that is where x is equal to 3. Like they told us already, it's a point 3 and negative 9. Then the places on the graph where this is greater than negative 9 would be here. So let's just group this and line this up to the x-axis. It'll be all these highlighted spots on the graph. And as you can see, these will be places that are in between 0 and 3. But also notice that at the point 0, we have 0 and 0, okay? And 0, the y value of 0, is also a number that would be greater than negative 9. So your answer for this would be, it's between 0 and 3. X is going to be greater or equal to 0. So it's not just greater than 0, because 0 is also an included point. At this point 0, the y value is 0. 0 as a y value is also greater than negative 9. So we have to include that as well. So it is x is greater or equal to 0, but less than or equal to 3. And the reason why it's equal to 3 here again is because they specifically asked for places that are greater or equal to negative 9. And we know that at the x value of 3, the y value is equal to negative 9. Okay, so that is the answer for that first one. And then question 2 says, write down the equation of the inverse of f in the form of y is equal to, and then you need to indicate all restrictions. So they're referring to this restriction. They restricted the domain of the original graph, so you also have to show your restriction as well. Okay, so just finding the equation of this. First of all, we can write it as y is equal to the original one, negative square root 27x. And then to find the inverse equation, first of all, just swap x and y. So I'm going to say x instead is equal to negative square root 27. And in place of x, I'm going to put y. Okay, now we just have to make y the subject. So if y has to be the subject, we need to get rid of, first of all, the square root. So to get rid of the square root, we're going to square both sides. So if I square that and I square that, this is what we get. We get that x squared is equal to, now the negative is going to fall away because a negative times negative is positive, and then the square root also falls away because it's the inverse. So we have 27y. And then to make y the subject, we'll just divide both hand sides by 27. And so therefore y in that form is equal to x squared over 27. But now we also have to put a restriction for this inverse. Now to put the restriction for the inverse, first look at the restriction for the original. The original has a domain of this. This is the domain. Remember, with the original and the inverse, the original graph, if it has a domain, this domain will now become the inverse's graph's range. And then the range of the original graph will become the domain of the inverse. So if you look at this graph as our original graph, if its domain was x is greater or equal to 0, so that was the domain of this one, x is greater or equal to 0. We have to find out what is the range of this original graph so that we will know what the domain of the original graph is. That's the restriction you're putting. You only put a restriction on the domain, and that will have an effect on the range. So we need to put a restriction here. We need to find out what the domain of the inverse is. To find out the domain of the inverse, we're just going to find the range of the original. Okay, so with this one, it's quite simple because they already just gave you the graph. They already sketched it. So we can look at this graph and see what are all the possible y values of the graph. If we know that x can only be greater or equal to 0, so meaning you only have these x values, greater or equal to 0, look at the y values that you have. your y values, notice that you do not have any positive y values. There's no graph up here. Your y values are, it's either equal to 0 because we have a y value of 0, or it is less than 0. So it means that here, our range of this, the range is y is either less than or equal to 0. And so if this is the range of the original graph, then the domain of the inverse would be x is less than or equal to 0. Okay, because that's what it becomes. The range of the original becomes the domain of the inverse. But I cannot call that y because it's still domain, so it's still speaking about the x values. So that would be the answer for that. So it's this, and then you need to say where, or put a semicolon and say this is where x is smaller or equal to 0. That's the domain of the inverse. So question 6.3 says, sketch the graph of the inverse of f in your answer book. Indicate all intercepts with the axis and the coordinates of one other point on your sketch. Okay, so you have to have intercepts, so x and y intercept, but in this case, it's definitely just going to be one intercept. It's just going to be that 0 and 0 because that is both the x and the y intercept. And then you also have to include one other point, so possibly the point that they already gave us here. Okay, so you don't have to now start sketching it using other points. You can just use what we have here. You know that this is the original. The inverse of it will just have all the coordinates swap. So if we had 0 and 0, the inverse will also just have 0 and 0 because they are just swapping. And then here, if our coordinate for p was 3 and -9, our coordinate for p on the inverse would be -9 and 3. So let's go ahead and just put that down first. So we have our Cartesian plane, and we know first of all, we have the coordinates 0 and 0, and then we have -9 and 3. So 0 and 0 in the center, -9 and 3 will be somewhere here. Let me just extend this. So -9 would be here. So 9 places, 9 blocks, I'm just moving. -9 and then 3 up. So we have that. -9 and 3. I'm just going to call it the image of p. So p prime, -9 and 3. Okay, so we have that point now. We have the center and we also have that point. Now just to sketch the graph, monitor the way your original graph looks. So it looks like this. If you tilt your head to the right, you will see that this original graph, if it was a full parabola, it would be concave up. So kind of like, imagine this like that. It will be concave up, just tilting your head to the right. So it means your inverse will also be concave up. So if it's concave up, and we can see that it is concave up facing the positive part of the x-axis, the inverse will be concave up facing the positive part of the y-axis. Okay. And we know our coordinates were over here, so it's going to be concave up facing like this. Okay, so that's how to look at it. That was just to let you see that it was like from an original parabola. It was just restricted. So we can go ahead and just draw that over there. It's going to come from the center and it's going to just curve out like that. Something like that. Let me just make that look better. Okay, so something like that, and basically just shoots out. So that's what your parabola is going to look like, the inverse. So you can also just label it f -1. Okay, so that's it for 6.3. You can, if you like, call the 0 and 0, but as long as they can see it is touching the origin, they will know that is the center. Okay, then moving on to 6.4, the last question in question 6. Okay, so 6.4 says, describe the transformation from f to g if g of x is equal to the square root of 27x, where x is greater or equal to 0. So g of x looks like this, square root of 27x. But f of x was negative square root 27x. So if you look at these two, you see that this one had a negative and that one had a positive. So clearly this was multiplied by -1 in order to get that one. So when you're multiplying this by -1, it's like multiplying the y value because f of x is equal to this, right? So you're taking all the y values and you're multiplying it by -1, meaning you have caused all the y values to change. So it means that the transformation that happened here was a reflection. And since all the y values changed, it means that it was reflected in the x-axis. So this is a reflection in the x-axis. So it just basically means that f is reflected in the x-axis to form g. And that's it for question 6. Okay, so now we're on question 4, and question 4.1 says, sketched below is the graph of h of x, which is equal to 1 over x plus p plus q. The asymptotes of h intersect at 1 and 2. Okay, so they tell us those asymptotes intersect. So they're telling us clearly the vertical and the horizontal asymptote. We have to write the values of p and q. So as you can see, they're doing that thing again. This is not the original equation of a hyperbola. This is not what it's supposed to look like, this part. It's supposed to say x minus p. So you have to remember what the original one is. If not, you could end up getting confused. So in order to find that value, I just have to remember that the original equation is supposed to look like this. It's y is equal to a over x minus p plus q. So as you can see, there's no problem with the q, but the p, you just have to be careful there. So p, naturally in the original equation, that stands for your vertical asymptote. So as we can see, the vertical asymptote, it passes 1 on the x-axis. So p is equal to 1, right? And q is equal to 2. We have no problem with the q. So when we substitute that into our original equation, that is y is equal to a over x minus our p value is 1, and then the q value is plus 2. Now, you have to answer them in terms of their p. It doesn't change the formula. The formula is still the same. The a is 1, by the way. Okay, the formula is still the same, but then their p value is just different. So if you see that here, they clearly put the x plus p, okay, but you know the original one is x minus p, you're just going to have to take whatever your p value is and multiply it by -1. Okay, that will give them their p value. So it means that p, their p value is actually equal to -1. Okay, because you know that this is the original equation, and only if you made p equal to -1 will you get this equation. So if we substituted this p, their p value, into here, it would be h of x is equal to 1 over x, and then you see you have plus p. But now we know p is -1, so that's plus -1, which really just becomes a -1, and then plus 2. There, it matches up with our equation, which we used the original one for. So just remember that if you see a plus there, it means whatever your value of p is, just multiply that by a -1. So p, their p, was saying that is equal to -1, and the q still stays 2. So p equals -1, and q is equal to 2, just so that it can match up and we can still end up getting the proper equation. Okay, moving on to the next question. Okay, next question. We have to calculate the coordinates of the x-intercept of h. So what are the coordinates of the x-intercept? Well, let's write the equation of h down first so that we can see what we have. H of x is equal to 1 over x, and of course, you see plus p, but we know their p value is -1, so that's minus p plus 2. So this is our equation, and we just need to find the x-intercept. To find the x-intercept, you're just going to make y equal to 0. So our y value, that's h of x, we're making that equal to 0, and we have 1 over x minus 1 and then plus 2. To solve for x, we can just take the 2 over, so that becomes a -2 is equal to 1 over x minus 1. Okay, and now just to solve for x again, you can put this over 1 and cross multiply. So we're saying the 1 times the 1, which really just stays 1. And then you're saying the 2 multiplied by x minus 1. You're multiplying something that's one term with two terms. Remember, this -2 needs to multiply to the x and the -1. So that's -2 times x, which is -2x, and -2 times -1, which is +2. And so this is going to be equal to, I want to solve for x, so I'm going to take this -2x over so that it can become positive, and then I'll just take this 1 over. So we have +2x now is equal to And we still have a 2 here. So 2, and we took this 1 over. We're taking it over, so it becomes a minus 1. So 2x is equal to 2 minus 1, which is 1. Then if you divide both sides by 2 to solve for x, x is equal to a half. So remember to answer their question. The question is for you to calculate the coordinates of the x-intercept. So we need to put it in as a coordinate. So therefore, it means the x-intercept when y is equal to 0, the x value is 1 over 2. So we have 1 over 2 and 0 as our coordinates. Okay, so there we go. That was for 2 marks. And then we move on to the next question. Then we have 4.1.3, which says, write down the coordinate, the x-coordinate of the x-intercept of g if g of x is equal to h of x plus 3. Okay, so there's a new graph called g, and this graph is being translated, and we have to write its x-intercept. Okay, so this is only worth 2 marks. So for you to just go ahead and start applying this translation into the graph, that's going to take long, because then you're going to have to still find the new formula of g and then find its x-intercept. We're going to have to look at how this graph is moving, and you have to always think about this because this is not always the case. First of all, how is this graph moving? Look at the translation going on. We're saying h of x plus 3. Okay, this 3 that is being added to the x, it's only affecting the x. When you are moving a graph and you're only affecting the x, this means that this is either a left or a right movement. Okay, those are the things that affect x. Because if I had a Cartesian plane and I had a point and I called this 1 and 2, and I said, okay, let's move 2 units to the right. If we just move this point 2 units to the right, like 1, 2, our new point is going to be 3 and 2. As you can see, only the x was affected. So when you see only x is being affected, this is either a left or a right movement. Now, because it's saying plus 3, this, I know normally most people will be thinking, oh, because it says plus, it must be a right. It doesn't work like that with graphs when it has to do with the actual equation of the graph, okay? When it says plus, it's actually moving to the left. When it says minus, it's moving to the right. So because we have plus 3, it means this graph is moving 3 units to the left. Okay, so that's all we know about this graph. It's moving 3 units to the left. Okay, so think about however this graph looks, which we already have. We have this graph already. It's only moving 3 units to the left. So if you think about that, the way this graph is just moving 3 units to the left, all that happens is if it moves 3 units to the left, right? This was the old x-intercept. That's where it intersected the x-axis. The new x-intercept, okay, is just going to be this point that moves 3 units to the left. Okay, so we're just going to have to find out now what it's going to be. It's just still moving on the same line. What is this going to be now? We knew this one was a half, right? And now it's just moving 3 units to the left. Now, we're not working with the actual equation of the graph. We're moving them as coordinates, okay? We're starting here and we're moving 3 units to the left. When you move to the left, you're going to subtract. This is when you're working with coordinates. We're actually taking a coordinate on the Cartesian plane and moving it. So from a half, you're going to move 3 units to the left, meaning you need to minus 3 because we're moving to the left on the Cartesian plane. And so whatever a half minus 3 is, that's going to be your x value, okay, of your new x-intercept. So in order to find that, we can just say x is actually just equal to, we're starting at a half and we're moving 3 units to the left on the Cartesian plane. That's why I'm saying minus 3, okay? So when it has to do with notation, it's plus 3 so that you can apply it to the graph. But when you're deliberately moving on the Cartesian plane, you have to actually move according to the direction. Left will be minus, right will be plus. Okay, so x is equal to whatever this is going to be. So you can put this onto the calculator and see what you get. Okay, and a half minus 3, I get negative 5 over 2. So it means that x is equal to negative 5 over 2. Okay, now you see they do ask you to only write down the x coordinate, okay, of the x-intercept of g. So this is fine. You don't have to write it as a coordinate. Okay, moving on to the next question. 4.1.4 says the equation of the axis of symmetry of H is y is equal to x plus t. We have to determine the value of t. So they just want that last point. Okay, they gave us the equation of that axis of symmetry. Please notice y is equal to x plus t. They're telling us the gradient of this. It is in the form of y is equal to mx plus c. So it means that our gradient m is actually equal to 1. So clearly they're asking us for the equation of the axis of symmetry of h, that hyperbola, with a positive gradient. Okay, so you have to think about the equation of the axis of symmetry, how they work. When you have a hyperbola, you have axis of symmetry on these hyperbolas. So something like that and like that, right? So the axis of symmetry is the line that really just divides the graphs into two equal parts. They make the graphs look symmetrical on the one side and the other side. So there are two. There's one with a positive gradient. The one with a positive gradient has an increasing function, straight line. So the straight line is increasing. You read functions from the left moving to the right. As you can see, if you read it like that, you can see that this graph is increasing. So this is the straight line, right? That axis of symmetry of the hyperbola with a positive gradient. And its equation is very simple. If you remember the general equation of hyperbola, you will remember this one. The general equation of hyperbola is y is equal to a over x minus p plus q. All you have to just say is, oh, x minus p plus q. That's all. So the equation of that straight line, that axis of symmetry with a positive gradient, is y is equal to x minus p plus q. That's all. Okay, so I'm not really going to deal with the negative one because the question is not asking for that here. So we just need to find the value of p and the value of q. Now, not their value of p and their value of q, okay? Now, this does not refer to their value of p, okay? It refers to the original value of p. So, in this case, we're saying we know that p was equal to 1, okay? Positive 1. When we look at it as a graph, okay, this is your vertical asymptote. So originally, not here, they altered that a bit. P is equal to 1, as we can see here, and Q is equal to 2. So we're going to use those values, the original one of it. Okay, so we're just saying that finally it just means that y is equal to, let me just put that in black, y is equal to x minus our p is 1 and our q is positive 2. So we have y is equal to x. Negative 1 plus 2 is positive 1. And so remember, the question was for you to determine the value of t. So it means that if it is in this format, we can now see that t is actually equal to 1. So just conclude, therefore, t is equal to 1. And that's our final answer. Okay, so I'm adding this to the explanation on 4.1.4 because when I was looking at this question while editing, I noticed that it's actually an easier way to solve this. Remember, it's only worth 2 marks. Notice that in the beginning, they already give you the equation of this line. They just don't give you the value of t, and you have to find that. Since they gave you the equation of the line, this really helps us a lot because, so this is just an alternative way of solving this. So we could have said y is equal to x plus t, and then since this is an equation and only one thing is missing, if we had an x and an y value to substitute into this equation, we will be able to find the value of t. Now the thing is, we actually do have an x and a y value to substitute. Do you remember that in the beginning, they mentioned that we had the asymptotes of h intersect at this? You see, where you have your asymptotes, and let me just remove this because this is for the explanation of the next question. Okay, when we have the asymptotes, this is what we have. You see that the vertical asymptote is 1, the horizontal is 2, and do you see that they intersect at this point? The point they intersect at is going to be that x value 1 and the y value of 2. That's why they mentioned that. So that line of symmetry, okay, the line of symmetry, whether you're taking the one with the positive gradient or the negative. But of course, it's going to be the one with the positive gradient in this case, because they told you that your gradient was clearly 1 in the equation. Okay, so if we're looking at this one with a positive gradient, then we have a point of intersection. We have a point on this line. So to find t, you're just going to have to substitute this point of intersection 1 and 2. So we could have just done that instead. So this is what we're going to do instead. We have 1 and 2, which we're going to substitute into this equation as your x and your y value. So that would be 2 is equal to x is 1 plus t, and then you just take 1 over, and you'd get that 2 minus 1 is equal to t, and so therefore t would be equal to 1. So there is an alternative way of substituting, and here you're definitely going to get your mark, first of all, for your substituting of those 2 points and for your answer of t. In a way, when I look at it like that, it kind of also seems as if you're getting a mark for substituting the value of p and q and then your answer of t. I think it can be used like that. Okay, but this is an alternative way of doing that, and that's how you can get t. Okay, moving on to the next question. Then 4.1.5 says determine the values of x for which negative 2 is less than or equal to 1 over x minus 1. Don't get afraid when you see these types of questions. You need to just actually put this in its correct order. What they did is they took the graph of h, and you see the graph of h was, we know h of x was equal to 1 over x minus 1 plus 2. And all they did was took the 2 and put it over. So just bring the 2 back and then it will make more sense. So this equation is actually, if we take this negative 2 over on this hand side, on the left, we're going to have 0 is equal to, not equal to, less than or equal to 1 over x minus 1. And then this is going over, so we have plus 2. Now this makes more sense. So they're just saying we need to find, and let me just rewrite it in a way that this comes first, so it just looks simpler. So I'm saying 1 over x minus 1 plus 2, but you still have to follow what the sign says. So I'm going to put the 0 here, and you need to show what exactly, okay, this is saying. Notice that the inequality, the mouth, right, this open side is facing this. So it is to face this expression. So we're going to draw it facing the expression, and we have an equal to. So this is really what they're saying. You need to solve or find the values of x for which this, okay, the graph of h is going to be greater than or equal to 0. That's what we're just trying to find out. Where is this going to be greater than or equal to 0? Okay, so remember, h of x refers to the y values of the graph. So we're just looking for where are the y values either greater than or equal to 0. Okay, so if we look at the graph, where are the y values of this graph greater than or equal to 0? So where are they greater than or equal to 0? Looking at the y-axis, because they're y values. The y values that are either greater or equal to 0, they start here. They start at 0, and then there's everything above here. These are all y values that are greater than 0, and this is a y value equal to 0. You're going to highlight the parts of the graph that have y values greater than or equal to 0. So that would be here. If we look at this graph, see, it has a y value equal to 0. And then here, it has y values greater than 0. And here as well. And all the way here, everything here on the graph has y values that are either equal to 0 or greater than 0. All of these y values are positive. But then it doesn't only happen on this part of the graph. You see here after the asymptote, we also have here this point over here. It has a y value greater than 0, and this point greater than 0 as well. So everything here, okay, and above also has y values that are greater than 0. Okay, so we're only going to take everything that has been highlighted now in red. We have to answer them in terms of x. Okay, so let's see how we can answer them. First of all, the y values that were greater, okay, or equal to 0. The y value that was equal to 0, the x value that belongs to that, as you can see here, that is an x-intercept. And we knew what that was. That was a half. Okay, so we know here it starts at a half, okay, where x is equal to a half, and then these parts of the graph we also have to take. So what are the x values that belong to these parts of the graph? Well, let's highlight it down to the x-axis and see where this belongs. So as you can see, look at these x values. These are values that are what? Than a half. You have to compare it to a half. There's nothing else to compare to, because at a half, we have y values that are equal to 0, or y value that is equal to 0. So this is where x is either equal to a half or less than a half, because you see it's moving towards the left-hand side. These x values are values that are smaller than a half. So that's one part of the solution, where x is either less than or equal to a half. Okay, so that's one side that we have. Then we have to look at this other side, because this was also highlighted. Okay, so let's find out what are the x values that belong to this highlighted part of this graph. Well, notice that after the 1, right, then you're going to have the x value that belongs to this highlighted part of the graph is going to be somewhere up there. And of course, that has a y value greater than 0. So we're going to take these. If you highlight them, you see where these are coming from now. They are heading towards the right-hand side, but they start after 1. They cannot start at 1. It's not possible because there's an asymptote here. We don't have any solution here. That's why there's an asymptote. So these are values that are greater than 1. So x is either less than or equal to a half, or x is greater than 1, not equal to 1. So this is our solution for this. There's no other, we can't really see any other place that this happens except for those two places. So we say that x is less than or equal to a half, x is less than or equal to a half, or x is greater than 1. And that's going to be our answer for that question. Okay, and now we move on to the next question. Okay, so on the next question, we have 4.2. They say the graphs of f of x is equal to x squared minus 4x minus 5, and g of x is equal to a times 2 to the power of x plus q are sketched below. So we have a parabola and we have an exponential function. Okay, and now they say that e and h are the x-intercepts of f. Okay, so we have e and h, x-intercepts. They tell us that c is the y-intercept of f. Okay, and it lies on the asymptote of g. So that's going to give us a lot of information about that asymptote, seeing that this is a y-intercept, so it has a y value. And then they say the two graphs intersect at D, the turning point of f. Okay, also going to give us a lot of information about this graph of g. So the first question is to write down the y coordinate of c. So just the y value of c. Well, c, like they said, is the y-intercept of f. Okay, and they gave you the equation, the formula of that graph. Remember, it's in the form of ax squared plus bx plus c. So they're telling us already what the y-intercept is. This c, the small letter c at the end, always stands for your y-intercept. So we know now the y-intercept is -5. So obviously as a coordinate, that will be 0 and -5. But they're only really asking you for the y coordinate of c. So to find the y coordinate of c, we just say y is equal to, and what is that y value? We found out that it is -5. So -5. Then 4.2.2 says determine the coordinates of D. So to find the coordinates of D, remember this is the turning point, like they told us, the turning point of F. So we already have C, let's just put that down, that is -5 over there. And now to find D. Well, they gave us the equation of f of x and it's in standard form. So to find the turning point when your equation is in standard form, you find it like this. Let me just rewrite what we have. Okay, so this is f of x, and to find that turning point, you're going to have to use this formula. X is equal to -b over 2a. There is a longer method where you have to complete the square, but that takes too long. You can just use this formula instead. So when we have this now, we can go ahead and say x is equal to negative, and our b value, as you can see, is -4. A is 1, okay, and that's really all we need, b and a. So bracket -4, open, and then over 2, then times 1. Then let's go ahead and find this. So that's just going to give you positive 4. Positive 4 divided by 2 is 2. So x is equal to 2. So this is the x value belonging to the turning point. So if the x value is 2, to find the y value, just substitute this 2 into the equation of this graph and to give you the y value. So we're just going to take 2 and substitute it into f of x. So we're saying f of 2 is equal to 2 all squared minus 4 times 2 minus 5. And you can substitute this into the calculator. And we get negative 9. So f of 2 is equal to negative 9. And so the coordinates of D is really D is just 2 and negative 9. Okay, so that is 4.2.2. Moving on to the next question. Okay, 4.2.3 says determine the values of A and Q. So A and Q, that was from the, yes, okay, so this was from the exponential graph. So A and Q. Well, to find Q, whenever you're trying to find a hyperbola or an exponential function, you have to start with your asymptotes. If you find your asymptotes, and then you'll be able to find the other variables that may be missing by just using like a point, okay? So as long as you have an x and a y value. So to find Q, well, they told us something very important about that. They specifically said that C, right, that y-intercept that lies on F, that it also lies on the asymptote of G. That is a very important piece of information. Because this point 0 and negative 5 lies on G, its y value is negative 5. That means that this asymptote is passing negative 5 on the y-axis. So because it's a horizontal asymptote, it is passing negative 5. It means that that horizontal asymptote, the equation of it is y is equal to negative 5. So we know that now, and so that means we know the value of Q. That Q is actually equal to negative 5. So we can put that down first. Q is equal to negative 5. Okay. Then now that we have Q, it means only one thing is missing. In equations, when you only have one variable missing, you usually only need one piece of information to find that missing variable. So it means that in this equation, we just need at least 1 point in order to find that. So looking at the graph of G, what other points do we have on G? We have D, okay, the point of intersection of F and G. They said that they intersect here, so it means they have the same point. So because we already found the coordinates of D, which was negative 2 and negative 9, negative 2 and 2 and 9, sorry, negative 9. So 2 and negative 9, we can substitute this into this equation and we would find A. Okay, so let me just rewrite that equation down. Okay, so this is the equation, but we know now that the Q value is negative 5. And now we just know we just have to substitute that point D, which of course we knew was 2 and negative 9. So if we substitute this, we'll find the value of A. This is your X value, this is your Y value. So I'm saying the Y value is negative 9 is equal to, we have A multiplied by 2 raised to the power of 2. So we've substituted X and Y into the equation now. Then we have, of course, minus 5. Now, in order to solve for this, as you can see on this side, on the right hand side, we have two terms. This is the first term and this is the second term. Remember, terms are separated by plus and minus signs. So we need to get rid of, since the A is already multiplying to this, we have to get rid of the negative 5. And you can do that by taking it over. Okay, since it's minus 5, you take it over, it becomes a plus 5. So that is 5 minus 9. Okay, is equal to A multiplied by 2 squared. 2 squared is 4. So that's A times 4. 5 minus 9, that gives you negative 4 is equal to A times 4. And then we just need to solve for A. So get rid of the 4 by dividing both sides of the equation by 4. And so that means that A is actually equal to negative 4 over 4, which is negative 1. So there we got A as well. Okay, so remember they did say find the values of A and Q. So this is Q and this is A. And there we go. So we move on now to the next question, 4.2.4. Then question 4.2.4, write down the range of G. So they're asking a lot of questions that you should know about specific types of graphs. So the graph of G is an exponential graph. We know the equation of the graph. We also know the asymptote. The range of it depends on how it looks, okay? So because this graph is below the asymptote, it's only going to have, remember the range refers to all the possible y values of the graph. Because it lies below its asymptote, it's only going to have y values that lie below this. It's going to have a y value here, and here, and here. It's only going to have y values that lie below the asymptote. It won't have any y values above here because the graph is not even here. Okay, no, there's no G here, but it's all down here. So to find the range of this graph, you're saying that the range of all the possible values of y is where y is going to be, and look at the direction it's heading down, okay? It's going to be less than -5. Now, you don't say less than or equal to. This is not a parabola. At this point, okay, at -5, that y value, we have an asymptote. So it means the graph will never touch this. So it doesn't have a y value of -5, but it does have y values that are all less than -5. So that will be your range. So y is less than -5. Okay, moving on to the next question. Okay, so the last question in question 4 says, determine the values of k for which the value of f of x minus k will always be positive. So we're taking this graph f of x minus k, right? And we need to find the values of k for which this will always be positive, for which it will always be. So positive just means the y value needs to be greater than 0. Okay, so we have to actually look at the graph to be able to move this. So we're looking at the parabola f, right? And we have to move this graph in such a way that it's always going to be positive. So right now, you see, the thing is that it has negative y values. Okay, this point over here, its y value is negative. That point over there, its y value is negative. We don't want that to happen. We want everything to be positive. You have to catch it from where the y values start. This graph's y values, because it's a parabola, it starts here at the turning point. This is the last place, okay, it's going to have this y value. So if we can actually move this graph in a way that its y value will not be negative anymore, then it's always going to be positive. So think about how to move it. If you moved it down, that would not solve the problem because now your graph is sitting here and it still has negative y values. It has even more negative y values. So you have to move the graph up instead. So we're going to move the graph up. So if we move the graph up, let me just draw a parabola and pull it up. Okay, so this is our parabola. If it was here before, we have to move it up. But how far up? You see, if you just move it till here, that doesn't really help. It still has a negative y value. So if you move it all the way to the x-axis, and it's sitting on the x-axis, then we can see that if you just move it any further than this, then it's going to always have y values that are positive. So we just want it to have y values that are positive, not necessarily 0, just positive. So it needs to go beyond this point. So how far up did we move it? Well, we moved it up by going from this point to this point. And if you're looking at the y values, that is from -9 all the way to 0. So we moved it 9 units up. It needs to just move by 9 units up. But now we need to know how to actually say that to them given what they told us. They told us that the graph that we have is f of x minus k. And we need to determine the values of k for which it's going to always be positive. So f of x minus k, this is what we have, f of x minus k. So think about what k needs to be for this graph to shift up. If you just said f of x minus 9, this would not work if you made k equal to 9, because f of x minus 9 means you are taking the graph and actually moving it down. So be careful because they put a minus there. We need to make this f of x minus and then minus 9. That way, if we multiply the negative times that negative, we have f of x plus 9. And now that we have this graph will move up. So we have to be able to monitor this and see what should k be for this graph to constantly have positive y values. Okay, so we already know it has to do with k and negative 9. We just need to know, should it be greater than, should it be less than? Okay, if you made k to be greater, and that's where you have to think about the type of numbers that you have. If you made k to be greater than negative 9, you have to think about the types of numbers that are greater than negative 9. On a number line, right? Negative 9, let's say negative 9 was here. Numbers greater than negative 9 will be moving towards the right. These are numbers like negative 8 and negative 7, you see. So looking at this graph, it has to move more than 9 units for it to even touch the x-intercept, okay, the x-axis. Okay, so thinking about these numbers, if you had to make x greater than negative 9, then you're going to say that, k greater than negative 9. Then you're basically saying that k can be numbers like negative 8. Well, let's see if this actually solves the problem if we make k equal to negative 8, okay? If you said f of x, and then you said minus negative 8, right? Then we have f of x, and then if you multiply, that becomes plus 8. Well, f of x plus 8, it needs to be able to move this graph in a way that it's always going to be positive. If you move it, this means we're moving the graph 8 units up. If you move this graph 8 units up, that does not solve the problem because it's only moving 8 units up. And so it's going to land here, meaning your graph still has negative y values. That's the thing. You have to think about the type of numbers that you have. So clearly, if you make k greater than negative 9, it's not going to work. Let's think about the other direction then. How about we make it to be less than negative 9? So think of numbers that are less than negative 9. That will be things like negative 10, negative 11, and so on. So let's say k was equal to negative 10, right? It's just substitute in place of k negative 10. So now we're making it less than, okay? So f of x needs to be, and then we have minus, and the k is negative 10. So if you multiply this in, you have f of x plus 10, which is great because now it means that this graph is going to move 10 units up. See, when it reaches 9 units, it moves an extra unit, and now the graph is here. There. Everything that moves beyond 9 units is always going to be positive. This graph will always have positive y values. So that's why you have to think about it as in the relationship between numbers. So this means that k must not be greater than negative 9, because you see numbers greater than negative 9 are negative 8 and negative 7, and that's not enough to move the graph. You need to get the graph to a point that it actually moves beyond this so that it can have positive y values. So k just needs to be less than negative 9. You need to think about that carefully, okay, with your graph. So k is less than negative 9. That is our answer for this question. And that is it. So that is the end of question 4. And then we'll move on to question 5. Okay, so question 5, we have been given this. So the graphs of g of x is equal to 2x plus 6, and we have the inverse of g are shown in the diagram below. D and B are the x and y intercepts respectively of g. So there we go, we have D and B. And then they tell us that C is the x-intercept of the inverse. Okay, the graphs of g and the inverse intersect at A. Okay, so you see, your knowledge on inverse is going to help you a lot on inverse functions. So the first question we have, write down the y coordinate of B. Okay, so the y coordinate of B. Let me just get rid of these ones because I just want to work on each question one by one. Okay, so they want the y coordinate of B. So I'm already saying y is equal to, so let's see what B is. As you can see, B is on the y-axis, okay? And it's on this graph of G. So it is the y-intercept of B. And they already told us that as well. So since it's the y-intercept, then remember, do we have the equation of G? We do. We have the equation of G. This is the equation of G. And it's in the form of y is equal to mx plus c. So if that is our gradient and this is our c, c is always your y-intercept. So it means that the y-intercept is 6. So that y value of B is 6. Okay, So y is equal to 6. So as a coordinate, it's of course going to be 0 and 6 because the x value is 0. Okay, so that's the first question. Moving on to the next question. The next question says determine the equation of g of, g negative 1, which is the inverse, in the form of, so in this form. So we need to make sure that that notation is also correct. So we're just finding the inverse. Okay, so to find the inverse equation, you're just going to take the original one and we're going to write it as y is equal to 2x plus 6 first of all. Now that we have it in this format, you're going to swap the x and the y value. So in place of y, we're going to put x, and in place of x, we're going to put y. So 2y plus 6. Then you're going to try and make y the subject. So to make y the subject here, we first have to get rid of this positive 6. So we can take that over. And so that is going to become x minus 6 is equal to 2y. Now to solve for the y, to make that the subject, you have to get rid of the 2 by dividing both hand sides by 2. So this is really saying that y is equal to, so this is what we have here. Now remember, in front of the x, there's actually a number. There's an invisible 1 in front of the x. So if you look at this, this is saying 1x divided by 2. You can say the 1 divided by 2, which is just 1 over 2, and then put the x there. And then we have negative 6 divided by 2, which is negative 3. Okay, so this is the equation, but remember you need to write it in that format. So I will just leave it as this is g negative 1 of x. The inverse is equal to a half x minus 3. And that is our equation. Okay, moving on to the next question. Okay, 5.3 says we have to determine the coordinates of A. So look at A. A is the point of intersection between these two graphs. So it's great that we have the equation of G and we also have the inverses equation. If you want to find the point of intersection, this is the point where their x and their y values are exactly the same. So to find the point of intersection, you would make this equation equal to this equation. So we're going to take the equation of g of x and we're going to make it equal to the inverse of g. Okay, so that is going to be, like we already know, this one is 2x plus 6. That's the equation of g of x. 2x plus 6 is equal to a half x minus 3. Okay, so just have to solve for x now. So I'm going to put the x's on one side. So we have 2x, and I'm taking that x over, which becomes a negative, a half x, is equal to, and we have negative 3 still on this side, and we're taking the 6 over, and that becomes a negative 6. So 2 minus a half is going to give you 3 over 2, okay, because that is 1.5. 2, just take away a half. Okay, so 3 over 2x is equal to, and then we have negative 9. Now we just have to solve for x. So we're going to divide both hand sides by 3 over 2. So divide by 3 over 2 and divide by 3 over 2. Okay, so we can go ahead and divide. Okay, so negative 9 divided by 3 over 2 is negative 6. So it just means that x is equal to negative 6. That's the x value of this point of A. We found its x value. Now, in order to find its y value, just remember that it lies on both lines. It lies on G and on the inverse. So you can substitute that x value into either one of these equations. It's still going to give you that y value since this is the x value over here. Okay, so I'm just going to choose the easier one, the one that seems easier. I'll go with the 2x plus 6. So I'm substituting into g of x. So g of negative 6 is equal to 2 times negative 6 plus 6. And let's just see what we get here. So that's going to give you negative 12. Negative 12 plus 6 is negative 6. So our coordinate is for A is just negative 6 and negative 6. Okay, so that is question number 5.3, and that is for 3 marks. Moving on to the next question. Okay, the second last question is calculate the length of AB. So the length of AB, to find that, we just need the coordinates of A, which we know is negative 6 and negative 6, and the coordinates of B. Now, with B, we already found that before. We know that B, the y value is 6 because it was the y-intercept of G. So it means its coordinate is going to be 0 and 6. So that's really all there. So B is 0 and 6. Then you're going to have to remember the formula for the length of a line. So the length of a line, we find that by saying AB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, even if you started with the y2 minus y1 or the x2 minus x1, it doesn't matter. It will still be the same thing. So AB is equal to, okay, so you also can label these. This will be x1, this will be y1. Those are your two first points. Then this is x2 and y2. So this is the square root of 0 minus negative 6. So minus negative 6 will end up just becoming a positive 6. So that's just plus 6 all squared. Then plus we have y2, which is 6 minus negative 6 as well. So that just becomes plus 6 all squared. And so AB is equal to, and we can just substitute this into the calculator and see what we get. Okay, so this is what we get. Okay, then you can round off to 2 decimal places. So that is going to be 13.42. So round it off to 2 decimal places because 6 is higher than 5. So rounds up basically and adds a 1 to that one. So we have 13.42, and that is the amount of units that AB would be. Okay, and now we move on to the last question in question 5. Okay, so the last question, 5.5, says we have to calculate the area of triangle ABC. Okay, so triangle ABC. So let me just draw the triangle out so that we can look at it and see how we can find the area of this. Okay, so this is the triangle that we have. And looking at this, there's a number of ways that you can find the area of this triangle. So I'm going to just try 2 methods here, but then there would be, of course, other methods that you can use. First method, we're trying to find the area of this triangle. We can use the area rule. And the reason I'm saying the area rule is because we already have the length of AB. So the area of AB, that was, we already said this is 6 square root 5. Okay, so I'm going to use it as this, just so that the answer can be perfect. Even if you used it as this, I don't see a problem because AB was one of the things they actually asked for. Okay, but to be safe, I'll just take 6 square root 5. So if we're using 6 root 5 as AB, now there's something about AC. We can actually find this. Okay, the thing about AC, the length of it, well, we can find the coordinate of C if we want to, because remember, G is the original function and this is the inverse. So the X and Y values just swap. So think about it like this. This coordinate of 0 and 6, right, on the original graph. On the inverse, this coordinate is going to be 6 and 0. Okay, so that is an x-intercept. That is going to be what C is. C is the x-intercept. So then that one is going to be 6 and 0 because the X and Y values just swap. Then you could have gone and just found the length of AC. But in a way, you don't have to actually do this. The reason why is because the original function, okay, and the inverse, they are symmetrical about that line y is equal to x. So if we drew that line y is equal to x, then these two are going to be symmetrical about this line. So it means that we have this point A over here. But for example, if we get to B, right, whatever this line is doing from A to B is exactly what this line is going to do from A to C, since that is the inverse of this point over here. Meaning these two lengths, AB and AC, they're going to be exactly the same. Okay, and really this is because if you wanted to go ahead and find the length of this line, you will notice that you have AC, right? It's equal to the square root of, if we are taking the X and the Y values, I'll start here. So that is still 6 minus negative 6, which is of course 6 plus 6 all squared, plus 0 minus negative 6, which is 0 plus 6 all squared. That looks familiar again. We still have a 6 plus 6 all squared and a 0 plus 6 all squared, which is the exact same thing we did. Very similar, just, you know, this one is now first. It's the same thing we did to find AB. So that's why I'm saying they're really the same length. You don't actually have to find AC. We know that they're the same length. So this is also 6 square root 5. So notice I just found the two sides, okay? This side AB and this side AC. What we can do now is we can find this angle in between. So if we find this angle over here, we'll be able to find the area of this triangle using the area rule. Okay, so all I'm going to say so long is I know the coordinates of C, that's 6 and 0, and I know that AB is equal to AC. That's all I'm going to put down so long. Okay, so this is all I put down for now. So AC is equal to AB, which is 6 square root 5. Okay, now that we have that down, we just have to find that angle, this big angle over here. Now to do that, we have to use angle of inclination. So to find the angle of inclination, okay, let's just see how this angle is formed. It doesn't mean that this is just formed by finding the angle of inclination of something. First of all, we have to do this. Draw a imaginary x-axis. Draw an imaginary x-axis. So if we do that, let's see how this angle in yellow is formed. We can find that angle by finding, first of all, the angle of inclination of the line AB. So if we find the angle of inclination of AB, that entire line, right? And then we find the angle of inclination of the line AC, this angle. And then if we take this big angle and we subtract it by this little angle, we will be left with this angle. So that's how we can find this angle in yellow, that angle BAC. So let's go ahead and find the angle of inclination of these lines. So we're going to start with the red one, the angle of inclination of AB first. So we'll find that by saying tan of theta, I'm going to call that theta of AB, so I remember that it belongs to AB, is equal to the gradient. So now what is the gradient of AB? Well, we have the equation of the lines, so we know what the gradient of AB is. AB is on this line of G, and this was its equation, meaning its gradient, M, is 2. So we know that. Now we know that M is equal to 2, so I'm just saying tan of theta is equal to 2. Then we can solve for theta of AB. So I'm saying theta of AB is equal to, and we're taking tan over, and it becomes the inverse of tan, shift tan of 2. So on your calculator, you're just going to press shift and then tan, the second function of tan, and of 2, and we get 63.43. Okay, so I don't want to round off yet. I want to round off at the end. So I'm just going to leave this as AB. Theta of AB is equal to 63.43 and then 4. Okay, I'm not rounding off yet, so we'll probably just use it as this. Then after finding that, we have to find the next angle of inclination. So we just found the one for the red line. Now we have to find the angle of inclination, okay, for this blue angle over here, which is the angle of inclination of the line AC. So let's find that angle now. So AC, we also have the equation of AC because it's the inverse of G. The equation of that was 1 over 2 and then 1 over 2x and then minus 3. So we know the gradient, it's 1 over 2. So we could just put that down. So finding theta of AC now. So tan of theta of AC is equal to, the gradient is 1 over 2. So theta of AC is equal to second function of tan, and we have 1 over 2. Then theta of AC is equal to, and we can also find that if we want. It's not even necessary to be finding these. What we can do is, I'm just going to still put the answer, but I'm not really going to use it as a decimal. So 1 over 2, which is 26.565. So 26.565, and I'm not rounding off yet. The whole goal here is just to find that angle inside this one. So remember again, we find this angle by taking this larger angle minus this little angle. Okay, so I'm just finding that angle BAC. So I'm going to name it. I'm going to take the bigger angle minus the smaller angle. So BAC, we'll find that angle by saying theta of AB minus theta of AC. Okay, and that's why I don't know why I found it like this. I could have just taken it as shift tan of 2 minus shift tan of a half, just so that nothing is rounded off. Okay, so this is the shift tan of 2. That's the bigger line, okay, the bigger angle. And shift tan of a half, of course, is the smaller one, AC, that one. Okay, so we know now BAC is equal to 36.87 degrees. And now we can use that angle, okay. But of course, if you want it to be exact, then I would suggest that you just use it like this rather, as it is here. Okay, theta of AB minus theta of AC. So this is what I mean. So remember, we're trying to find the area of that triangle ABC. So A, B, and C. And we're using the area rule. So the area rule says half multiplied by, now see, we're multiplying by this line AB multiplied by AC, and then we're going to say sine of this angle in the middle. Okay, so multiply by AB, multiply by AC, and then sine of angle BAC. So if we do this, this is going to be a half multiplied by AB. We already knew that to be 6 square root 5. And of course, AC is also 6 square root 5. So multiply by 6 square root 5. Then we're saying sine of this angle. So if you want to be exact, instead of using this that has already been rounded off, you could have said sine of, then put all of that in. So shift tan of 2 minus shift tan of 1 over 2. Okay, so you could also just do that, just to be exact. Or you could use this, but maybe a decimal might be off. It also might not be, but then again, we are multiplying, so that could happen. So I'm just going to go ahead and say a half multiplied by 6 square root 5, again multiplied by 6 square root 5, and then make sure you're coming out of that radical. And then you say sine of, and I'm going to say shift tan of 2 minus shift tan of a half, and then when I come out of that, close the bracket and close finally that bracket for everything, and we get 54. So it means that it is 54 units. I think if we rounded off, it would have definitely affected it. Let's see. So if we rounded off and we use this angle instead of putting all of this in, like how we find the angle, I'm sure it would have just given you a rounded off answer. Okay, so you see, it wasn't going to affect it that badly because you would have still known, oh, okay, this is 54 units. So it wouldn't have been a bad thing. It's still fine. Okay, so that is the way to find that 54 units squared. Okay, and let me just show a second way of doing this that I see that we can also do this. And I'm just going to show this method because this isn't really, this is a video. It's not a one-on-one session where, you know, we're working against time or anything. So we can go ahead and look at this diagram again. See, the second method that you could use is, first of all, instead of finding an angle, we could just use the fact that we know naturally the area of a triangle is equal to, or right angle triangle, a half multiplied by the base multiplied by the height. But we would need a perpendicular height for this. So we can actually construct one. You see, the fact that these two, okay, are the inverse of each other, it means they're symmetrical across this line, y is equal to x. So this can become our perpendicular bisector. This line is going to bisect BC, right, into two equal parts, and so it's going to be perpendicular to BC. So this can be our height. Now we can go ahead and try and find the height of this triangle. And then if we have the height, we also have the base of the triangle, and we can just use that to find the area of it. So in this one, the only thing that you have to work on now is you don't have to find any angles. You just have to focus on trying to find the length of BC and that perpendicular height. Okay, so that's just from here, of course, to that point of intersection. Okay, so to find that height, first of all, you would need the coordinate of C. When you find the coordinate of C, just knowing that it is the inverse of B as 6 and 0, you would be able to find now the midpoint. Since we know this is a perpendicular bisector, okay, it's perpendicular to this. So we would find the midpoint of this, and that would be, of course, the points that we have here, that intersection of our height and BC, that. Okay, so let's go ahead and find BC first, the length of BC. So we know that B is 0 and 6, and C is 6 and 0. And let's see what we get. That's really 6 squared and negative 6 squared. And that is going to give us this. But it's better to leave it as a set. So we're just going to leave it as a set, 6 square root of 2. So BC is equal to 6 square root 2. We have BC now. Now all we have to find is, we just need to find this height. To find the height, remember, BC, right? The midpoint of BC is going to be this point that we have over here. So let's just find that midpoint. Finding the midpoint of BC now. Okay, so we're going to say midpoint of BC. So we're going to find this by saying x1 plus x2 over 2. So that's x1, 0 plus 6 over 2. And then, of course, y1 plus y2 over 2. So that is 6 plus 0 over 2. That's just going to end up being 6 over 2, which is 3. And that's also 6 over 2, which is also 3. So that's 3 and 3. Okay, so we have that midpoint now. It's just 3 and 3. I'm going to call it M, which is 3 and 3. Okay, now that we have this, we just want to find this perpendicular height, this AM. Okay, so we're going to call it the perpendicular height. So A is negative 6 and 6, M is 3 and 3. So here we have these, and I'm just going to find AM, or that perpendicular height. So that is going to be equal to the square root of, and we're saying x2 minus x1. So I'm just going to say 3 minus negative 6, which becomes a plus 6 whole squared, plus same thing, 3 plus 6 whole squared. And then if we find this is going to, let's just see what it gives us and put it in third form. So we get 9 square root 2, 9 square root 2. And now we have everything to find the area of this triangle. So the area of the triangle, again, is going to be found by saying a half times the base times the height. We have the base of BC, we have the height of this. So we can just find it now. Area of this triangle. So now I'm just going to put that formula down. The area of triangle ABC, we find that by saying a half multiplied by the base multiplied by the height. So the base was BC, multiplied by the perpendicular height. Okay, and I'm just going to leave this as the perpendicular height like that. So that is a half multiplied by BC, which we know BC was 6 square root of 2. So that's 6 square root 2 multiplied by the perpendicular height, which is 9 square root of 2. And there, again, we get 54 units. So you see, it still agrees with each other. Whether you use the area rule or use the area of a triangle with a perpendicular height, we still get 54 units. Okay, so now we're on question 4, and 4.1 says, given the function p of x is equal to 1 over 3 raised to the power of x, 4.1.1, is p an increasing or decreasing function? Okay, so to find out whether it's an increasing or decreasing function, this is all you can do. If the function is going to increase, how about we first find out if we substitute 1 in place of x? So it's kind of like looking at it as a graph. If we have 1 here and 2 here, let's just find out whether it's going to increase or decrease. So substitute 1. So I'm saying p of 1, which is going to be 1 over 3 all raised to the power of 1. And that will just give us 1 over 3. Okay, so let's say this is our y-axis and we have 1 here. So if this is 1, when we substitute 1, we get the answer 1 over 3. Okay, so 1 and 1 over 3, maybe just here, like a third way through. Okay, then try p of 2. So substitute x value of 2 into this. So I'm going to see whether it increases or decreases. Then we can just say 1 over 3 raised to the power of 2, and this will be equal to 1 over 9. So you see, 1 over 9 is smaller than 1 over 3. You can even check the decimals on the calculator. So it means that from at 2, you have 2 and 1 over 9, which is much smaller than that. So as you can see, from this point to the next point, it decreased. Okay, we're talking about the y values. The y values are decreasing. So this graph is not an increasing function, it's a decreasing function. So that's something you could have looked at. Just see whether it increased or decreased, and that actually decreased. Okay, so you can conclude p is a decreasing function. Okay, so moving on to the next question. As you can see, that's for 1 mark. They really just wanted to see the answer. There is a way of doing it, but then that takes quite long, where you have to think about the value of A and B. You can do that as well, but it does take quite long. You could have just done that. It's easier. So question 4.1.2 says, determine p negative 1, the inverse of p in the form of y is equal to. Okay, so we have to just determine the inverse of this equation in this form. So I'm going to put this first as y is equal to not p of x. So y is equal to 1 over 3 raised to the power of x. To find the inverse of a function, first step is to swap the x and the y. So this is why I'm going to turn it into x is equal to 1 over 3 raised to the power of, this was x, I'm going to turn it into y. Then the second step is to just make y the subject. So if we make y the subject, y is on the exponent. The only way to make an exponent the subject is to use log. So we're going to say y is equal to, and now we have it's the log, and the base is going to be 1 over 3, just like it is here. This is the base carrying the exponent, so it's still the base. And then here we have the x. So there we go. Y, we have log of x with a base of 1 over 3. And that is, of course, for 2 marks. So that's 4.1.2 done. Moving on to the next question. Okay, 4.1.3 says, write down the domain of the inverse of p. Okay, so there's something you need to know about the range at the domain of an original graph and the inverse. So I'm going to put the original, and over here we speak about the inverse. So in this case, the original was that p of x, so it was equal to 1 over 3 raised to the power of x. And the inverse is the log graph. Y is equal to log, we have a base of 1 over 3 and x. And then over here, I'm going to speak about the domain of the graph and the range. So the thing about the domain and range is the original graph, whatever the domain is, whatever the original graph's domain is, that will become the range of the inverse. And whatever the range of the original graph is, that will become the domain of the inverse. So notice that they asked us to find the domain of the inverse. So the domain of the inverse is actually the range of the original. So all this means is if we can find this one, we will know exactly what the domain of the inverse graph is. So let's go ahead and find the range of the original graph. Okay, so if this is the original graph, p of x is equal to 1 over 3 to the power of x, then also notice what the value of a and b is. Because p of x is equal to 1 over 3 raised to the power of x, then if I'm putting it in terms of a and b, so I'm saying y is equal to, the way the graph is supposed to be written, the original form of an exponential graph is a bracket b to the power of x minus p plus q. So if a is greater than 0, it would just mean that your graph is going to lie above the asymptote. So wherever this asymptote is, so let's just say we have an asymptote, the graph is going to lie above the asymptote. Now we also know that this graph is decreasing, and this is an exponential function. So the graph is actually going to look like this. See, it is decreasing, moving from left to right, it is moving down. So if the graph looks like this, what is the range of this graph? Okay, so looking at the y value, so let's say this is your y-axis over here. Looking at the y values of the graph, you have an asymptote. You always have to focus on what the asymptote is. The equation of the asymptote is y is equal to q, whatever the q value is. Now, as you can see, we're supposed to have plus something or minus something, but because we don't have anything, it means the value of q is actually 0. So our q value is 0. So if that is the case, then look at the range of the graph. The range is all the possible y values that the graph can have. Notice the graph will not have any y values down here. It only has y values here. So you're going to have to find out where is your asymptote. Your asymptote is at y is equal to 0 because that's the value of q. And then notice that only from numbers that go above 0 do you have y values. Because look, this point over here, that's its y value. This point over here, that's its y value. And that's its y. It keeps having y values that are only greater than 0, but not equal to 0, because at 0 there's an asymptote. So here, the range of this graph is that y is greater than 0. Okay, so now that we found the range of the graph, we can find the domain of the inverse. If the range is y is greater than 0, then the domain of the inverse, remember it's domain, meaning it's not speaking about y values, it's speaking about all the possible x values. So that means the domain is x is greater than 0. That's how we get that answer. Okay, so that is, I just gave that explanation just so that it can make sense. You would really just have to say x is greater than 0. Okay, so that's what I meant by this paper is going to definitely be longer than 3 hours because I'm just going to be explaining certain things. And then question 4.1.4 says, write down the equation of the asymptote of p of x minus 5. Okay, so to understand what p of x minus 5 means, so we're taking the graph of p and we're moving it down by 5 units, okay? That's why it's saying the y, p of x stands for y. So you can think about it like this. If this graph, its asymptote was originally here, y is equal to 0. But now we are taking this graph and we are shifting it down by 5 units. So if this graph goes down by 5 units, the new asymptote, every y value is also going to move down by 5 units. So if this was y is equal to 0, it will move down by 5 units, meaning now it's going to be that 0 minus 5 because it's moving down. The new asymptote is going to be y is equal to negative 5. Your graph is going to be down here and it's going to have an asymptote at negative 5, at y is equal to negative 5. Okay, so that is a graphical way of looking at it. If you didn't look at it as that, you could have just done that with the equation. So the equation of this graph was 1 over 3 all to the power of x, right? That was p of x. That's what that stood for. So you'd have said 1 over 3 to the power of x. That's your p of x. Then you'd have said minus 5. And if this is the new equation that we have, the equation of the asymptote is always y is equal to whatever number is here, whatever is your q value. And so that will be negative 5. So that is the equation way of doing that. Okay, so that's the equation of your asymptote, your horizontal asymptote of this graph. Then moving on to 4.2, we are given f of x is equal to 4 over x minus 1 plus 2. 4.2.1 says, write down the equations of the asymptotes of f. So the equations of both asymptotes. So meaning the vertical and the horizontal asymptote. The vertical asymptote will always be x is equal to whatever the value of p is. And the horizontal asymptote is always going to be y is equal to whatever the value of q is. Your equation, the general equation is y is equal to a over x minus p plus q. So let's find the value of p and q so we can just put it there. So p is equal to, notice here we have a minus p. But here we have a minus 1. So think about it like this. We have p and we have 1 over there because the minus is really the minus here as well. We have x minus 1, x minus p. So it just means that p is equal to 1. That's the p value. P is equal to 1 and it means that q is equal to whatever number is here plus q, which is 2. So that's something you should always know about this. The value of p, even if you have x minus 1 here, the value of p will actually be positive 1. If it was something like x plus 2 here, the value of p would be negative 2. It always changes signs when it has to do with the p, but not the q. So this would just mean that the vertical asymptote would be x is equal to, the p value is 1, and the horizontal asymptote would be y is equal to, that q value is 2. Okay, moving on to the next question. 4.2.2 says calculate the x-intercept of f. So since f of x is equal to 4 over x minus 1 plus 2, so we just have to find the x-intercept. The x-intercept is where our y value is equal to 0. So we're just going to make y equal to 0. F of x stands for y, so we're saying 0 is equal to 4 over x minus 1 plus 2. Then we can take the 2 over, so we have a negative 2 is equal to 4 over x minus 1. Because we have a number here, a fraction here, and equal to in the middle, we can cross multiply. So we're going to just take the negative 2 and put it over 1. Then you cross multiply. It's the negative 2 being multiplied by the x minus 1. And it just really gives you this so long. I'm just saying it's a negative 2 that has to multiply into the x and the minus 1. And then it's equal to the 1 multiplied by 4, which gives you a 4. Then we need to get into the x. So we can just go ahead and divide both sides by -2. And so we have here -2 is equal to, then we have x minus 1. To make x the subject, take -1 over. -1 becomes a +1, and we still have a -2 is equal to x. So therefore, x is equal to 1 minus 2, -1. So the x-intercept, they specifically just said the x-intercept of f. That is the x-intercept. So because they're already asking us about x-intercepts, they spoke about the asymptotes, you can already expect they will ask you to draw the graph. So 4.2.3 says, sketch the graph of f, label all asymptotes, and indicate the intercepts with the axes. Remember, they want the asymptotes. We have those already. But they also want all the intercepts with the axes. So this would be your x-intercept and your y-intercept as well. Those would be that. So we already have the x-intercept. We just don't have the y-intercept. So we have to find that first. So to find the y-intercept, here's the function. To find the y-intercept, you need to make x equal to 0. Okay, so we're going to say f of, and in place of x, we're saying 0 is equal to 4 over, there's an x again, 0 minus 1 plus 2. So this is going to be equal to, so we have 4 over 0 minus 1. 0 minus 1 is -1. So 4 divided by -1 is -4 plus 2. And so -4 plus 2, that's going to give you a -2. So this is your y-intercept. So we can lay down all the points that we have. We only have x-intercept, y-intercept, and our asymptotes. So let's go ahead and put down the x-intercept. If this was the x-intercept, it means as a coordinate, it's going to be -1, and the y value is 0. See, that's why we make y equal to 0. So it's -1 and 0. And then the y-intercept, the x value, we made that 0, and the y value is -2. And then our asymptotes are also important. So our asymptote is x is equal to 1 and y is equal to 2. So with all of this, we can actually draw down the graph. Okay, so this is the Cartesian plane that I have. This is your x-axis, and that is the y-axis. So first, start with putting down your asymptotes, because this will really just help the shape of the graph so that you know what line you should not go beyond. So the vertical asymptote is x is equal to 1. Okay, so that is a vertical line, a standing line. So it's x is equal to 1 because it is a line that passes the x-axis at the point where x is equal to 1. Okay, so this is the vertical asymptote. So it also goes on to infinity, and you should always just write the equation of it. So that is the x is equal to 1. And then your horizontal asymptote is y is equal to 2. Okay, it's a horizontal line, so it will pass the y-axis, and specifically at that point 2. So it is just a horizontal line that looks like this. And you always need to write its equation. That is y is equal to 2. Okay, now that those are down, we can put the intercepts now. The first point that we have is the -1 and 0. So -1 and 0, that's our x-intercept, -1 and 0. So here's that point. You can write the coordinates if you want, but we can also see that it's intersecting at that point. So we know it is an x-intercept. Then the y-intercept is 0 and -2. So 0 on the x-axis and -2 on the y. So there we go. So that's 0, -2, that is -1 and 0. Okay, so now another thing you also should look at is the way this graph is going to look. Notice that the value of a, okay, is 4. So it's a positive number. When a is positive, it means that your graph is going to lie in the first and the third quadrant. So it's going to lie here, the first quadrant, and in the third quadrant. So you can already see these points are going to be the ones here in the third quadrant. So the graph is always going to do this. It's going to come from the asymptote, being very close to the asymptote. It's going to move here, hit -1 and 0, hit 0 and -2, and then move closer and closer to this vertical asymptote, but it will never touch it. So it's going to look like this. And of course, we'll have the arrows here. So this is just the one that is in the third quadrant. We still also need one in the first quadrant. So you can just draw it. If you like, you can substitute a point in here. Okay, then you can just draw the other wing as well. It's also just going to do something like this and move like that. And so it's going to look like that. They didn't really say anything about drawing another point because they really just want you to label the asymptotes and indicate the intercepts with the axes. And it's for 4 marks. And since it was called f of x, we can just name the graph f. Okay, so that's it for the sketching of the graph. Then the next question, 4.2.4 says, use your graphs to determine the values of x for which 4 over x minus 1 is greater or equal to negative 2. So with this question, just notice that this looks very similar to the graph that we have, the equation that we have. The only difference is we have a plus 2 here. And that's just because you have to just take this, negative 2 over. So when you do that, you have 4 over x minus 1 plus 2 is greater or equal to 0. This is actually what we need to solve for. We need to find the values of x for which the graph that we have is greater or equal to 0. And when they say that, they're referring to the y values of the graph. So where are the y values of this graph? Greater or equal to 0. Okay, so looking at the graph, here is your y values, okay? That's your y-axis. So we're looking for only the places where the y values are either equal to 0 or greater than 0. So we'll only be looking at this part, okay? So everything that has y values within here. And so you see the graph here, that's the y value, greater than 0, greater than 0. Keeps having values greater than 0 all through. And then at 2 itself, it doesn't have a y value there because there's an asymptote. And as you can see here, that has a y value greater than 0. So we're only going to be looking at this top part of the graph. Okay, nothing on the bottom because all of these have y values less than 0. So what you can do now is highlight the parts of the graph that are on top in the first and the second quadrant. That will be everything here and everything here, but stopping at negative 1. And now that we have them highlighted, we can find out which values of x belong to these highlighted parts of the graph. And I'm going to start from the left because it's easier to read numbers from the left to the right. So from the left hand side, you see that this keeps going on. It's going to keep getting closer and closer to this asymptote infinitely. So here it has an x value of here and here. Keeps having all these x values. But when did they start? Where was the y value of this graph equal to 0 in the first place? That was here at negative 1. It was equal to 0 at negative 1. And then every place that is here, all of these x values that I've marked. So these places, when you compare them to negative 1, they are values that are less than negative 1. So this happened when x was less than or equal to negative 1. Remember, we're including negative 1 because they said that this needs to be either greater or equal to 0. The y values need to be greater or equal to 0. And at negative 1, the y value is equal to 0. So negative 1 is an included point. So that would be the solution for that part of the graph, that highlighted part. Then we have to do the same to this part of the graph. I'm also going to read it from the left to the right. It's easier like that. So if you look at this graph, it's coming from a place that is very close to this asymptote. And that asymptote itself is 1. So it means after 1. Okay, something like 1.01 or something like that. You're going to have a y value in this graph that is greater than 0. So we can mark all of these parts of the graph. Here's the x value of this, and here's the x value of that. I'm only marking the x values of the highlighted parts of the graph because those highlighted parts of the graph have y values that are either greater or equal to 0. So you see these parts of the graphs, look at their x values. So the x values belonging to all these parts of the graphs is all of these values here. And these are values that are greater than 1. Okay, and I'm starting at 1. The reason I'm starting at 1 is I can't just start at 2. At 1.1, for example, we have a y value on this graph. And that y value is greater than 0. Okay, the only place there isn't a y value on this graph is here where x is equal to 1. We don't have that. So this is where x is just greater than 1. I can't say greater or equal to 1 because there is no value here. We don't have an x value here. So all of these values that are greater than 1. So those would be our solutions, where x is less than or equal to -1 or where x is greater than 1. Okay, and we don't have to write them together because as you can see, they're really pointing towards the opposite directions. These ones are going that way to the left, and these solutions are going to the right. Okay, so that's the solution, and moving on to the next question. Okay, so question 4.2.5 says, determine the equation of the axis of symmetry of f of x minus 2 that has a negative gradient. Okay, so since they're asking you for the axis of symmetry that has a negative gradient, that equation looks like this. So we have two axes of symmetry in this hyperbola. One has a positive gradient, so it's an increasing function moving upwards like that. And the equation of that one is y is equal to x minus p plus q. And this is quite easy to remember because of the general form of the hyperbola, which is y is equal to a over x minus p plus q. So you see that x minus p plus q repeating itself here again. Now the only reason I'm showing you the one with a positive gradient is because this one can help you to formulate the formula for the one with a negative gradient. And that one looks like this. So it is a decreasing function, and both of them, of course, they would pass this point where your asymptotes intersect. This one with a negative gradient is what they asked us for. That equation looks like this. Y is equal to, now in front of the x minus p, we put a negative. So put a bracket x minus p, and then we have the plus q again at the end. So this negative actually multiplies into the x and the minus p. So you have a negative x and then plus p plus q. So that's the equation of the one with a negative gradient. But then they also say, so just keep that in mind, the general equation of a graph with a negative gradient is y is equal to negative x plus p plus q. But they told us that we have to determine this equation for the graph f of x minus 2. So we need to see, what does this do to the graph? When you say x minus 2, this is only going to affect the x values of your graph. So since our graph was a is equal to 4 over x minus 1 plus 2, it's only going to affect this part of the graph. We're going to have that f of, because this was f of x, so that f of x minus 2 is going to be 4 over, we have an x, then you're going to say minus 2, okay? Then of course we have this minus 1, then the plus 2. So the new equation would be 4 over x minus 3 plus 2. And so how does this affect this? Well, it affects your value of p, but not really your value of q. So now the new value of p here is going to be, since we have minus 3 here, the value of p is positive 3. And the 2, it didn't affect that. So q is still equal to 2. So that's what this is supposed to help you with. So we're going to apply that into this equation. So our new equation of the axis of symmetry with a negative gradient is y is equal to negative x plus p, which is 3, plus q, which is 2. So that is y is equal to negative x plus 5. That is the equation of your axis of symmetry with a negative gradient if we have f of x minus 2. And that is the last question in question 4. So we just move on now to question 5. Okay, so question 5 says the graphs of the functions f of x is equal to negative x plus 3 all squared plus 4 and g of x is equal to x plus 5 are drawn below. The graphs intersect at A and B. Okay, then the first question is for us to write down the coordinates of the turning point of f. Okay, I'm going to get rid of the calculator for now because I don't really think it's helpful right now and I really just need this space. Okay, so to find the coordinates of the turning point, just remember that when the parabola is put in this form, this is turning point form, which is a bracket x minus p all squared plus q. And the turning points will basically be your p value and your q value. Remember that if you have an x plus 3 here, so plus something, the p value is actually the negative of whatever number is here. So your p value, the first x coordinate would be negative 3, and then the y coordinate would be the q, which is just stays the same. So whatever is here, that will be the y coordinate. And that is 4. So we have and positive 4. So that would be the coordinates. And you see it's just for 2 marks. Then the next question, write down the range of f. So to find the range of f, think about the fact that we know the turning point now. The turning point of this graph is -3 and 4. So if this is -3 and 4, remember the range is all the possible y values that this graph, this parabola can have. So if you look on the top here, you notice there is no parabola up here, meaning the parabola will not have y values on any part of here. Okay, there's no y values here, but it starts having a y value at this turning point first. And at this turning point, the y value that it has is 4. Then you see that, look at the point here and look at this point over here. Look at the y value. It's a y value that is below 4. And then another point on the graph, these 2 points, it's a y value that is also below 4. And this will keep happening on the parabola. It will keep having y values that are below 4. So it means that your range is that y needs to be less than or equal to 4. So we have to also say equal to 4 because 4 is also the y value of the turning point of this graph, meaning this is also a point on this graph. 4 is also a y value on this parabola. So that is our range. The range is y is less than or equal to 4. So you just have to see whether it's concave up or concave down to see what the range is going to be. Okay, then the next question is, you need to show that the x coordinates of A and B are -5 and -2 respectively. Okay, so A and B. So if we're looking at A and B, you see that these are points of intersection of these two graphs. So to find the points of intersection of two graphs, you just have to make the equations equal to each other. So we're going to make f of x equal to g of x. And f of x was negative bracket x plus 3 all squared plus 4, which is equal to the g of x graph, which is x plus 5. So, which is equal to x plus 5. Now we just have to solve for x. So when solving for x, I'll start with this part. So we have the negative, and then let's simplify what's inside this bracket. You square the x, gives you x squared. Then you square the last term, positive 3 gives you positive 9. Then you say the x multiplied by the positive 3, which will give you 3x. Then you take that 3x and you multiply it by 2, which will give you a positive 6x. That's how we get the middle term. Then we have plus 4, and we also have these. I can just take them over so long. Minus x minus 5 equals to 0. Then we'll multiply in this negative into these 3 terms in the bracket. And so we get a negative x squared minus 6x minus 9 and then plus 4. Okay, so 4 and negative 5 can go together. So positive 4 minus 5, that will give you negative 1. And then we have minus x is equal to 0. Then we still have negative x squared, and then the negative 6x and the negative x can go together, and that will give us negative 7x. Then, of course, the negative 9 and the negative 1 will simplify to negative 10 is equal to 0. So when you're at this point, you can take everything over, or you could just go ahead and divide both sides by negative 1 so that we can make the coefficient of x squared positive. Then, because it's easier to factorize like that, then we're going to have x squared and then positive 7x and positive 10 is equal to 0. So let's factorize this. Open 2 brackets equal to 0. What times what gives you x squared? X times x. What times what gives you positive 10? And remember, everything is positive. Okay, but you need to get a positive 7 in the middle. So that can be positive 2 and positive 5. So if we're solving for x, it means that x is either equal to negative 2 or x is equal to negative 5. Okay, so those are the two solutions for x that we have. And so that would be A and B. But because they say respectfully, and so they want you to know exactly which one belongs to what. So I'm just going to also conclude which one belongs to A and which one belongs to B. So on your graph, you see that A is more to the left than B. So this would be the negative 5 and that would be the negative 2. Okay, so here I'll just conclude it by saying that x of the coordinate of A is the negative 5 and x of the coordinate of B is the negative 2. Okay, so that is 5.3. Then moving on to the next question. The next question says, hence determine the values of C for which the equation negative x plus C plus 3 all squared plus 4 is equal to x plus C plus 5. Okay, so something you need to notice here is this is the exact equation of f of x. We're just adding a plus C this time. And this is the equation of g of x, we're just adding a plus C. Okay, so when we add a plus C inside, okay, to the x, now you're not moving this parabola up or down. You're actually moving it left or right because the C is affecting the x. So depending on what C is, it will be moving this graph left or right. Now, in the straight line, what it's actually doing is, regardless of what you put here, it's actually going to still move the graph up or down. Because think about it, you had x plus 5. And even if I just decided to say, okay, x, and then in place of C, I say plus 1, then I have plus 5. Then if you simplify this, because there's a plus here, it's just x plus 1 plus 5, which is just x plus 6. And you see that will just move this graph that was x plus 5. It's just moving it 1 unit up. So what I mean by this C is that with the straight line graph, it's really moving the straight line graph either up or down, depending on what C is. But with the parabola, it's moving the parabola either left or right because it's affecting the x. Okay, but look at the full question. The question is just saying, hence determine the values of C for which the equation this has one negative and one positive root. So we need to have one negative root and one positive root. You see, the minute they start to speak about roots like this in detail, so if they were saying something like determine the values of C or K for which the roots will be non-real or real or even unequal, you see, that case you would deal with delta because delta can affect the nature of the roots, but delta does not manipulate whether the roots will be negative and positive. You do that using the graph. Okay, so another thing that you should take note of, they are equating these two equations, the equation of the parabola and the equation of the straight line. And they're asking about the roots. They want the roots to be one negative and one positive. So it just really means that we're speaking about these roots that we're referring to. It's not actually just x-intercepts, well, they are, but in our graph, they're really just the x coordinates of our points of intersection between these two graphs. That's why we're equating these graphs. Okay, so that really refers to A and B, the x coordinates of A and B. That's what they mean by the roots. So let's see what the roots, okay, of this equation being equated currently is. The current roots that we have is we have a negative root and a negative root. Okay, those are the x coordinates of the points of intersection between the two graphs. We want a situation where it's a negative and then a positive root. Remember that the equation said that by the parabola we have a plus C, meaning you have to move this graph left or right. It's not speaking about a plus C on the outside. If it did that, then you'd be moving the graph up or down. Okay, so we have to think about how do we move these two graphs together in a way that they're going to have one negative root and one positive root. Okay, not just negative and negative. So let me draw another one of the parabola and the straight line as well so that we can move them and see what happens to them. Okay, so remember that these two graphs are going to move by the same amount. When we are manipulating the parabola is either going to move to the left or to the right because of that plus C that we had after the x. But you also see that that plus C really moves the straight line either up or down. But this doesn't really matter because the thing about a straight line is that it extends to infinity, just like also a parabola. And you can see it like this. Let me make another copy of this. So if you see this straight line, so I made a copy of it. Let's say it was here, right? And because of that plus C, let's say we're moving it down. Maybe it causes the graph to move down. I just want you to see what happens. If this graph shifts down, right? You can see it visibly going down right now. But if you looked at it as a graph like this, it doesn't actually look like it went down in a way. Like, yes, because of I moved it, you actually saw it going down. But if you look at this, look at the fact that here it intersected the x-axis at -5. But here, look at where it's intersecting the x-axis. It kind of looks like it's just moving to the right. That's what it looks like. Okay, so I just want you to see that it is actually moving down, but it will look like it's moving to the right just because it's a straight line. Okay, so let's focus on the parabola first. How do we move this parabola so that these two graphs, when they will both move, they will both have a negative and then a positive root as well. So if you look at the parabola and you look at how you should move this graph, if you move it to the left, you see the problem with this is we're not going to get this type of roots that we want. The root is still going to be, we're looking for the point of intersection of the parabola and the straight lines. You see, it's a negative value and it's also another negative value. That's not what we want. And if you keep moving it to the left, that's what you're going to keep seeing. So instead of moving it to the left, let's move it to the right. Okay, so let's talk about what right movements do or how to move things to the right using a parabola. If this is the equation of the parabola and you want to move it to the right, you're going to first of all put whatever number, the amount of units that you want to move it to the right. Okay, it's going to be affecting the x. We're going to put it next to the x. Now, when you're moving something to the right on a parabola, you don't say plus. For example, if I wanted to move it like 1 unit to the right, I will not say +1. You will say -1. You're going to have to put a -1 in here for it to actually move to the right. Now you see this -1, we're moving it by the same amount of units on the straight line as well. That's why we have that +c in both equations. So if we're moving it 1 unit to the right, look what that's going to cause this one to do. If you put that -1 next to your x, -1, then you have the +5. What it's going to do to the straight line graph is it's going to cause the straight line graph to move 1 unit down. But this won't really make too much of a difference. So you see it as this is moving 1 unit to the right, and this one ends up moving 1 unit down. And this is what I mean by it's not going to cause that much of a difference, because you see it's still going to intersect at the exact same places. Not at the exact same number, but they're both still going to intersect at the x-axis first, and then they're going to intersect here again. Okay, so 1 unit will definitely not just be enough to give it a negative and a positive root. So you see we still have a negative and a negative root. So how many units to the right do we have to move it? Okay, this is how we can look at it. When it is sitting here, focus on the point B. So B is -2. How about we move this graph, the parabola and the straight line graph? Let's move the parabola first of all 2 units to the right. So if this is -2 and we count 1, 2, we will be at the origin. So it means this point of intersection will now happen here on the y-axis. So the parabola will move like this to the right until it cuts the y-axis, something like that. Okay, and what the straight line would do is, because this one is moving to the right, the straight line, it will cause the straight line to move down, like I explained here. It causes the straight line to move down, and you see, look at them intersecting again. It intersects here on the y-axis, and it's still going to intersect at the x-axis as well. So let's see, do we have the type of roots they're asking for? Well, we have a negative root, but now one of our roots is not positive, it's just 0. So we would need to move this parabola a little bit more. So it means that we need to move the parabola at least just more than 2 units to the right. If it is more than 2 units to the right, it will pass this y-axis, it will pass this origin, and it will have a positive root. Okay, that's the whole point of that. So let's put that point down. So we need to move it more than 2 units to the right. Okay, but how far? We can't just move it more than 2 units, because if we move it more than 2 units, it's just going to keep moving like that. You just keep moving. Where should we stop? How do we know where to stop? Okay, so this is how you know where you need to stop moving it. Look at the fact that this point of intersection or this root was -5. Okay, if you move this graph, so it's a negative root and we want the roots on this side to stay negative because the one on this side will be positive when we move it a bit more than 2 units to the right. So that it can continue to stay negative, as long as it does not move anything more than 5 units. You see, we're at -5. If you move 1, 2, 3, 4, 5, that root will now be at the origin. As long as it doesn't move anything more than 5 units to the right, we're going to be okay with this. Okay, because this is what's going to happen if you move them more than 5 units to the right. So if it was here and you move it, let's just say even 5 units. If you move it 5 units to the right, this is what's going to happen. You see, now look where it's sitting. Okay, yes, we will have a positive root here, but then we'll have a root of 0. And then if you move it anything more than 5 units, you're going to end up with a positive root, and the roots that you're going to have here is also going to be positive. But we're looking for one negative and one positive root. Okay, so that is the amount we should not move it past. You need to move it more than 2 units to the right, but not more than 5 units, not more than 5 units. Okay, so now how do we interpret this with what they gave us? How do we tell them what the value of C needs to be given this description? So let me rewrite what we had as f of x in that equation. Remember, we had f of x and g of x being equated, but we had negative bracket x plus c and then the plus 3 all squared. And they said it was equal to the x plus c, and then we had the plus 5. So remember that now we know that this c, it has to move to the right. And remember, when things have to move to the right, looking at the equation, you do not say plus to make it move to the right. You say minus. So this c is now going to be negative. We need to move it to the right, meaning it's going to be a negative value so that it can be a right shift. So I'm treating this negative c as if it is the right shift. I'm saying that this right shift, this negative c, it needs to move more than 2 units to the right because it's already moving to the right by saying negative c. It needs to be greater than 2, but less than 5. Okay. Then now we just have to solve for c. So to solve for c, we see that this is negative. So you have to divide by a negative. If you divide both sides by -1, it will make the c positive. So now the c is positive. But you need to remember that in inequalities, when you divide or multiply by a negative, it will cause the signs to change. So 2 divided by -1, that's -2. But this sign is going to change direction. It's going to look like that now. And then 5 divided by -1, it is -5, and this sign also changes direction. So if you read what this is saying, because this is not put in the proper way, we're supposed to have the c in the middle, the smaller number here, which would be the -5, and then the bigger number here, which would be the -2. So if you see what this is saying, compare the c to the -5. This inequality, the mouth needs to face the c, so we draw it facing the c. When you compare the c to the -2, the mouth needs to face the -2. So it's really saying that c needs to be greater than -5, but less than -2. And that will be our answer. So I'll put that calculation and this as well in my answer. And there we go. So that is the answer. C just needs to be greater than -5, but less than -2, so that we will have one negative and one positive root. So that, of course, will move these graphs in a way that it's going to basically move this one past this point, moving it more than -2 units to the right, and moving this one more than 2 units down because it will cause that one to shift down. And so you see the new place, the new points of intersection, this is what's going to happen. Here it's a positive root, and there it's a negative root, but I'm actually drawing this one wrong. It's supposed to still cut the x-axis. So here it is a negative root, here it is a positive root. The roots are the points of intersection of the two graphs. Okay, so moving on to the next question now. Okay, so the last question in question 5. 5.5 says the maximum distance between f and g in the interval where x is greater than the x value of a but less than the x value of b is k. Then they said if h of x is equal to g of x plus k, we need to determine the equation of h in the form of h of x is equal to this. Okay, so that you don't get lost in what they're saying, focus on the goal. The whole goal of this is to determine the equation of this h of x. And they said that h of x is made up of g of x plus k. Now, the good thing is we have g of x. That was that g of x is equal to x plus 5. We have that. What we don't have is k, so it means that we need to find k. So what did they say k is? They said k is the maximum distance between f and g in the interval where x is greater than x of a but less than x of b. That is what k is. Okay, so let's find that maximum distance. So since it is the distance between f and g in this interval, let's see what x of a and x of b refers to. X is greater than x of a but less than x of b. This is just the x coordinate of the point of a and the x coordinate of the point of b, which was, as we have here already, -5 for a and -2 for b. So let's just replace those. They're really just saying between this interval where x is greater than -5 but less than -2. So we have to determine the distance between f and g between these intervals. So this is what they mean by that. We have this graph and they want us to determine the distance between f and g between these two x values. Now you see between these two x values, if we're looking at it like between here, this is the point where the graph of f is above the graph of g. So in order to find a distance for them, okay, or at least just the formula of the distance, you would have to take the y value of f and take the y value of g, and to find their distance, you subtract the graph of f minus the graph of g. And that's why they're giving you that hint that you have to take it between where x is greater than -5 but less than -2, because only at this point do you have the graph of f being above the graph of g. At every other point, like if you move this side, you see the graph of g is above the graph of f. So that's why they put that restriction, so that you have to say f of x minus g of x. Okay, so remember, they didn't just ask us to find the distance of that, but they specifically asked for the maximum distance. But let's try finding the distance of that first. So to find the distance of it, so just a general distance, not the maximum yet, you would take whatever the function of f of x is, and you would subtract it by the function of g of x. So that's what we're going to do to find that distance. So that distance is going to be equal to f of x minus g of x. Okay, then of course k would be the maximum distance. So let's go ahead and find what this equation will give. F of x was negative bracket x plus 3 all squared plus 4 minus g of x was the x plus 5. So because it has two terms, you have to include brackets. So we're going to put brackets and say x plus 5. So x plus 5. So let's simplify this. We have negative bracket x plus 3 all squared plus 4, and then if you multiply this in, we have negative x minus 5. Now if you look at this equation, it should look familiar. We actually did deal with something like this. If we scroll up and look at this, you see when we made f of x equal to g of x, we actually had an equation like that. You see where we had this equation and this equation had to come over, because really if you're saying f of x is equal to g of x, it's the same thing as taking g of x over. And so now you have f of x and g of x becomes negative minus g of x. So the equation that we get here at the end is the same equation we will get if we subtract this by that. So you can go ahead and work it out if you want to, but the answer is already here. So we might as well just take this, or even the final answer. So I will actually just take it from here because I can't actually take this answer. Here we were equating it to 0 and solving for x, but here we just want to find the distance. So it's like taking this part over like here. So I'm only going to take as far as this, negative x squared minus 7x minus 10. Okay, so I'm just saying that if you like, you can simplify that. It will give you this negative x squared minus 7x minus 10. It will definitely give you that. Okay, I'm not going to divide by -1 because this is not an equation. It's the formula for the distance of this graphs between those x coordinates. So this is an equation for the distance of it, but we're trying to find k. K specifically is what they call the maximum distance between F and G. Currently, we just have the distance between F and G, okay, where X is, of course, between these intervals. We need to find the maximum of that. That would be the value of K. So to find K, we're going to have to find the maximum. Okay, so what is the maximum value of this expression that we have? It forms a parabola. And because a, the first term, the coefficient of x squared is negative, it will be a concave down parabola. And so as you can see, this type of parabola has a maximum turning point. And that's what we're looking for. K is that maximum turning point. So to find that maximum turning point, if this was on the Cartesian plane, we first have to find the x value belonging to that, then take that and substitute it into the original equation for the distance, and we will get the y value of it, which of course will be our value of k, that maximum distance. So to find the x value belonging to this maximum or belonging to this turning point, there's two ways. You can use that x is equal to negative b over 2a, or we can just derive that equation and set it equal to 0. And I'll just use the derivative. So I'm taking the distance formula. I'll just call it d is equal to negative x squared minus 7x minus 10, the distance of this, okay? And I'm going to derive it. So I'm saying d prime is equal to this -1 times the 2 is -2, then x. We have to take a 1 from that, and it's just we're left with a 1, which we don't have to rewrite. And then minus 7, and the x falls away, and that constant also just falls away. So this is what we have. So we've derived this. Now we have to set the derivative equal to 0. Okay, and just remember the whole logic behind that is you're looking for a turning point. At the turning point, that's where the gradient of the curve is equal to 0. When you derive a function, you're actually finding the gradient of that function. This is the formula for the gradient of this parabola at any point. So we're just setting that gradient equal to 0 so that it will find the turning point, because only at the turning point is the gradient equal to 0. So negative 2x minus 7. Then I'm going to take the negative 2x over, so it becomes positive, and we have minus 7. Divide both sides by 2, and x is equal to negative 7 over 2. Okay, so I found the x value belonging to that. It's negative 7 over 2. So of course I put the y-axis at the wrong place, so it will probably be somewhere like here. Okay, but we just have to find now we know the x value, we need to find the y value. The y value is your value for k, okay? So the y value would be, if we say d, where we're substituting negative 7 over 2, it's going to be negative bracket negative 7 over 2 all squared minus 7 bracket negative 7 over 2 minus 10. And then we'll just put this onto the calculator and let's see what we get. And when I put that onto the calculator, I get 9 over 4. So that maximum, okay, the maximum, or k, the value of k is 9 over 4. So k is equal to 9 over 4 because they told us what k was. It was the maximum distance between that. So we found the maximum distance. And now remember, the whole point of all of this was to find the equation of h of x. And so h of x is equal to g of x plus k. So know what g of x is, it's x plus 5. So we're saying that h of x is equal to the x plus 5, so x plus 5, that's the g of x, plus k, which is the 9 over 4. And so this is equal to x plus, and then if you calculate that, that's going to give us a 29 over 4. That would be the equation of h of x. Okay, so that's what they want. And that is the end of question 5. In this video, we're going to be working on the functions part of this paper, which is the grade 12 maths paper 1 prelims, but specifically from the Gauteng province. Also, let me just mention that this is a 2023 paper. Okay, so we're on question 4, and question 4 says, consider the graphs of g of x, which is equal to 6 over x plus 3 minus 3 over 2. So please notice that's just a constant, okay? That is just that q value there. That's all it is. Despite the fact that it's a fraction, it's just still a number. And then we have h of x is equal to 6 over x minus 3 plus 2. The first question is to write down the domain of g. So remember, the domain is going to be all your possible x values. You don't have to write down these graphs. I'm just showing you so that you can understand how that works. So we're just going to look at all the possible x values of this graph. Okay, so the graph of g is this one, right? Now, as you can see, you have a normal hyperbola. So in order to actually find out the domain of this graph, this is what we're going to look at. You see a hyperbola. Despite where it is, because a here, right, the value of a, the 6 is greater than 0, your graph is going to lie in your first and your third quadrant. So it's going to look something like this. Now, this graph is going to have every single x value. You will see that it will always have an x value, okay? This is a point, that's its x value. This is another point, that's its x value. It's going to keep having x values all through, except for one place. And the only place it will not have an x value is where it has a vertical asymptote. So it's going to have its vertical asymptote here. And this is how we're going to see what that is. So if this is x plus 3, right, you know that the equation is a over x minus p plus q. So what is actually the value of your vertical asymptote? Think about that. That's going to be negative 3, because if you want to put it in that same way, the only way you can actually do that is by saying x minus negative 3. That's why when they simplified it, it became x plus 3, because this is your vertical asymptote. This is the negative 3. Okay, that's the value of p. You take that value. So it means that we have an x is equal to negative 3 over here. And this is the only place that the graph will not cross. Okay, the only x values will not cross. So your domain, and what we say that is we say its x is an element of all real numbers. It will have every single x value that is on the number line, but x will not be equal to negative 3. And that's how it is. Simple like that. Okay, 4.2 says, write down the range of h. So let's go ahead and put h in blue. It's the same situation. You see, we have this again. We're thinking about the range of a hyperbola. It will have every single y value as well. Every y value would be present. The only y value it will not have would be the q, which is really your horizontal asymptote. Okay, so it will not have that. That's the only one it will not have. So there's going to be, here it's positive 2. You're going to have a y equals positive 2. And this is the only place that the graph will never cross. Okay, that should be a dotted line. So in this case, it would be y is also an element of all real numbers, but y will never be equal to positive 2. Okay, so that is it for those two questions. Okay, moving on to the next question. The next question says, if the graph of g, okay, so g is shifted so that it coincides with the graph of h. The first question is, how many units must the graph be shifted horizontally? So thinking about it as this graph of g is shifted so that it coincides or perfectly fits into the graph of h. When graphs coincide, or when a graph coincides with another graph, it just means that you had that graph originally, and all it did is it moved to the point that it actually fit perfectly with the other graph. Okay, so it just moves nicely and then gets to a point that it actually sits on the other graph. Okay, so that's what's going on there. So we have to think about how this is going to affect the shift. How are we going to shift them so that this can happen? Okay, so to explain this, I'm going to go ahead and draw a little graph. Now I need you to understand that you do not need a drawing of the graph for you to do this. If you know how the graphs work and how shifts work, you can actually do this without any drawing. I'm just going to put a drawing so that it makes more sense. So if you have the graph, so we just have our Cartesian plane, and let's just put down our graphs. Now, how we're going to draw the graphs is going to be a very brief and simple graph. I'm not going to think about x-intercepts and y-intercepts really. How we can think about these graphs are, because we already know their asymptotes. So the graph of G, I'm going to draw in red, and this one I'll draw in blue. So with this graph, you know that it has an asymptote at x equals -3, right? It has a vertical asymptote. So I can mark that here. So at x equals -3, we have a vertical asymptote. And then we have a horizontal asymptote here. See, because that is our Q value, or our horizontal asymptote value, okay, at y equals -3/2. So that would be y equals -3/2 on the y-axis, and this is our asymptote, okay? Now, because our graph has a positive a value, okay, it's going to lie in the first and the third quadrant, but it needs to lie in a way that it perfectly fits with its asymptotes. So this is how it's going to be drawn. The graph is actually coming from being really close to the asymptote, and then it goes like that. See, and then goes really close to the asymptote, but never touches it. So that's what your graph is going to look like, roughly. Okay, it may not look exactly like that, or like past the origin, but it looks something like that. And then the other wing is also going to do the same thing, just in the third quadrant instead. So it's going to look something like that. And then the blue graph, right? Because that's going to be what shifts. The blue graph is going to look like this. Again, it's also in the first and the third quadrant. But here your asymptote is what? Since you have an x -3, your asymptote is actually x equals 3, because that is the value of p. See, x minus 3. So we have a 3 there. So we have a vertical asymptote of x equals 3 and a horizontal asymptote of y equals 2. So that goes over here. We have y equals 2 over here. So our graph, again, it's going to be in the first and the third quadrant. So it's going to look like this and like this. See, it goes closer to its asymptotes. That's really what's going on. So like I said, you don't have to draw the graph to understand this. If you understood how these things just move, you could have done this without the graph. I'm only showing you a graph so that you can understand what's going on. So what's going on here is the graph is going to be shifted so that it coincides with the graph of H. So this is very important for you to understand that it's the graph of G that is moving so that it perfectly fits with the graph of H. So how that will happen is like this. What you can use to control the shift of this red graph, the graph of G, is the asymptotes. So what's going to happen is the graph is going to shift. The vertical asymptote is going to shift until it aligns with the vertical asymptote of the graph of H. So in other words, what we're saying is that this graph, right, this line here, this vertical asymptote, it is going to move until it lies perfectly with this one. So how many units should it move for that to happen? Okay, and that's actually the first one they're asking for. They're asking, how should it be shifted horizontally? Horizontal shifts happen like this, left and right. Vertical shifts are up and down. So how should it be shifted so that it perfectly fits like that? Well, from -3 to 3, you moved how many units? You moved 6 units to the right, okay? You can think about it like this. If you wanted to know how far it shifted, you're really just saying, we're going from here to here. What is the distance between them? And to find the distance between points, you take the highest minus the lowest. If you said 3 minus -3, you would get +6. Okay, so that's what happens there. So you need to move it 6 units to the right. That's how we have to shift it. Okay, and if that shifts there, then there we go. It has been shifted to that line. Okay, then this one, how many units must you shift that vertically? So how much units must you shift the graph vertically? Well, that would be, what will control that would be your horizontal asymptote. So this, because this line, for it to shift, it can only move up and down. It can't move to the side. If it moves side to side, it's not going to change. It's still going to pass -3/2. Nothing's going to happen. So you know here that the horizontal asymptote on the graph of H is 2. Okay, so for that to happen, for this to shift from here all the way to 2, you need to have moved the graph how? Well, you could literally count them, but you could also just say, we just need to find this little distance here. That would be the amount of units you needed to shift this graph, and we can clearly see that it's moving up, right? So you could just say highest minus lowest. So what is 2 minus this number, which is negative 3 over 2? So that becomes a plus. So that's really 2 plus 3 over 2. And if you add that, well, adding mixed fractions, you can just multiply this, the whole number, and the denominator, which is 4, and then add 3. So that is 7 over 2. That's how much units you need to move it. It's 7 units, 7 over 2 units up. That's how you have to move that. So that over there, the answer is 7 over 2 units up. And once those asymptotes move, the graph itself will also move and perfectly align with that graph. Okay, so that's really what's going on there. Okay, so that is the answer for that. And moving on to the next questions. Okay, the next question, 4.4, says, write down the equation of the asymptotes of G. So the graph of G, the equations of the asymptotes. Okay, we already had one of it here. So the equation of the vertical asymptote is that x is equal to negative 3. And the equation of the horizontal asymptote, that q value, okay, is y is equal to whatever that q value is. I've already explained it with the domain and the range story. Okay, so that is y is equal to the number here, which is negative 3 over 2. Okay, so that is for 1 mark. And then moving on to the next question, that should be up here. I'll just rewrite it up there. Okay, so moving on to the next question, 4.5 says, calculate the x-intercept of G. So what's the x-intercept of G? Well, to find the x-intercept, you just have to make y equal to 0. Since this says g of x is equal to all of this, the g of x is your y, okay? So we're really making that equal to 0. So we're saying 0 is equal to the 6 over x plus 3 minus 3 over 2, and we just have to simplify this. Okay, so to simplify this, because this is negative, I'm just going to go ahead and take it over. When I take it over, it becomes positive. 3 over 2 is equal to 6 over x plus 3. Then you need to solve for x. The best way to solve for x here, since they're both fractions, would just be to cross multiply. So I'm saying 3 multiplied by this. But remember that when you're multiplying the 3 by something that has 2 terms, the 3 needs to multiply into the x and into the 3. So 3 times x is 3x, and 3 times 3 is positive 9, is equal to, and we also cross multiply here. 2 times 6 is 12. And then just simplify. So 3x is equal to, we're going to say 12 minus 9, which gives us 3. And then divide both sides by 3 to solve for x. Therefore, x is equal to 1. And so our intercept, our x-intercept as a coordinate is 1 and 0. X value is 1, y value is 0. Okay, so that is the x-intercept of G. Moving on to the next question. Then 4.6 says, sketch the graph of G in your answer book. Clearly show all asymptotes and intercepts with the axes. So we already have most of the work done for us. In fact, the only thing we have to actually find in G, because you see that in G of x, we just found the x-intercept. The only thing we have to find is the y-intercept, okay? So the y-intercept, when you're trying to find that here, you just need to make x equal to 0, okay? Because that's how you find the y-intercept. So we can just go ahead and do that since we don't have that yet. So that was g of x is equal to 6 over x plus 3 minus 3 over 2. And you're just going to find the y-intercept of this graph. So make x equal to 0. G of 0 is equal to 6 over, and we're going to say 0 plus 3 minus 3 over 2. Okay, so 6, and we have 0 plus 3, which is 3. 6 over 3 is 2. So it's 2 minus 3 over 2. Okay, so that would give you a half. Okay, you can calculate it on the calculator as well, because that is 1.5. So a half. Okay, so we have our y-intercept, and now we can go ahead and actually sketch the graph. We have everything we need to sketch the graph. So we have our axes. We're not really going to focus too much on putting too much points. Just put the important points. That's really all you need. The first thing that we need to put down are our asymptotes. Okay, you need to put down your asymptotes first. So with your G graph, you see that the vertical asymptote is x is equal to negative 3. So the x equals negative 3 because the vertical asymptote is a vertical line. It's going to go like that. So we're going to say x equals negative 3. You don't even have to do that. You can just write negative 3 here. So they know, okay, that is the line that passes negative 3 on the x-axis. And then you need the horizontal asymptote, which we know is negative 3 over 2. and that's going to be down here. So it's -1 and then halfway through. So -3/2 is here. Okay, -3/2, and I'm just going to put the number there, -3/2, so they know it passes there. Then we have to draw our intercepts. So we have an x-intercept of 1 and 0. So that is, we have 1 and 0. So that's here. And you can just write the number 1. You don't have to write the coordinates. It passes through 1. And then the y-intercept, of course, is a half. So that is on the y-axis. And that is a half. So it's not even past there. It's just a half. Okay, then you have to draw your graph. Remember that your graph of G, the value of A is 6, which is a value greater than 0. When your value of A is greater than 0, your graphs are going to lie in the first and the third quadrant. So now you're just going to join your graph. Your graph is going to go like this. It's going to pass the y-intercept, the x-intercept, and then just move closer and closer to the asymptote, but never touch it. So like that. And then we're also going to just do the same thing on this side. You don't necessarily need a point. What you can just do is kind of estimate the distance between where the asymptotes meet and the line, and then kind of roughly just also measure that here, and then just make sure your graph passes like that. So just like that, and it's fine like that. Okay, so that is your graph of G. Okay, so all the important things are here. This is for 3 marks. So they're just really going to give you a mark for the things, the important points that you have included. That's our y-axis, that is our x-axis. Okay, moving on to the next question. Okay, we're on 4.7 and it says determine the value of k, and there's k here, okay, if h of x is equal to -x plus k, right? If this is an axis of symmetry of the graph of G. So they're saying that this is an axis of symmetry of the graph of G, and you have to just find the value of k. I feel like they should have just called this something else instead of h of x, you know, because we already have a graph called h of x. It's just a little confusing. So anyways, we're going to have to find the value of k. So in a nutshell, what they're saying is we have the axis of symmetry of G, okay? And that has an equation. Let me already speak about that. The axis of symmetry of a graph, right? There are 2 axes of symmetry in a hyperbola. There's the one with a positive gradient, and its equation is y is equal to positive x minus p plus q. And it's easy to remember this if you remember the general form of a hyperbola. See, x minus p plus q. So kind of like repeats there. So the axis of symmetry is really just any line that divides the graph into 2 symmetrical parts, okay? So this part looks exactly the same as that part, and that part looks exactly the same as that part. But we also have another axis of symmetry, the one with a negative gradient, because you see here, this graph would look exactly the same as that graph, and that's why this is a line of symmetry. And the equation of it is y is equal to -x plus p plus q, okay? How you get that is, if you remember this one, you remember that one. Because all that is done to get this graph is they put a negative in front of the x minus p. So we just have this, they put a negative here, and if you distribute, you see that you're going to end up with this. Okay, so now they're really helping you a lot here. They said determine the value of k if h of x is equal to -x plus k, if that is the axis of symmetry of G. So if this is the axis of symmetry of G, which one is it exactly? Is it this one with the positive gradient or the one with the negative gradient? It would be the one with the negative gradient, because you see that you have a negative x over there. So they're really just saying find this equation and then tell us exactly what k is. K is just everything without the x. So that plus p plus q. That's really what all that is. Okay, so I'm going to say y is equal to -x plus p plus q, and I'm going to take the p and the q value of that and add it into the equation. So we're looking at the graph of G. The graph of G, its p and q value are these. As you can see, the p value, like we spoke about, is -3. That's p. And the q value is this over here, which is -3/2. Okay, so -3 and -3/2, that's all we're adding there. So y equals -x plus -3, which is just -3, plus -3/2, which is just -3/2. So y equals -x, and then you're just going to have to simplify that. Okay, that's like saying 3 plus 3/2. You multiply those, that gives you 6 plus 3, which is 9. So that's going to be 9 over 2. But it's negative, okay, because it's negative minus that. So that's negative 9 over 2. You can also use a calculator. So we can finally tell them that you see the value of k. K is that negative 9 over 2. So therefore k equals negative 9 over 2. And that is our answer. Okay, moving on to the next question. Then in the next question, 4.8 says, for which value or values of x will 6 over, and as you can see, that is the graph of g they're giving you there. Okay, that's the graph of g is greater than negative x plus k. We just saw this graph. This is your axis of symmetry, the one with the negative gradient. Okay, that h of x graph, which I really feel like they shouldn't have called h of x, but okay. So that's really what we're looking at. So you can use the graph to think about how this works, but if you visualize the way a hyperbola and its asymptote looks, you'll be able to already see what's going on there. I'm going to use the graph. It's better to use the graph here. So we're going to look at the graph of g, and you're going to look for where it is greater than the graph of h, your axis of symmetry. In other words, you're looking for where this graph is going to lie above that axis of symmetry. That's really what you're doing, because if it is greater is referring to the y values of this graph. So if we draw that is our graph of g. There's our graph of g here, right? And if we're looking at that axis of symmetry, that graph that I said is called h of x, that would just be a line, really a dotted line. It's a diagonal dotted line that is going to pass through this point over here, and this point is the intersection of your vertical and your horizontal asymptote. That is where that line is going to pass. That h, which is y, or let me just call it h of x, equals negative x minus 9 over 2. Okay, that's where that's going to pass through. So the question is, where is g of x going to be greater than h of x? That's really all they're asking you. Now, the only place where the graph of g is going to be above the graph of h is here, this part of the graph. Because if you go anything beyond this, if you take this part of the graph, do you see that everything here, or this graph, is lower than this line? Okay, that's really what we're looking at. This graph is lower than this line. And so we cannot take that because all its y values are going to be below that. Like if you are comparing it to the same x value. This is what I mean by that. So what I mean by that is, let's look at it like this. Okay, you see, for example, see this point over here? Its y value is negative whatever that number is, right? Now, we have to look at this graph's y value for this same x value. So the x value we're referring to is something here. And if you're looking for this graph's y value for this same x value, look at where that is. Do you see that the blue graph's y value is higher than the red graph's y value for the same x value? That's why I'm saying that the only place that you will find that this graph is above this axis of symmetry would be here and nothing here, because this is really just below this. We're really just looking at it like that. That is just below this line. So we need to write the values of x for which this will happen. Okay, so you already see that you have an asymptote here. So this graph will never pass this line, meaning it starts from -3, or really values that are greater than -3. And then it continues until this graph goes on till infinity like that. So this is from -3. This is where x is. As you can see, it's moving towards the right-hand side. It's every value that is greater than -3. And it just keeps going because this line will just keep getting closer and closer to the asymptote, but it will never pass the asymptote. Okay, so it's really just every part of that wing of the graph. So it's where x is greater than -3. That's our answer there. So the answer for this is where x is greater than -3. Okay, moving on to the next question. Okay, then the last question for question 4 says, the graph of g is reflected in the x-axis. Write down the new equation in the form of y is equal to. So remember, if something is reflected in the x-axis, this is an x-axis, okay? If something gets reflected in the x-axis, what it causes is, let's just look at it like a point. Let's say this point was 1 and 1. right? If it gets reflected in the x-axis, so it now appears here, what's going to happen is your x value stays exactly the same, but your y value would change. So because it's reflected as a mirror image, it's really just going to go the same distance, okay? So it's going to appear at -1, so 1 and -1. So if a graph is reflected in the x-axis, it causes the y values to change their signs, okay? In other words, you really just multiply the y values by -1. So that's what we're going to do. We're going to take the graph of G and multiply its y values by -1 so that we can reflect it in the x-axis. Okay, so our graph of G said G of x is equal to, and it was that, right? Is the 6 over x plus 3 minus 3 over 2. And this gets reflected in the x-axis. So we're going to take the y values and multiply it by -1. It's like taking G of x and multiplying it by -1. So we have negative G of x, okay? And so what happens there is you're saying negative G of x. This was what G of x was equal to. What happens is we have a negative being multiplied into it. So it's going to really appear in front of it like that. So we have negative 6 over x plus 3 minus 3 over 2. And then you can just distribute this. So if you distribute, that now becomes a negative 6 over x plus 3. And then that becomes, when it multiplies, positive 3 over 2. If you like, you can actually, and it should be written like this actually. It should be written as, you can put the negative in the middle just to show you that the fraction is now negative. So we have 6 over x plus 3 over 2. That is going to be your new graph. And they did say we're going to call it y is equal to. So that is our new graph. Y equals that. Okay, so that is it for question 4. Now we move on to question 5. We are on question 5, and question 5 says the graphs of f of x is equal to negative, and then we have x minus 7 over 2 all squared plus 81 over 4. So looking at that graph of f, can you see that it is raised to the power of 2, right? Meaning the highest exponent of x is going to be 2, meaning this is a parabola, right? And this parabola is in turning point form. Okay, so that's going to be very helpful here. And g of x is equal to negative 3x plus 24 are sketched below. Okay, so we have those two graphs. And they tell us that the graph of f and g intersect at points D and B. And we have points A and B are x-intercepts of our graph of f, our parabola. The first question is to write down the coordinates of E, the turning point of f. Okay, so they're making it very clear. That is your turning point. So we are at an advantage here because they gave us this parabola in turning point form. And turning point form is y equals, and we have a multiplied by x minus p all squared plus q. So you see the value of p and q, that will be the coordinates of your turning point. Please notice that this says x minus p, right? But we have a positive p here. So you see x minus, and you have 7 over 2. So 7 over 2 is your p value. And then q is just plus q. So 81 over 4 is your q value there. So our coordinates of p will be those two. So E is going to be the 7 over 2 and that 81 over 4. That is going to be the coordinates of our turning point. And I'm also just going to include it here as well. Okay, moving on to the next question. The next question, 5.2, says, determine the average gradient of the curve of f between x is equal to 1 and x is equal to 5. So they just want you to find the gradient of this curve, of the graph, right, at these points. So they gave you the x values of the points. Remember, average gradient, the formula for finding the gradient of 2 points, because that's really what they're asking you for. The gradient of 2 points, the formula for that is y2 minus y1 over x2 minus x1. So we're going to use this here. But in order to do that, we need our y2 and our y1. You see that they only gave us the x values. So you can call that your x2 and that's your x1, right? We need to find the y values of those. So to find the y values, you can substitute your x values into your equation and it will give you the y values. So we're going to go ahead and find out what exactly f of 5 is, because that's going to be our y2 And we're going to use our formula. So let me rewrite that down here first. Okay, and in place of x, you're going to substitute 5. So that's what we're going to do there. Okay, so let's go ahead and find out what exactly this would give us. And that gives us 18. So we know that f of 5 is 18. And it's important to substitute because they want to actually see, they probably want to see that substitution. Then again, you are getting a mark for the answer. If you got the answer, they know you substituted. Okay, and then we also need to find f of 1. So we're going to, in place of x, put 1. And you see there that f of 1 is 14. I don't really think you need to show them the substitution, but we can, it's fine. So I just copy that, and in place of 5, I'm just going to put 1. And we know that the answer of that is 14, like we saw on the calculator. We have 14 there. So that gives us 14. So to find the average gradient, we are using the gradient formula, okay, which is this. And so let me just pull this down here. So we are using this. So to find that gradient, okay, do those points have names, 1 and 5? Well, not really. Okay, so they don't really have names, so it's fine. I'm going to go ahead and call that. That's going to be, so y2, remember, since this is our x2, this is our y2, so that's the 18. So that's going to be, well, let me write it like this, first of all. So we're saying that in place of that y2, it's going to be our f of 5, since the x value is our x2, minus our f of 1, right? That's y2 minus y1, over x2 minus x1. Our x2 is 5, and our x1 is 1. Okay, so substituting, that's really just the 18 minus 14, 18 minus 14, over 4. 5 minus 1 is already 4. So 18 minus 14 is 4. 4 divided by 4 is 1. So our answer here is just 1. That is going to be our average gradient. Okay, moving on to the next question. The next question, 5.3, says calculate the value of A, the x coordinate of point D. Okay, so they want us to find the value of A, which is the x value of this point. You remember what they told you about this point D? They told us that the graph of F and G intersect at points D and B. So it's a point of intersection. So to find out what exactly that x value is, right, you're just going to have to make the graph of, since it's the place where f and g meet, it's the place where f of x is exactly the same as g of x. We're saying their y values are the same and their x values are the same. So we're going to have to equate the graphs at that point. So that's what we're just going to do. We're going to tell them that f of x should be equal to g of x. And f of x was that. Just substitute x in place of that there. And this should be equal to g of x, which they told us at the beginning of this. So that is negative 3x plus 24. So minus 3x plus 24. And we just have to simplify now and solve for x. Okay, so normally I'd like to leave these two alone and just try to simplify and get to the x. But there's no use of doing that right now because we already have an x here. So you might as well distribute here. Okay, so we can go ahead and distribute this. Okay, what I can do actually is take this over. Since it has a negative in front of it, I'll take it over and make it positive. So we're going to have here positive x minus 7 over 2 squared, right? And then I'll just take everything over here. So leave nothing on this side. Here on the right hand side, we still have the minus 3x, and then we have the plus 24, and then this positive 81 over 4 that is on the left hand side will come over and become a negative 81 over 4. Okay, so we're just going to have to simplify this part now. 0 is equal to, so you see that you have a binomial squared. You can go ahead and create two brackets and distribute. That will take too long. You can actually just do this this way. So you square the first term, that is x squared. You can go ahead and square the last term. So that becomes a positive because it's negative here. And 7 squared is 49, 4 squared is 4. Then you're going to say first term multiplied by second term. And you see that that's going to give you negative 7 over 2x. Then you multiply that by 2. Okay, you see that 2 is a number that's actually on the numerator. So what's going to happen is it's going to cancel with the denominator here. And you'll be left with negative 7x in the middle. Negative 7x is in the middle. Okay, so it's square the first term, square the last term, multiply the first and the second term, and then multiply it by 2. Okay, then we have minus 3x, and then the numbers, we can actually just simplify that. So what is 24 minus 81 over 4? That's what we have to simplify there. Okay, so what is 24 minus 81 over 4? Well, you can actually just use a calculator, but you can write 24 as 96 over 4. I'm trying to make the fractions to be equivalent, so make the denominators the same. And we have minus 81 over 4. 96 minus 81, that is the 9 minus the 8 is 1, 6 minus 1 is 5. So 15 over 4 is what we're going to have there. So positive 15 over 4, 4, not 14. Okay, so this is what we have. And just simplify. You see that you have x and x that can go together here. So that 0 is equal to x squared. What is negative 7x minus 3x? That will be negative 10x. And then we have 49 plus 15. If you have 49 and 15, you can go ahead and add that together. So that's just going to be your 14 and then 64. So that's going to be positive 64 over 4, because the denominators are the same. But then 64 can divide by 4. See, so 64 divided by 4, it's like dividing by 2 and then dividing by 2 again. So that's 32 divided by 2 again is 16. So that just gives you a positive 16. Okay, so we have a trinomial right now. Okay, and we can go ahead and factorize this trinomial. So 0 is equal to, open up two brackets, and we have x multiplied by x. And factors, we need factors of 16 that can give us 10. So factors of 16 can be 1 and 16, which will definitely not work. It can be 2 and 8, which looks perfect, okay? Because the middle is negative, right? The only way you could have gotten this, and you can see that this is positive, okay? The only two things that can multiply that can make that positive, but that stay negative, is if this is negative 2 and negative 8, because negative 2 times negative 8 is positive 16, but minus 2 minus 8 is negative 10. So that is going to be minus 2 minus 8, and then just solve for x. So therefore it means that x is either equal to positive 2 or x is equal to positive 8. So you have two answers here, and you need to choose the one that is for A, the x coordinate of point D. Okay, so remember this is positive 2, positive 8. So one is bigger than the other. Which one is A going to be? Because A is more on the left-hand side, this is the 2. Then this one is the 8. Okay, so we can go ahead and tell them that A finally is equal to 2. So therefore, A is equal to 2, and that is our answer. Okay, moving on to the next question. Okay, 5.2 says, point S is a point on the graph of f where x is greater than a. We already know what a is, it's 2. So x is greater than or equal to 2, but less than or equal to 8. And then they tell us that line ST is drawn parallel to the y-axis. We already have this. So let me just bring down the graph so that we can actually look at this properly. Okay, so what they're telling us is that we have this point S, okay, which is here. And it's a point on the graph where x is greater than or equal to 2, but less than 8. As you can see, that is true because we already found the value of a to be 2, right? So that x value is over here. That is 2. And we know that this x value is 8. So indeed, that point S is sitting, its x value is sitting where x is greater than 2, but less than 8, okay? It's in between this. That's really what they're trying to tell you. Okay, and then what else did they tell us? They said line ST, that line ST, right, is drawn parallel to the y-axis. So all it is it is a vertical line, okay, parallel to the y-axis with a point T on the graph of G. So you see that S is on the graph of F and T is on the point on the graph of G, right? And you need to determine ST in terms of S. So you have to determine the distance of this line in terms of X. Because they didn't give you X and Y values, that's what we're going to have to do. So in order for us to actually do this, think about how you calculate the distance of a line, because ST is really speaking about the length of ST. So the distance of a line is calculated by taking the highest Y value, I'll call that Y2, right, minus the lowest Y value, Y1. But in this case, they didn't give us y values. The only thing they told us is that S is clearly on the graph of F, right? The parabola. And T is on the graph of G, the straight line. So the only way to find it is by using the y values of this graph. But that's actually using the function of it, because think about it, the y value of this graph F, right? We can express that as f of x. And the y value of G can be expressed as g of x. So to find the distance, because this lies on F, its y value, we can call that f of x. And because that lies on G, we're going to call that g of x. That y value is called g of x. So to find the distance, to say, you have to say that y2 minus the y1 to get exactly what the distance is. So we're going to say that f of x minus g of x, and that's going to give us our distance in terms of x. So f of x minus g of x, and then you just simplify that. So we know that f of x is this and g of x is that. So I'm just going to go ahead and write them down, and we're subtracting. Okay, so this is f of x, this is g of x, but you're subtracting, okay? G of x already has a negative in front of it. So if you're subtracting, you're going to have to protect this with brackets, okay? So that's what we're doing here. So it's equal to this, and we just have to simplify this really. You can actually just use the simplified expressions of when we were equating these two graphs. So when we're saying f of x is equal to g of x. Okay, so with this part, we already kind of worked on that. We know what this is going to give us inside the bracket, right? Because when we simplified the inside of the bracket, it ended up becoming this. So I'm just going to rewrite that. And then, of course, I know I have a negative in front of it. Okay, so we're going to have our negative and then x squared and our minus 7x plus 49 over 4. Okay, so minus 7x plus 49 over 4, and then that is going to distribute in. So if it distributes in, you get a negative x squared plus 7x minus 49 over 4. So that's what actually happens when that little part simplifies. Okay, then of course you have the plus 81 over 4, and then if you distribute here, you get positive 3x and minus 24. Okay. And this is equal to, we have negative x squared, and those two add and become positive 10x. And then all of these numbers really just simplify together. As you can see, if we simplify the constants, you're just going to get negative 16. So minus 16. Okay, so there we go. That is our answer there, and that is for 2 marks. So they'll really just give you a mark for actually forming your equation and then your answer. Okay. Moving on to the last question in question 5. Okay, last question 5.5 says, calculate the maximum length of ST. So in the previous question, we found the distance of ST, really, right? We found the distance of ST in terms of x. So since we have that distance, we can now use it to find the maximum distance. It's really the length of ST that we have. So we can now find the maximum length of it. Okay, so we know that ST is equal to negative x squared plus 10x minus 16. To find its maximum length, okay, to find the maximum or minimum, we are going to derive this function, okay? And remember, the idea behind that is this right now is a parabola. It's a concave down parabola. And to find the maximum length, or really the maximum of this parabola, that would be the highest points that it can reach. That is your maximum. So to find that, because this is your maximum point, it's also the turning point. So you're really just finding the turning point's y value of this graph, okay? To find the turning point's y value, there's 2 ways. You can either derive or you can use the equation for turning point, which is x is equal to negative b over 2a. Okay, so let's go ahead and find that. So we're going to derive this. I'll say st prime is equal to, and let's derive. So we're going to say coefficient times exponent, which gives us the negative 2x, and then that exponent minus 1, which is 1, and you don't have to rewrite that. Then this becomes 10 times 1, which is positive 10, and the exponent of 1, you subtract with a 1, which becomes 0, and anything to the power of 0 is 1. 1 times anything stays the same. So this is what we have, right? Then to find the turning point, that actual turning point, you're going to make your derivative, right, equal to 0. In other words, the derivative is the gradient of the function. You're making the gradient equal to 0 because at any turning point, the gradient is equal to 0. Since this is the place where the graph is no longer increasing nor decreasing. All through here, what the graph is doing here, if you look at it from left to right, this graph is increasing. It's moving up and moving up. And so the gradient you're going to find here would be positive because the gradient shows you whether the graph is increasing or decreasing. Positive gradients are increasing, negative gradients are decreasing. But at the turning point, the gradient stops doing that and it stands still. That's why the gradient is equal to 0. And that's why we make the derivative equal to 0. Okay, so now that we know that, we're going to go ahead and say 0 equals negative 2x plus 10. And then I can just go ahead and take the negative 2x over to make it positive, divide both sides by 2, and x is equal to 5. Now, what we just found right now, and I keep erasing that diagram, it's actually helpful. What we just found right now is the x value of that turning point. You still have to find its y value. So to find its y value, you can take the x value and substitute it into the original function, okay, of this concave down parabola, which is this. That is the original function. That is the equation of st, the length of st. So we can do that and say that st, we're substituting where x is equal to 5, is going to be negative, and we have 5 all squared plus 10 times 5 minus 16. And that will give you your maximum. So let's go ahead and find that. And our answer for st, the maximum, is 9. Okay, so we can go ahead and tell them that the maximum length, okay, of st is 5. Okay, so that is that question, and we are done with question 5. We finally move on to question 6, which is the last part of functions for this paper. We are on question 6, and question 6 says the graph of f of x is equal to 3 to the power of x is sketched below. So as you can see, this is an exponential function, and there's something here that I know we cannot see but is there. Okay, please remember that this exponential function, it usually has a q value, okay? But because we can't see the q value, please note that that q value is equal to 0. Your q, okay, in your exponential function, a times b to the power of x minus p plus q, that is your horizontal asymptote, okay? So because it's your horizontal asymptote, it's the line, the horizontal line that this graph will never touch, okay? And we also have a point which is p, -1, and 1 over 3 is a point on this graph f. So please just remember that we have that over there. That q value is 0, okay? That horizontal asymptote, because it's a horizontal line, its equation is y equals 0. Horizontal lines always start with y equals, because it's really just a line passing a value on the y-axis, okay? So this is what we have. And the first question, 6.1, is to write the inverse of f in the form of y is equal to. So to write the inverse, because this is the original function, we can go ahead and write it in terms of y first of all. So it's y equals 3 to the power of x. Then to find the inverse of it, you swap x and y. So it's x equals 3 to the power of y. And then to simplify or solve for y, you're really just going to make y the subject. The only way to make y, or the exponent, the subject, is by using log. So we say y is equal to log of our base, and then we have x here. Okay, so that is the equation that they're asking for, the equation of the inverse of f in the form of y equals. So moving on to the next question. The next question, 6.2, says sketch the graph of y equals, as you can see, this is the inverse. So sketch the inverse of f and the inverse where we have x minus 2 on the same set of axes in your answer book. Clearly indicate or intercept with the axes. So let's understand what happened here. We know that this is the inverse, right? That is the inverse. And this is also the inverse, but something happened here. They said x minus 2. Remember, when you add a subtract to the x, you're really just moving this graph horizontally, which is left or right. When it is a plus, it's moving to the left. And when it is a minus, it is moving to the right. So this graph is actually moving 2 units to the right. So it is the inverse, but it's moved 2 units to the right. So we have to sketch this one first, then we'll be able to understand how this one looks. Okay, so let's go ahead and put our axes down. Now, sketching the inverse function is actually really simple. And the reason I say so is because remember when we were finding the equation of this, what was the first thing we did? We swapped x and y. Okay, swap x and y. So because of that, really what happens to the function is all the x and y values of the function just get swapped. Okay, so if your graph initially looked like this, right, then the new graph is going to do this. You see, the x and y value, we have 1 point on this graph and we can use that. The x and y value are going to swap. So we're not going to have -1 and 1/3. We're going to have 1/3 and -1 as our new point of P, okay, the image of P. So let's go ahead and put that down. Okay, so along with the x and y values swapping in this function, right, to get the inverse, what's going to also happen is the asymptotes are also going to swap as well. You see that here we had a horizontal asymptote of y equals 0. Now, in our inverse, we're going to have a vertical asymptote. And instead of it being y, because it's vertical, it's going to be x equals 0. Okay, so that's the first thing I want to let us know, that we're going to have an asymptote over there. Okay, so I'm going to actually write the equation. We have x equals 0 over here, and then the graph really just swaps. So the points that you have P, instead of it being -1 and 1/3, the x and y value will just swap. So you have 1/3 and -1. That's what you're going to have as your image of P in your new graph. So here, 1/3 and 1. So let me just put down some coordinates just so that there's a bit of order here. Okay, so you see what our original function did. Our original function, what it was doing is it was increasing, but it was coming from the negative part of the x-axis. And then as it moved towards the positive part of the x-axis, what it started doing was it started increasing. Okay, so we're looking at it as the y values were going from the, not really negative, but a lower part of the y-axis, and then the y values basically just started to increase. So this is going to do the exact same thing, but it's just going to do the other way around. We first have to plot that point down. So -1 and 1/3 becomes 1/3 and -1 here. So 1/3 is somewhere here, right? And then -1. So this is our new point of P over here. And we can just put it as P prime, the image of P. So that is 1/3 and -1. And then our graph is going to do this instead of it doing this. So you can actually just imagine it like this. The easiest way to do this is you see your x-axis, treat it as if it's your y-axis, and your y-axis, treat it as if it's your x-axis. So when we're looking at this part, you see the negative part of your x-axis, you're going to now focus on the negative part of your y-axis. So that would be here, right? And it means that your graph is going to be really close to the negative part of your y-axis as it is close to the negative part of the x-axis here. See, it's coming from being really close to that, and then it starts to increase. So that's what we're doing here. It's coming from here like this, and then it starts to increase, okay, as it moves towards the positive part of the y-axis. And here is as it moves towards the positive part of the x-axis. That's really what it's doing. It's doing that. So over here, you're going to just treat your y-axis like it's your x-axis, and that's exactly what it's doing. But it's going to pass that point P. That's the only difference. So we're going to have it doing something like this, pass the point P and go up. And there we go. So that is our graph. That is the f-1. That is the inverse, first of all. I'll just call it f-1 of x so that just we'll know exactly what this one is. Okay, so now that we have this graph sketched, I feel like having the x-intercept will be very helpful here because it might be useful. So you can find that. Well, the x-intercept is not a difficult thing because here, this is what you're going to think about. You see Q here? That's your y-intercept. Now, there's something you would have noticed by now. When you have an exponential function, when you see the value of p here is still 0. So if your value of p is still 0, and you still have this over here, the q value is still equal to 0, then naturally your y-intercept is always going to happen at 1. Okay, that is really just because to find the y-intercept, you make x equal to 0. 3 to the power of 0 is 1. Okay, so that's what we know. So if the y-intercept as a coordinate is 0 and 1, and you have your inverse function and it swaps places, okay, the x and y swap places, then it means that the new points you will have on your inverse would be 1 and 0, which is an x-intercept. See, we didn't need much calculation. Okay, so we know that the x-intercept is supposed to happen at 1. So I'll just try to draw it again, just let it pass 1. Okay, so like that, I had to just redraw the graph, okay, so that it passes 1 and still that 1 over 3 and negative 1. Okay, so that is what our inverse function looks like. That is the f negative 1 of x, right? Then we have to draw this one, okay? The inverse that is shifted 2 units to the right. So all you're going to do is take this graph and you're going to shift it 2 units to the right. So because it's moving to the right, this is a horizontal movement and it's affecting the x. It means all the x values of this graph are going to all move 2 units to the right. So what happens here is, remember that we had an asymptote here, right? We already wrote that asymptote. It was x is equal to 0, right? That line there. It's going to also move 2 units to the right. So that asymptote moves from 0, 2 units to the right, it moves to 2. So now your new asymptote there, I'm actually just write it like this in green. Your new asymptote there is a line that's going to pass 2. So there we go. And it's going to be a dotted line. So let me just make that dotted. And the equation of it, instead of it being x equals 0, it's x equals 2. Okay, so that's the first thing that we have. Then you see that we have this point 1 and 0, the x-intercept. That's going to move 2 units to the right. So 1, 2, it now appears at 3. So that's going to be over there. That's the new x-intercept of this graph, right? This graph is green. And then we also have this point, of course, it's 1 over 3 and negative 1. So it's moving to the right, okay? So only the x value is going to change. It's moving to the right by 2 units. Okay, so that's like 1 over 3 plus 2, which is really just, okay, so that's going to give you 2 times 3 is 6 plus 1 is 7. So that's 7 over 3. And 7 over 3 is about 2.3 recurring, right? Okay, so that is just past 2 and 0.3 recurring. So it's just right here, just and a third, somewhere here. Okay, so that is our new point there, 7 over 3 and negative 1. Still the same, okay, still the same y value. And so our graph is just going to do the exact same thing. It's just going to do that using this as the asymptote. So it's going to look like that. It's going to be coming from here, increase, and then shoot like that. Okay, so that is your f negative 1, x minus 2. There we go. So these are your 2 graphs, and that's what it's going to look like. It's very important to remember that this has an asymptote. Despite the fact that we may not see it, it is there. Okay, so that's what that looks like. Okay, moving on to the last question in question 6. Okay, 6.3, the last question in question 6 says, use your graphs drawn in question 6.2, so the previous question, to solve for x. If log of base 3, we have x minus 2. So as you can see, this is this function that we have here, right? Because you see that it's the same thing as the inverse. You just have an x minus 2. So that is the green graph, right? So if this is less than 1, so you need to find the values of x for which the green graph has a y value that is less than 1 or has y values less than 1. Let's look at that. So because we're saying less than 1, remember they're referring to the y values. They're just telling you find the places or the values of x where you're going to have all these y values being less than a y value of 1. So your y value of 1 appears here, right? So this is our marker. We need to find all the places on the green graph where its y value is lower than that 1. And as you can see, we can actually see it here. All the places on this graph that has a y value lower than 1 is all through here. So all through here like that, okay? Because there's 1, and then everything below it is less than 1. So everything here. But now we need to be able to express that in terms of x. How do we do that? Remember, you see, the asymptote is something that's going to really help you a lot here. Because there's an asymptote of x equals 2 here, it means that this happens all through here. So values that are here, and they keep going, and where they end at is here, okay, where we have a y value of 1. So the first thing we would have to do is find out exactly what the x value is when our y value is 1, so that we know where to stop. Because we know where it starts. It's when values are greater than 2. But where does it end? Okay, so let's find out exactly where does this graph have a y value of 1. And really all we're doing there is saying, where does it have a y value of 1? You're making 1 equal to that function, the function of the green graph of f of x minus 2, right? Which is this log with the base of 3, and we have x minus 2. So we're really just making it equal to 1. You can write it in exponential formats to solve for x. So the base is 3. That would mean the exponent is the 1. And then what it's equal to is x minus 2. So solve for x here. If you take the 2 over, it becomes positive. 3 to the power of 1 is 3. So that's 3 plus 2, which is 5. And so you can see now that x is equal to 5. That this happens at the point where x is equal to 5. My numbering is obviously not too good here. So maybe we have 4, then 5, then 6, okay? So it happens here where x is equal to 5. That's where it stops. So we can see now that the places on this graph that has a y value that is lower than 1 on the green graph, it starts here and then it shoots down like that. But when we're looking at it in terms of x, these are values that are greater than 2 but less than 5, okay? So that's really the only calculation we needed to do here. So we're going to go ahead and tell them this is where x is greater than 2 but less than 5. So one thing that would have really helped you in this is remembering that this has an asymptote because it is a log function. Okay, so we are on question 4, and question 4 says this. They say, sketched below is the graph of f of x, which is equal to, we have 2 to the power of x minus 4, so we have an exponential function, okay? And for x, x is an element of negative 2 to 4. Okay, so that's something we'll probably have to look at. And then we have a and b are respectively the y and x-intercepts of f. So here's a and b. Okay, the first question, usually simple ones. You see, usually these questions, this is your places to score marks. If the last question gives you a headache, just skip. It is better to lose 2 marks than to spend 10 minutes on a 2-mark question. Okay. Then we have 4.1 says, 4.1, determine the equation of the asymptote of f. Well, f is an exponential function. The asymptote that it has is a horizontal asymptote. And that shows here in the equation. See, we have 2 to the power of x minus 4. That minus 4 is showing you your horizontal asymptote. Because this is a horizontal line, it will start with y is equal to, not x is equal to, because it passes the y-axis, and then we're saying y is equal to whatever number it passes the y-axis at. We can see that number here, that minus 4. Okay, so y is equal to negative 4. So whatever has the exponents, whatever is the coefficient of it, like if it was something like this, that part you don't take. You take that part. And if there's nothing there, it means that it's 0. Okay, so I may just make small explanations like that. So it means that y is equal to negative 4. Because that's the number that we have there. It's a negative 4. Okay, next question. They want us to calculate the coordinates of b. Well, what is b? B is the x-intercept of this graph. The x-intercept, how do you calculate that? You calculate the x-intercept by making y equal to 0. Make y equal to 0 to find x-intercept. So we're just going to say f of x is equal to 2 to the power of x minus 4. And we're substituting in place of y 0. So f of x now becomes 0 because it's y to the power of x minus 4. I can see this is negative, so I'll take it over. It's now positive 4 is equal to 2 to the power of x. And then this is an exponential. So exponential, you have to make the basis the same. 4 can be written as 2 squared. It's equal to 2 to the power of x. And so therefore x is equal to, equate your exponents, x is equal to 2. Okay, so since x is equal to 2, the coordinates of b, because it's an x-intercept, is b is going to be, the x value is 2, the y value is 0, because it's an x-intercept. That's why we made y equal to 0. Moving on to the next question, 4.3. 4.3 says, determine the equation of k, which is a straight line passing through a and b, in the form of k of x is equal to that. Very simple. It's just a straight line. It's passing a and b. So to find the equation of the line passing through a and b, you just have to find the gradient of that line, and you need at least 1 point. So to find the gradient of a line, you need 2 points by default. Okay, so to find that gradient, I have b because it's one of the points it passes on. Now, which point do I need? I need a because it's the second point that it passes through. So how do I find a? Well, a, as you can see, is your y-intercept. So how do you find the y-intercept? By making x equal to 0. So I'm taking f of x is equal to 2 to the power of x minus 4. And I'm just going to make x equal to 0. 2 to the power of 0 minus 4, f of 0 is equal to, anything to the power of 0 is 1. So that's 1 minus 4. 1 minus 4 is negative 3. So it means that a is actually, the x value is 0 because it's an y-intercept, and the y value is negative 3. There we go. We have 2 points now. We can use this to find the equation of that line. So you're going to find the gradient of it first of all. So remember, we are using these 2 points. So the gradient of AB, you say y2 minus y1, so 0 minus negative 3. 0 minus negative 3 really just becomes 0 plus 3, so over, and y2, x2, sorry, minus x1, which is 2 minus 0. Okay, so that's going to be 3 over 2. Okay, so gradient is 3 over 2. Now that we have the gradient, we can substitute it into the equation of a straight line. Now, you can use the equation y is equal to mx plus c. Then substitute your m and one other point. I'm just going to choose b because it doesn't have negatives. I like stuff without negatives. So 2 and 0. This is my x and my y value. You can just use that and substitute. Let's just go ahead and do that. I was going to use a different method, but it's okay. So my y value is 0. M I now know is 3 over 2. X is 2. And I have plus c. I just have to find c. So 0 is equal to 3 over 2. Oh, that's multiplying. So the 2's will cancel. You can use a calculator, but I'm looking at it as a fraction. Those 2's will cancel. So when they cancel, you just have 3 plus c. If you take 3 over, you have negative 3 is equal to c. So therefore, y is equal to, our gradient was 3 over 2. So we have 3 over 2x minus 3. And that's our answer. Okay, so that looks fine. 3 over 2x plus minus 3. And moving on to the next question. So you see, first 3 questions, that was fine. Okay, moving on to the next question. It says, calculate the vertical distance between k and f at x is equal to 1. So they're telling you where exactly to calculate this. So we're going to end up with a number, not just an expression in terms of x. So for me to find the vertical distance between f and k, or k and f, I first have to see which one is above which one. Because if you want to find the distance of a line, you need a point that is above and a point that is below so that you can say the top minus the bottom. So I need to know which one is above, okay, and which one is below. Is k above f? Well, where x is equal to 1, right? Let's think about that. We know what b is now. B is 2, right? We found that. 2 and 0. So if this is 2, then 1 is here, somewhere here. And in this region, do you see that the straight line, k, is above the hyperbola? No, sorry, not the hyperbola, the exponential function. It's above the exponential function. So since k is above f, you're going to have to say k of x minus f of x. That's how you'll find that vertical distance, okay? Because you need to say the one that is above minus the one that is below. So I'm going to say k of x minus f of x. And let me just call this the distance. I guess I can just call it the distance. D is equal to this. And k of x, I now have the equation of it. It is 3 over 2x minus 3, 3 over 2x minus 3, minus, I know what f of x is already from the start. It was 2 to the power of x, so, but remember there's two terms, so you need to protect it with brackets. 2 to the power of x minus 4. Then when you're simplifying, we're just saying 3 over 2. We have x minus 3, and we distribute. That's negative, and 2 to the power of x, okay? That's just the coefficient. It's not really, And so we have negative times that negative, which is positive 4. You can simplify this a bit further. So 3 over 2x. Let's put the numbers together. So we just have a minus 2 to the power of x. Positive 4 minus 3 is positive 1. Okay, so this is the expression for the distance, the vertical distance. But they specifically told us where to find it. They said where x or at x is equal to 1. So in place of this expression, the distance, I'm going to substitute 1 in place of x. So I'm saying d of, I guess I could have just called this d of x this whole time. So d of x. So I'm saying d of 1 now is equal to 3 over 2 times 1 minus 2 to the power of 1, okay, plus 1. Okay, now that all of that is in, I'm just going to go ahead and find the answer. So this is equal to, I'm just going to use the calculator, 1 over 2. And so that is it. The vertical distance is a half. Okay, so that's what we get. Now the next question, 4.5. So you see, first few questions always okay. 4.5 says we have to write down the equation of g if it is given that g of x is equal to f of x plus 4. Okay, another simple one. Just write down the equation of g given this translation that has happened. So since g of x is equal to f of x plus 4, then the equation of g of x is going to be equal to, just substitute whatever f of x is, and then you just say plus 4. So f of x, that was 2 to the power of x minus 4. So 2 to the power of x minus 4. Then we just put in the plus 4. As you can see, negative 4 and positive 4 would cancel. G of x is just going to be equal to 2 to the power of x. And that's our answer. Okay, moving on to the next question, 4.6. We're almost done with this question 4. So question 4 says, write down the domain of the inverse. Okay, now the reason I'm stopping here and thinking about this carefully is because of this. You see this part? Yeah, I know they didn't do this for nothing. They restricted this one. Okay, so we have to think carefully about this. Okay, so here is the thing about the domain and the range of a function. You have to think about what the original function is and then the inverse of it, right? So if this is the original function, right, and this is the inverse of the function. So we have the domain of the function, right? And we will also have the range of this function. Now, whatever the domain of this function is, it's going to become the range of the inverse. And whatever the range of the original function is going to become the domain of the inverse. Okay, that's how they work with inverse functions. So I want to think about this carefully because I know that this was a translation from the graph of f, meaning we had the graph of f and then it was translated and became the graph of g. But I notice here that there was a restriction applied to the domain of f. So if there was a restriction applied to the domain of f, then since g is coming as a translation from f, then that restriction would also be applied to it as well. So since the graph of f of x, right, f of x being equal to 2 to the power of x minus 4 it had a domain of x is an element of ranging from 2 to 4. But remember that 2 is actually included. That's why there's a square bracket, meaning x has a value of 2, but not necessarily 4. It's just numbers that are less than 4, but not exactly equal to 4. Okay, that's why it looks like this. We have a closed circle here and an open circle, just to indicate that it's not really equal to 4, but its numbers less than 4. Those are the x values we're speaking about. So since this is the domain of f, then this would also count as the domain of g. G of x is equal to 2 to the power of x. This is the domain of g, right? So in order to be able to find the domain of g's inverse, I need to know what exactly the range of g is. I know what its domain is. Its domain is this, because it's the same domain applied. It's kind of like it's a restriction. It's saying you can only draw a graph, or this graph can only exist within -2 to 4. So that graph of g, right, we know it became this. So as you can see, it shifted up. So that graph is probably like here. But either ways, it's been restricted like that. And because it's being restricted, its range will also be restricted. So we need to find what exactly the range of g is. So let me find the range of g. Since this is the domain, it's saying that it can only go from 2 to 4. Then because of this restriction, what exactly would be the range? Since our equation is g of x is equal to 2 to the power of x, I would just say to find the y values, okay, where it's going to start and where it's going to end, right? What y value it's ending at, I would just say 2 to the power of and substitute an x value in there. So 2 to the power of 2 gives me 4. And then I'll also substitute that as an x value to find out where it's ending. So that's 2 to the power of 4, which is 16. So this is ranging from 4 to 16, meaning the range of this graph is y is an element of, and I'm going to have to put a square bracket again at 4, because you see that at 2 we had a square bracket, meaning x is equal to 2. So y will also be equal to 4. So starting from 4 and ending at 16 with a curved bracket, because it's not really including the actual number 16. So if this is the range, right, of g, so now what we have is, we have the graph of g of x, which is equal to 2 to the power of x. We have its domain, because that's what it seems like they restricted it, you see. So the domain of this was the same domain as f's domain. So x is an element of from 2 to 4, and its range was y is an element of going from 4 to 16. So it means that the inverse of g, right? The inverse of g, the domain of the inverse of g is going to be whatever the range of the original was. That's how it works. So the range was this. That's going to be the domain. But of course, it's a domain. You cannot write it in terms of y. You have to write it in terms of x. So it means that the domain, right, by that rationale, because of that restriction, the domain of g is x is an element of 4 all the way to 16 and curved bracket. That's what I would say is the answer there, because of that restriction. Okay, moving on to the next question. The last question here, they want us to write down the equation of the inverse in the form of y is equal to. Okay, so the equation of the inverse, you know, the original of g looked like this, so 4.7. The original of g said g of x is equal to 2 to the power of x. So the inverse, we're just going to write this first of all as y. So it's y is equal to 2 to the power of x. Then first you're going to swap x and y. So in place of y, I'm going to put x, and 2 to the power of, in place of x, I'm going to put y. Then I'm going to make y the subject. To make y the subject, since y is an exponent, you have to use log. So y is equal to log, and we're going to put x, and the base is 2. Okay, log x base 2, and that is our answer. Okay, so that is it for question 4. And moving on to question 5. Okay, so now we're on question 5, and question 5 says this. We have the graphs. Let me actually just try to make this a little bigger okay, just in case. So the graphs of f of x is equal to negative 1 over 2x minus 1 all squared plus 8, and g of x is equal to d over x. So you can see this is a parabola and it's put in turning point form. And we've been given d over x. You see something over x, that is a hyperbola. Okay, it really looks like, it's very similar to the mother graph. And then we have, they are drawn below. A point of intersection of f and g is b. The turning point of f is also the turning point of f. Okay, the graph of f has intercepts at negative 3 and 0 and 5 and 0. So there we go. We have intercepts and a y-intercept at c. Remember, first questions are always very chilled. Don't panic. That last question, if it gives you too much of a headache, always just, come back to it later. So 5.1 says this. We have, write down the coordinates of the turning point of f. So remember how this is already put in turning point form, okay? It's already put in the form of a bracket x minus p all squared plus q. P and Q are your turning points. So notice that it says minus P here, but I said P, meaning whatever number you see here, if you see a negative 1, take the positive of it. You always really multiply it by a negative 1. So it means that your turning points, which is B as well, right? That is 1 and 8. So that's our turning point. Okay, moving on to the next question. The next question says, we need to calculate the coordinates of C. Well, C is the y-intercept of the parabola. How do you find the y-intercept? By doing what? By making x equal to 0. And you have to do that here because this is in turning point form. It's not in standard form where you can easily see the y-intercept as c. So this is going to be, we have f of, well, let me just write it here. F of 0 is equal to negative 1 over 2, 0 minus 1 all squared, plus 8. And you can just substitute that all into the calculator, and that's going to be your answer. And I get 15 over 2. Okay, so that is C as a coordinate is going to be, the x value is 0, and the y value is 15 over 2. So there we go, we have that. That's 15 over 2. Okay. Then the next question is calculate the value of d. So d is from g of x, d over x. Let's think about how we can calculate the value of d. Remember, it's just d over x, meaning if you have a point, you can substitute it in place of x and y, and then d will be remaining and you'll be able to solve for d. So we just need to find at least one point that lies on that graph of g, the hyperbola. Do we have a point that lies on it? Yes, we have B. B is the point of intersection between the parabola and the hyperbola, okay? And the coordinates of that was 1 and 8. We already had that. So I can find this by saying g of x is equal to, we have d over x, and we're just going to substitute. The x value is 1 and the y value is 8. So 8 is equal to d over 1. D divided by 1 is d, so d is equal to 8. Okay, so that's our answer. D is actually equal to 8. Moving on to the next question. The next question, 5.4, says write down the range of g. So do you see that g is a hyperbola? Hyperbolas work like this. Their range, okay, and the domain, very similar. They have basically every number on the number line, okay? They will have every single number on the number line. The only number they will not have is whatever their asymptote is, because they're asking for the range. Remember, the range is all the possible y values of the graph. So look, you see it has every single y value. The only y value it will not have is whatever its asymptote is. So you just have to think about what that horizontal asymptote, okay, because that's going to be a y value, one of the y values that it will not have. It will not have a y value of that. So what exactly is the horizontal asymptote of this graph? Well, the graph is really just g of x is equal to 8 over x. To find the horizontal asymptote, remember that this graph is actually supposed to be in the form of a over x minus p plus q. This is going to be a horizontal asymptote. And since we can see we don't have a plus q anywhere, it means that the value of q is 0. So we now know what that y value is. It's 0. So to find the range of this graph, the range of this graph is simply just y is everything. So it's an element of real numbers. But y cannot be equal to whatever the value of your horizontal asymptote is, which is 0. And that's your range. Okay, moving on to the next question. The next question, 5.5, says we have to, for which values of x will f of x multiplied by g of x be less than or equal to 0? So f of x multiplied by g of x be less than or equal to 0. Let's think about how this can actually possibly ever happen. If you're multiplying two things and they give you something that is less than 0, it means they give you something that is negative. The only ways that this can happen is if this is positive and this is negative, or if this is negative and this is positive. So what we're focusing on here is where on the graph do we have f and g having y values that are both positive and negative at the same time. Okay, so let's look at our graphs and see where that happens. Okay, so we can look at this side by side. Let's start off right at the edge. See here, right? If we look right at the edge here, I'm always going to look at it like this. So I'm saying that this has a y value here, somewhere here. You see this? Its y value, okay, of the graph of g is negative. It has a negative y value. And this one, the graph of f, also has a negative y value. That's a bad combination. That will not give us a negative. We're looking for where it's positive and negative at the same time. Okay, so that's not going to work. And you see that if we keep going all through here, it doesn't work because they're both just negative the whole time until we get here. Okay, at -3. And I'm specifically pointing at -3 because at -3, the parabola has a y value of 0. So its y value is 0. What is the y value of g? You have to make sure you align it vertically like that. So this will be for the same x value. The y value of g here is a negative value. The y value of f here is 0. 0 times a negative value gives you 0. That's one of the things we're looking for. When you multiply them, they must either be negative or equal to 0. So at -3, this is working. Okay, let's keep moving. We're moving towards the right. So we know that -3 is working. If you continue moving, like let's say I draw another vertical line here and look at the y values of these points. So here, this has a positive y value. This one at that same x value has a negative y value. This is a good combination. Positive times negative would give you negative. So this is working all through here. So it's still working here. Starts from here. Starts working. It's still working here. Okay, for the same x values, of course. And it's still working here. But the thing about it is I can't actually say it's working here anymore. The reason why is because we're going to have an asymptote here once we reach the y-axis. Okay, that's where our asymptote is, one of the asymptotes, because the graph of g says 8 over x. Remember that the original function of a hyperbola is supposed to look like this, a over x minus p plus q. So what exactly is that p value? It's also 0. So it means its vertical asymptote is also 0. So we have an asymptote here, and that's why I say I can't really pass here. So I can see now that this is working, right? From values that are greater than or equal to -3, but less than 0, I cannot include 0. So that's the first thing I'm seeing. I'm seeing places where f is positive and g is negative. That one worked out. This happened where x was greater than -3, but less than 0. Okay, so that's the first part I find. Let me find another part. I use a different color this time. Okay, so now let's just keep going. After this 0, you see that the parabola has positive values. It still has positive y values. Positive y value, a positive y value. And the hyperbola is also having positive y values. We don't want that. We don't want this situation where the y values are both positive, because if you take a positive times a positive, it will just give you a positive, not a negative. Okay, so we cannot take that. So if we keep going through here, they both have positive y values, and we don't want that. We keep going here, they still have positive y values until 5. at 5, the graph, this parabola f, has a y value of 0. Okay, so it has a y value of 0. And let's look at the graph of g for this same x value. So if we're looking at it for the same x value, this has a positive y value. But that's not a problem because this has a y value of 0. So it means that if you take that 0 times whatever that is, you still get 0. And that's what one of the things we're looking for. We're looking for when you take f times g, they give you 0 or something less than 0. So I say that, okay, 5 is a point that I need to remember to take, to include. It's a part of our solution. And then we keep on moving towards the right? And then you see that here, this has a positive y value. And this has a negative y value. We want positive times negative. So positive times negative is negative. So it's working all through here. And you see that here again, still has a positive y value. And for that same x value, it's a negative. So I can see that it's working all through here as well. So starting from the 5 like that, and for the same x value like that. And it will keep working because as you can see, this parabola is shooting down. And this one is just going to go closer and closer to this x-axis, but it will never touch it, meaning it will continue to have positive y values, even though it's getting closer to this x-axis. So see, it has a positive. It will still have a positive y value. Okay, no matter how close it gets, it will still be positive. So the solution here can be that I have to include 5, but I can see that it's values that are going this way, which are values that are greater than 5. So here I can say, or x is greater than or equal to, because I have to include 5, okay? Because at 5, that has a y value of 0. 0 times that is 0, which is what we are also looking for. So you see that that works out. I don't know, did I write? I think I might have erased that. So I meant positive there. Okay, so that would be the two places where if you multiply them, they give you a value less than or equal to 0. Okay, so that is that question done, 5.5. And we move on to the next question, 5.6. Okay, so 5.6 says we need to calculate the values of k so that h of x, which is equal to negative 2x plus k, will not intersect the graph of g. So this must not intersect the graph of g. Well, when you're thinking about things not intersecting, for you to actually be able to think about that, you're going to have to think about what it means for two graphs to intersect. When two graphs intersect, it means that they have the same x and y value at that point of intersection. So if we want to find out where h will not intersect the graph of g, how about we find out where they will? How about we make them intersect first, then we can manipulate that equation to then find out where they will not intersect. Okay, so here this is what we have. H of x is equal to negative 2x plus k, and we already know what g of x is. Well, g of x, they already told us that that was 8 over x, so it's 8 over x. I'm going to go ahead and equate these because they want us to find out just the values of k for which they will not intersect. In other words, what must k be for these two graphs to not intersect? So I'm going to make them intersect first. I'm going to equate them. Make h of x be equal to g of x. Then I'll tamper with that equation so that I can make them not intersect using delta. Okay, so I'm going to say negative 2x plus k is equal to 8 over x. This will be the values of k for which they will. Well, it's not going to be the values of k. This is just saying that they do intersect. Then I'm just going to have to simplify this a little further. Okay, so to simplify this, the issue that I see here is we have x on the denominator, and so it needs to be on the numerator. Okay, so since it needs to be on the numerator, we can get rid of this x by multiplying both hand sides by x. Okay, so if you FOIL in, this is what you get. You have negative 2x plus kx. I'm going to call it kx on purpose. Okay, this is the coefficient of x. And this is equal to this cancels and you have 8. So now do you see that this is, sorry, negative 2x squared, okay, x times x. Now do you see that this is a trinomial that it has just formed? So I can rewrite this trinomial as negative 2x squared. We have plus kx, and then minus 8 is equal to 0. This would be an equation for which these two intersect. This would be the equation when you equate them to those two graphs. But we need to make sure that they don't intersect. And we're going to do this using delta. Okay, so we just need to find the values of k for which they will not intersect. So you see, delta can be various things. If delta is greater than 0, the kind of roots that you're going to have, first of all, going to be real, right? Meaning you're actually going to have intersections, right? So if you're going to get roots that are real and will probably be unequal as well. If delta is equal to 0, your roots will also still be real, but they will be equal, okay? Real and equal really just means it's the same number, like x minus 3 and x minus 3, right? And then if delta is less than 0, your roots will just be non-real. In other words, they don't even exist, meaning that parabola that you form doesn't have roots. In other words, it doesn't even intersect that x-axis. It may be just way above the x-axis, or it depends on the shape of it. If it's like that, it doesn't even touch. So that's what we're going to do. We're going to manipulate this equation. We're going to find out the values of k for which they will not intersect. In other words, the roots will not be real. In other words, the roots will not exist. So I'm trying to find out where delta is going to be less than 0 for this equation. And so delta is b squared minus 4ac. I need to make that less than 0. So how do we make delta less than 0? Well, we're just going to substitute what delta is. B squared, well, our b value right now is this k, because this is in the form of ax squared plus bx plus c. You see now that your k is b. So in place of b, I'm going to say k, and I have to square that. Minus 4, and then a is negative 2, and c is negative 8. And this is equal to 0. Okay, so this is what we have. I have k squared, and what is negative 4 times negative 2? That is going to be positive 8. Then if you multiply that by negative 8, that is 8 times 8 is 16. So negative 60, 8 times 8 is 64. Negative 64 is equal to 0. Okay, sorry, why am I saying equal to 0? Less than 0. Less than 0. Okay, so I just have to solve for k in this inequality, really, because this will help this equation to not be equal. In other words, to not intersect. So this would be the values of k for which this will not intersect. H and G will not intersect. So let's simplify this. This is an inequality. I can look at this as difference of two squares. So open up two brackets. The square root of k squared is k, so k times k. Square root of 64 is 8, so I'll say plus 8 minus 8. So my critical values are negative 8 and 8. And I just have to solve. Now here I'm just going to use the graph method. I know earlier in the video I used the, table method. That was quicker. But I'm just going to use the graph method. So here I'm just going to look at the shape of my graph. K squared minus 64 is a parabola. It's a positive or concave up parabola. And I have my critical values of negative 8 and positive 8. And I'm looking for the places where the y value is less than 0. Again, you can look at my other papers. I do explain in more detail there. Okay, so where are the y values less than 0? Well, the y values will be less than 0 here. So we're not going to look at anything above the x-axis. You're going to look at all the parts that are below the x-axis, which is all through here. And so the x values belonging to this highlighted part would be x values that are greater than negative 8, but less than 8. Okay, that's the highlighted part's x values. And so what I'm saying is that k has to be greater than negative 8, but less than 8. And that would be the values of k for which h and g will not intersect. You see, you make them equal to each other, kind of like making them intersect. They will form an equation in standard form, and then you manipulate that equation. You find out the values of k rather, for which they will not have real roots, because when they don't have real roots, they don't intersect. Okay, moving on to the next and the last question for question 5. Okay, so question 5's last question is this. We are told that h is a tangent to g at r, a point in the first quadrant. So, okay. And then they also tell us to calculate t such that y is equal to f of x plus t intersects g at r. Okay, that's a mouthful. Let's think about that. Okay, let's break that down. So h is a tangent, right, to g at r. And they told us that that point r is in the first quadrant. Let's think about what g looks like. G looks like this. And they're saying that h is a tangent to g. So you have something like this. You have a tangent to g, right? A line that only touches g once. And this tangent to g, okay, its point of intersection is this point called r, which is in the first quadrant that they said. So this is h, this is g. Let's just keep that in mind. Okay, what else do they say? They say that calculate t such that y is equal to f of x plus t intersects at r. So we have this new equation or graph. It's called y is equal to f of x, so it includes that parabola plus t. We need to find the values of t for which it's actually going to intersect at r. Okay, so what's actually going on here is you have some sort of, we have this situation where we have h, we have g, but we also have a new graph, a parabola, which is formed by taking the graph of f and translating it somehow up or down. It's one of the two, right? So we have that. It's still an upside down parabola. Still the same thing, really. Okay, something like that, but it's intersecting at r as well, and we just need to find out the values of t for which it's actually going to intersect r. Okay, so in order to find out that, so to find t, we can think about it like this. If you can find the coordinates of r, the x and the y value of r, then in that equation of y is equal to f of x plus t, right? Since this is the point of intersection, then we could have just taken that. We can just take that and substitute it into this equation, because that's the point that it intersects. We need to find out for which values, or for what is the value of t that would help make r a point of intersection of this graph, this new graph. So when we find r, we can just take that and substitute it into this equation, and we will be able to find t. So the goal here is find r. Okay, how do we find r with the information that we have so long? Well, they told us that h is a tangent to r, okay? To g at r, sorry. H is a tangent to g at r. Let's also just write down the things that we do know. A g of x, right, it has an equation, so that we just see that it's not like there's no equations here. That's 8 over x. And h of x also has an equation. It's the equation that they just spoke about in this previous question. So h of x is equal to negative 2x plus k. Let's also keep that in mind. Negative 2x plus k. Because they said h is a tangent to g, what you should know about tangents to graphs is that at that point of intersection, okay, at that point of tangency, you know that the gradient of that graph and the gradient of the tangent are exactly the same. And that is actually a very powerful fact that we can use to even find the point of intersection. We can use that to find r. So how we can find r is because the gradient of g, in other words, g prime of x, should be equal to the gradient of h prime of x. And the great thing I'm seeing here is h is a straight line. And we can clearly see the gradient. Look at the gradient. It's negative 2. So we have that, right? We know that's negative 2. We just have to find the gradient of g. You know g of x is equal to 8 over x. So how about we find g prime of x, which is the gradient of g. So g of x is equal to, and I feel like I should have done this second. Okay, so I'm just going to put it down. So g of x is equal to 8 over x. Let me prepare it to be derived, because right now the x is on the denominator. It needs to come to the numerator so you can derive. So it's equal to 8x. But when you move it to the numerator, its exponent becomes negative, so to the power of -1. Now I can derive it. So g prime of x is equal to, I'm going to say, coefficient times exponent, -8. X to the power of exponent -1. -1 minus 1 is -2. So this is g prime of x. We have that. And so what I'm saying is I'm going to make g prime of x, the gradient of g, equal to the gradient of h. So that is -8x to the power of -2 should be equal to the gradient of h, which is -2. If you like, you could have derived it. The k would have still fallen away because it's just a constant. So -2. And now we just have to solve for x. You see, the x value here will tell you the x value of the point of intersection between that graph of g and your tangent h. So I'm going to say -8, and I don't like that this is negative, so I'm going to move it over to the denominator so that it can become positive. It becomes x squared is equal to -2. I shouldn't have done that there. Okay, let me get rid of this negative first. So I can get rid of the -8 to leave x alone. Divide both sides by -8, and so I have x raised to the power of -2 is equal to, what is -2 divided by -8? That is 2 over 8, 1 over 4. Okay, so at this point, I'm just going to put this in a way that its exponent is positive. So to do that, I'm going to have to change this to 1 over x squared, because I'm really just taking this, it's naturally on the numerator, and I'm moving it to the denominator so that its exponent can become positive. This is equal to 1 over 4, okay? So since it's equal to 1 over 4, to solve for x, if you like, you can cross multiply, okay? X squared times 1 is x squared, and 1 times 4 is 4. So x squared equals 4. Solve for x. If you square root both sides, you're going to have to say plus minus. X is equal to positive or -2. But they told us that r is in the first quadrant. So x is equal to +2. So there, we got the x value of r. Now we just have to find the y value. Okay, so the logic behind it is already figured out. We just have to apply it. So y, how do you find y? Well, it is the point of intersection of h and g. I don't have the complete h of x, but I do have the complete g of x. So I'll just substitute it into g. So g of, and I'm substituting the value 2 because I know that's the x value now, is equal to 8 over 2. And so g of 2 is equal to 4. And so now that I have that, I can just go ahead and say that g of 2 is equal to 4. And finally, this means that r is the point 2 and 4. Great, we have r. Now that we have r, we can finally find t, what they're asking for. You see, the equation is y is equal to f of x plus t. And we just need to find out what exactly is t, right? What should t be for this to intersect r, to pass through r? Well, we're going to take r and substitute it into here, saying that it's a point, right, on this. And then we'll find out exactly what t must be for this to actually happen, for it to intersect with r. So this is x and this is our y value. So I'm going to say 4 is equal to, no, let me expand this first. So y is equal to f of x is -1 over 2 bracket x minus 1 all squared plus 8. Then I still have plus t, right? I'm trying to solve for t. So now I can substitute x and y. So our y value is 4 is equal to -1 over 2. And then the x value is just 2 minus 1 all squared. And we have plus 8 plus t. Okay, great. I see numbers all through. So I see numbers all through here. I'll just simplify that and find out what that is going to be. And there I get 15 over 2 plus t. And this is 4. And then I'm just going to take 15 over 2 over 4 minus 15 over 2. You can use a calculator, but I can also express 4 as 8 over 2. So the denominators are the same. 8 minus 15 is negative 7. Negative 7. Okay, so negative 7 is equal to, we still have t there. And so this is now negative 7 over 2, because 8 minus 15 is negative 7, and the denominators stay the same. So there, that's the value of t. T needs to be negative 7 over 2 for this new graph to pass through R, okay, if given that H is a tangent to G. Okay, so that is that. That's the last question, yeah. So that is the last question for question 5, and that is it for functions. Now we're on question 4, and question 4 says, given g of x is equal to 1 over x minus 1 plus 2. So we have to write down the equations of the asymptotes of g. Okay, so it's only for 2 marks. The asymptotes of g, you have a vertical asymptote and a horizontal asymptote. Now, how you know which one it is this, the vertical asymptote is always the one with x. So if you have an x minus 1, your vertical asymptotes equation is actually going to be, you can kind of see it like you're saying x minus 1 is equal to 0, and then you're taking that 1 over. So it's x is equal to 1. That's the vertical asymptote. And then the horizontal asymptote would be the number that appears here, which is the number for q, right? So this one is p. Now, this one, it is horizontal, so it's going to start with y. Y is equal to 2, and that is our answer there. Moving on to the next question. 4.2 says, draw the graph or a graph of g indicating any intercepts with the axes and the asymptotes. So we already have the asymptotes. To draw the graph, we just need our intercepts. So let's go ahead and find those. So our equation is g of x is equal to 1 over x minus 1 plus 2. So first of all, we can go ahead and find our x-intercept. To find the x-intercept, you just have to make y equal to 0. So our y is our g of x, of course. So we say 0 is equal to 1 over x minus 1 plus 2. And then to solve for this, you can go ahead and take the 2 over, and it becomes a negative 2 is equal to 1 over x minus 1. So you have a number, fraction, and an equal to sign. Just turn the number into a fraction by putting it over 1, and then cross multiply. So we're going to say the 1 times 1 just gives us a 1. And then we're going to say the negative 2 times x minus 1. But remember, it's 1 term times 2 terms, so it has to multiply to both of them. Okay, like that. So I'm going to go ahead and do that straight away from here. I'm saying the negative 2 multiplies to the x and gives you a negative 2x, and negative 2 times negative 1 gives you positive 2. Then because negative 2x is negative, I'll take it over and make it positive 2x. Then we still have a 2 here, and this one comes over and becomes a minus 1. Then 2x is equal to 1, and then divide both sides by 2, and therefore x is equal to a half. So that is your x-intercept, and as a coordinate, it is a half, and the y value is 0, because remember we say make y equal to 0. So that's x-intercept. Then we need to find the y-intercept as well. So the y-intercept we find by making x equal to 0, okay? And so making x equal to 0, that is g of, in place of x, I say 0, is equal to 1 over, in place of x, 0 minus 1 plus 2. Then let's simplify that. That is g of 0 is equal to, well, 0 minus 1 is negative 1. So 1 over negative 1 is already negative 1 plus 2. That's going to give you positive 1 because it's 2 minus 1. So as a coordinate, our y-intercept is 0 and 1. So there we have our intercepts, and now we can draw our graph. With the graph, it's quite simple. Just draw a Cartesian plane first, and then make sure to label your axes. So that is our x-axis and that is our y-axis. Okay, so now that we have that done, you can go ahead and start plotting. If you want, you can put coordinates. So I'll just put a few coordinates. It's not really that necessary though. Okay, so this is the graph, and then we just have to put down, first of all, before the coordinates, put down your asymptotes. It's very important that you do that first. So remember that our asymptotes are x is equal to 1 and y is equal to 2. The x is equal to 1 is your vertical asymptote, and this one is your horizontal asymptote. So x is equal to 1, it's a vertical line, meaning it stands up. So it's going to be a vertical dotted line, of course. that will pass 1. So like that, and then just make sure to label it. So it's x is equal to 1. And then our horizontal asymptote of y is equal to 2 is a horizontal line that will pass 2. And then remember to label it y is equal to 2. Okay, so now that we have our asymptotes down, we can go ahead and start putting down our coordinates. So remember, the first coordinate we have is our x-intercept, which is a half and 0. So it's on the x-axis, it's a half and 0, meaning it is not past 1, it's here. So I'll put that there, and then I'm going to say a half because, we don't have that coordinate there. So you don't have to say a half and 0 because it's on the x-axis, you can just write a half. But when it's like a point, maybe something like 3 and -2, then you have to actually write it down. Okay, then we have that. And then the next point that we have is our y-intercept, which is 0 and 1. So we'll just go 0 and 1. And so we can see that that goes over there. Again, I don't have to write the coordinate. Okay, there's one more thing that we need to consider now. Now that we have our intercepts, we have our asymptotes, we need to consider the shape of this graph. So the hyperbola, the general form of it is y is equal to a over x minus p plus q. You see the value of a? If a is positive, then your graph is going to lie in the first and the third quadrant. And if a is negative, then your graph is going to lie in the second and the fourth quadrant. Okay, so that's how it works. So as you can see, our a value is 1, and that's positive. So it's going to lie in the first and the third quadrant. So our graph is going to look like this. When we're sketching down our graph, we know that it lies here and here. And so let's just follow the shape that we have here. Since our graph is going to lie here as well, you see that it's going to go like this and pass that and then go down like that. So something like this, it passes like that. And then we're going to have the other wing, which is going to be here in the first quadrant. So that you can just copy the way the shape looks, and you can just go ahead and say that is your other wing. So I'll just leave it like that. If you like, you can go ahead and find another point on the graph that would also be helpful, but it's fine like that because the most important points are there and the shape is there. Okay, so that is our graph. Moving on to the next question. Then question 4.3 says, determine the values of x where g of x is greater than 0. Okay, so where is g of x greater than 0? Okay, so to do that, we need the graph. We're going to look at the graph, and we're looking for, remember, g of x really just stands for y, meaning where the y values of g going to be greater than 0. The y values, okay, should let you think about the y-axis. Where you're thinking about y values that are greater than 0, these would be y values greater than 0, meaning you can only consider parts of the graph that have y values here. In other words, y values that are above the x-axis, because everything below the x-axis has a y value smaller than 0. So we're only going to consider parts of the graph that are above there. So as you can see, there is this part of the graph that we have to consider, and also this part of the graph. So all we have to do is now tell them the values of x for which these parts of this graph exist on this Cartesian plane. So we're going to look at that, and we can look at this and line it down to the x-axis. You see, if you line it down to the x-axis, you see the values that you have. It starts off here at a half, okay? That's when it becomes above the x-axis. And so these are values that are moving towards this direction, which are values that are really smaller than a half. So for that, we can actually tell them that x is less than a half. Now, I don't have to say less than or equal to here because they only ask for where g of x is greater than 0, not equal to 0. At a half, g of x is equal to 0 because it has a y value of 0 there. Okay, so for that wing, we're done. Then we have to deal with this wing. So what are the values of x for this one? Well, do you see that this graph is going up there and it's going to get closer and closer to this asymptote? So if you look at what's going on, these are the x values we're actually speaking about. So we can see where it's heading towards. It's heading towards the right-hand side. But where did it start? It started here after this asymptote of 1. Okay, that x value of 1. Then it was every value that came after it to the right. So this is where x is greater than 1. Okay, so we can tell them that. So, or x is greater than 1. And that would be our answer for this question. There's nothing really. We cannot say x is equal to 1 because we have an asymptote there and the graph does not have a value at x is equal to 1. So moving on to the next question. The next question says, determine the equation of the axis of symmetry of G which has a negative gradient. Okay, they've been very nice in these questions, honestly speaking. So the whole question 4 was really good. Axis of symmetry, we have to think about it like this. Okay, so you see a hyperbola. If you have a hyperbola, whether it is the one with a positive a value or negative a value does not matter. It will have two axes of symmetry. It first has the positive one, and the equation of that you just need to remember. If you remember the equation of the general equation of your hyperbola, which is y is equal to a over x minus p plus q, then you will remember this equation. It's just y is equal to x minus p plus q. See? Like in that original equation. So that's the positive one. That's the one with a positive gradient. That's why x is positive. The one with a negative gradient, if you can remember this one, you remember this one. The one with a negative gradient is formed by just putting a negative in front of x minus p. So y is equal to negative bracket x minus p and then plus q. Then if you distribute that, you see that y is equal to negative x plus p plus q. So that is the equation of the axis of symmetry of G, or of a hyperbola with a negative gradient. So let's go ahead and fill this in. So y is equal to negative x. And what is p and q? Well, we knew those values already from our asymptotes. You see that this is p here and this is q. Meaning, you see it says x minus p, x minus 1. So p is 1 and q is 2. Just like in your vertical and horizontal asymptotes. So we're just going to say we have plus 1, which is p, and plus 2. So your equation is just y is equal to negative x plus 3. That is the equation of that axis of symmetry. Okay, and that is it for question 4. And then we move on to question 5. Question 5 says, in the diagram, the graph of f of x is equal to log of x with a base of a, and g are drawn. Graph G is a reflection of f in the line y is equal to x. Okay, so we have the log graph of it, then we have the exponential graph of that. And so because they said it's a reflection, it's really just the inverse of that graph. Okay, then they tell us that graph f passes through the points P, which is 4 and 2, and Q is the x-intercept of f and R is the y-intercept of G. Okay, so they're just naming points that we have there. The first question, 5.1, says, write the coordinates of P prime, the image of P on G. Okay, so that's just the image of P on G. Remember that this is a reflection of this through that line y is equal to x. So it's the inverse of it. Since it's the inverse of it, when you're looking at this graph and looking at that graph, what changed is all they did was they swapped the x and y values. Okay, so to find the image of P on this graph, you would just swap your x and y values because it's the inverse. That's what happens with inverse functions. So P prime would actually be 2 and 4, and that will be your coordinate that you have here. So P prime is 2 and 4. Okay, moving on to the next question. Question 5.2 says, show that A is equal to 2. So let's look at that. Let's find A. So where did they mention A? They mention it in f of x. So f of x is equal to log, and we have x with the base of A. So let's go ahead and write that. So since we know f of x is log, we have A as a base. How do we find out that A is equal to 2? Well, this equation is almost complete. The only thing missing is the A. So it means that we just need one point to be able to find it. So be careful. Make sure you take a point that lies on F. So let's look at the graph. On F, we have a point P, which is 4 and 2. So let's go ahead and substitute 4 and 2 into this equation. So the y value is 2 is equal to, we have log, our base is still A, and the x value is now going to be 4. Okay. So now that it's in this format, we can actually put it back in exponential format so that we can solve for this, because we can't actually use the calculator for this since this is a. So this is how to put it in its proper format. First of all, you can think about what the base is. Remember, I kept calling this base, okay, base a. So that is your base. Your base is that number there. We're going to say that is a. But now a is being raised to the power of what? A is raised to the power of whatever this log function was equal to. Okay, so that's how that works. The logarithm graph really just makes the exponent the subject. So it's a to the power of 2 and then is equal to the number that the exponential function should be equal to. The exponential expression is 4. Okay, so that's how it works. That's your base, that's your exponent, and then that's the number it is equal to. Okay, now when we look at this, this is actually a quadratic equation because it has a squared. So naturally you would think, oh, okay, we can just square root both sides, which is true. You can do that. And I know normally we would consider the plus or minus, but please note we are speaking about exponential functions here. In exponential functions, we don't have negative bases. And I know that sounds weird. It's like, why don't we have negative bases? But we don't. And the reason why is because if you have a negative base, okay, let's say you have something like negative 2 to the power of, let's just try two numbers quickly. Negative 2 to the power of 1. And let's try negative 2 to the power of 2. And then you see what's going to happen. Let's also just include a third one. Negative 2 to the power of 3. Negative 2 to the power of 1 is negative 2. Negative 2 to the power of 2 is positive 4. Negative 2 to the power of 3 is negative 8. You see what's going on here? This is not going to draw an exponential function. It's going to be a zigzag function. Okay, so you're going to have like negative 2, 4, negative 8, and then something else. It's going to be a zigzag function. And that's why in exponential functions, the base is never negative. Okay, so that was just a little something I just wanted to throw in. So we're already just going to tell them that a is just equal to positive 2. And there we go. And that's our answer. Okay, moving on to the next question. Okay, 5.3 says, write down the equation of g in the form of y is equal to. Okay, so the equation of g. Remember they told you that this is f, the log, and then g is the exponential. So they want you to write down the equation of g. So since it's in the form of y is equal to, well, either ways, we would start with y is equal to, and let's just get our log function, the only one they gave us. They only gave us this. We're going to work with this and get it to g. It's inverse. So that is log, and we have the value of a now, it's 2 and x. So step 1, in order to find g, which is the inverse of f, you're going to swap your x and y values. Meaning in place of y, I'm just going to replace that with x. And then I say log base 2. And in place of x, I replace that with y. Okay, so now at this point, we have to make y the subject. So those are the only two steps. Swap x and y, make y the subject. That's all. Now, the only way to put y as your subject is to put this back in exponential form. Okay, so I'm going to go ahead and look at where my base is. My base is 2, so 2 is my base. And remember what the exponent is supposed to be? The number it's equal to, because the log graph always makes the exponent your subject. So we have x there. And then what is it equal to? It's equal to the y. And there we go. That is our equation of g in the form of y is equal to. Moving on to the next question. Then 5.4, we have t is a point on f in the first quadrant where TR is parallel to the x-axis. And we need to calculate the area of triangle RTP prime. Okay, that's specifically P prime. Okay, let's get the graph down and see what they're talking about. Okay, let's start off with what they told us at first. They first said T is a point on F in the first quadrant where TR is parallel to the x-axis. So there's this point T, and it's going to lie on the graph of F. But also, they also told us that TR must be parallel to the x-axis. So when you join T and R, they will be parallel to the x-axis. Lines that are parallel to the x-axis are horizontal lines. So it means that to draw that line or that point, you could really just do this. It's going to be a line. And so because this line is parallel to the x-axis, T is going to lie here on that line. Okay, That line does not look very, let me just fix that. Okay, so it's going to lie on here, and that is our t. So TR is parallel to the x-axis. Then what else do they say? Okay, so then they also tell us, they ask us to calculate the area of triangle RTP prime. So remember that P prime was somewhere here, but I'm starting to see that it's probably going to be here. It depends. It really just depends at the end of the day on where this is. Now, I could estimate where P prime is. I'll just put it here so long. And the reason I'm now thinking about it is because if I put it like too close, it's going to change the shape of this triangle. And if I put it too far, it's also going to change the shape. So I'm going to just put it anywhere for now. P prime, let's just say that was here. And remember, it was just 2 and 4. We will figure out where exactly it is, because remember, these are not drawn to scale. So just because something maybe looks like a right angle triangle, it doesn't necessarily mean it is one, unless they show you, some indication that, yeah, we have a right angle. Okay, so let's figure out how to actually draw this. Since we have this line already, and we know it's supposed to form a triangle eventually with that point, let's think about what T is going to be. Now, right now we don't have any other information about T other than the fact that this is parallel to the x-axis. However, if this is parallel to the x-axis, it means it's a perfectly flat line. So it would mean that the y value of r and the y value of t are the exact same thing. See? Because whatever number is here, that y value is also going to be the y value of your coordinate t. So the first thing would be, let's find r. Now in this case, r is easy to find because your equation is just y is equal to 2 to the power of x. Nothing has been added here. It's not plus 3 or anything. It hasn't been shifted to the left or right. Additionally, we can also see that the asymptote, because the exponential function, we're supposed to have a plus q here. Because there's nothing here, it means that your asymptote is 0. So here's the thing. If you have an asymptote of 0, and we have not added anything to the x, by default, it would mean that the first intercept, the y-intercept, is going to be 1. That's something that you're going to notice with these graphs all the time. You can calculate it if you want, but it's going to be 1. So now we know that r is 0 and 1. And so that would mean that t, its coordinate, is something and 1. Okay, so we know the y value now. Since we know the y value, we can actually find the x value, because this t lies on the graph of f. And because it lies on the graph of f, we can substitute this y value of 1 to get our x value. So let's go ahead and do that. So we take the graph of f, which, if you remember, is this with the 2 there. Okay, so this is our graph of f. And we are going to go ahead and substitute the y value of 1 to find our x value. So our y value is 1, which is equal to log, and we have a base of 2, and we have x. Now to solve for x, you have to put it in exponential formats because the calculator cannot do this for you. So we're going to go ahead and say our base is 2. And then our exponent is whatever number that is, which is 1. Which is equal to x. And so now we can see x actually is equal to 2. So I didn't want to make assumptions. That's the whole thing. So we know the coordinate of t now. The coordinate of t is actually 2 and 1, which is great. And the reason I say this is great is because now you see that this is 2. The x coordinate is 2. Do you see another point with an x coordinate of 2? That will be P. So now I know exactly where P is. P is actually just perfectly in line vertically with T. So it's 2 there. Okay. So that's 2 and 4. That's what we have there. And now if you join this triangle, you actually get a what type of triangle there? You're going to get a right angle triangle. And that is a right angle triangle because you can see that they have the same x value, so they're perfectly in line. This is a vertical line, really. And this line is parallel to the x-axis, making it a horizontal line. Therefore, you have a right angle. Okay, because we have a right angle triangle, we just have to now find the area of this triangle. They asked us to find the area, and we can use the rule a half times the base times the height. That's what we can use. So I'm saying the area of triangle RTP prime is equal to a half times our base times our height. So we just have to find the base and the height. The height is going to be super easy to find, and also the base, because this is a flat line. So we don't need to use any distance formula. Here's the reason I say so. You see that the base, this line, is going from, the x value is 0, and it's going from this point 0 all the way to 2. So how long is the base? It is 2 units, literally 2 units, 0 to 2. That's it. And then the y, we can also find that easily by saying, since this is a vertical line and this y value is 4 and this y value is 1, then just say the difference would be your height, meaning just say 4 minus 1, and that gives you that distance over there, and that's going to be 3 units. So there, our base is 2, our height is 3. Okay, remember this is not Euclid, so you don't need reasons. So we're saying a half multiplied by our base of 2 multiplied by our height of 3. And I'm just going to go ahead and say 2 times 3 is 6, and then half times 6 is 3. So our area is 3 units squared. Okay, remember that is the measurement of area. So that is our answer for that question. And that is the last question in question 5. So we finally move on to question 6. Okay, so now we are finally on question 6. And question 6 says, the graphs of f of x is equal to x squared minus 2x minus 3 and g of x is equal to mx plus c are drawn below. Then we have d and e are the x-intercepts and p is the y-intercept of f. Okay, so x-intercept, y-intercept. Then they tell us that the turning point of f is t, which is 1 and negative 4. Okay, they already gave us that coordinate, so just put that down. 1 and negative 4 is already there. Then they tell us that the graphs of f and g intersect at p and e. So graph of g and f here. So those are the points of intersection of those two graphs. The first question is, you need to write down the range of f. So remember, the range is really just all the possible y values of a graph. So if you see the way your graph looks, it's a parabola. And your y values, when we're looking at all the possible y values it can have. So look at this parabola. It has a y value here, for example, and here, and here. Okay, even these points have y values over here and here, and they keep having y values, and then the graph shoots up, meaning it's going to keep having all of these y values. But can you see a place where this graph will never have y values? That would be here. See below there, there is no more graph there. So there will be no y values there. So for you to tell the y values, or the range really, of a parabola, this concave parabola, you're going to actually look at where the y values started. What was the lowest y value it had? And that would be this y value here, negative 4. That's where it all started. Then it started having every other y value above it. So your range is going to be y is greater than or equal to negative 4. Now it has to be equal to negative 4. Do you see that? At negative 4, you have a physical y value, okay? The graph has a point that includes negative 4, and that's why our range is that. Okay, so that is our range. Moving on to the next question. Okay, so 6.2 says calculate the coordinates of D and E. So remember, they told us that D and E are our x-intercepts of this graph. Since we already have the equation, we can find the x-intercepts of them. Okay, let's go. So this is the equation we have, and these are x-intercepts, so you just have to make y equal to 0. So we have x squared minus 2x minus 3. Then this is a trinomial. Open up two brackets. Say x multiplied by x gives you the x squared. And then we need factors of negative 3 that can give us negative 2. Well, 3 is a prime number, so we can only have 3 and 1. So since this is negative, 1 has to be positive, 1 has to be negative. Which ones should it be so that we can have negative 2 in the middle? Well, we could make the 3 negative and the 1 positive. So negative 3 plus 1 gives you negative 2. So our factors are just negative 3 and positive 1. Then solve for x. It would mean that x is equal to, take your negative 3 over the equal to sign, 3, or x is equal to, do the same thing there, negative 1. Now just assign it to the correct one. D and E, they want the coordinates of D and E. So when we look at D, D is lower than E. So it's going to be the smaller one. So that is, D is going to be the negative 1 and 0. That's your Y value. And then E is 3 and 0. Okay, so that is that question. Moving on to the next question. In the next question, 6.3, they want us to determine the equation of G. Okay, so let's find the equation of G. When we're looking at the equation of G, do you see that G only has 2 points? So it has this over here. Remember, this is not, that's not that number there. And it has E over here. We know what E is already, that E is 3 and 0. So we can say 3 and 0. But what is this point over here? Well, first of all, it lies on the y-axis. And do you see that it is one of the points of intersection of F and G? Since it lies on the y-axis, it would mean that it's the y-intercept of both graphs. But the good thing here is that we have the graph of F. So it's the y-intercept of F. So to find that, you don't have to go and make x equal to 0. It's already showing here, since this is in standard form. It's in the form of ax squared plus bx plus c. And c stands for your y-intercept. So we know that our y-intercept is negative 3. So as a coordinate, that is going to be, it's a y-intercept, meaning x is equal to 0. That is 0 and negative 3. So there we go. We got 2 points on this graph, so we can actually find the equation of G. So let me put down these points. Okay, so these are our coordinates. We have our 0 and negative 3 and our 3 and 0. To find the equation of G, since it's a straight line, the equation of a straight line is y is equal to mx plus c, meaning you first need to find the gradient of this line. So the gradient is found by saying y2 minus y1 over x2 minus x1. And so this is equal to, and I put it in a top-down arrangement for a reason, so that we can just say y2 minus y1. Even if this is not y2, it's fine. Just stay consistent as well. If you say negative 3 minus 0, say 0 minus 3 as well. So negative 3 minus 0 over 0 minus 3. Okay, and so that's going to give us on top, you see you will have a negative 3 still, and 0 minus 3 is negative 3. So our gradient is 1. Okay, so we have our gradient. Now we just have to find C. So there are 2 ways. You can substitute it into this and then find C. Or you could use this formula. So I like to use this formula. It is y minus y1 is equal to m bracket x minus x1. So the y1 and the x1 just stand for a coordinate that you're going to substitute in. I'm going to choose the point E because it looks easier to use. So that's going to be my x1 and that's my y1. So I'm going to substitute by saying y minus my y1 is 0 is equal to, I have my gradient, it's 1. And then multiply by x minus my x1 is 3. So we're going to put that there. So it's 3. And we just have to simplify now. Now y minus 0 is just y. And then you have 1 here being multiplied. So if you FOIL in, it's x and minus 3. And that is your equation. So they say determine the equation of G. So we just have to write it as G of x. So G of x is equal to x minus 3. And that is our answer. Moving on to the next question. The next question, 6.4, says, write down the values of x for which f of x minus g of x is greater than 0. Okay, they're just trying to trick you by saying minus. You don't have to subtract anything. All you have to do is this. You see, since it says f of x minus g of x is greater than 0, why don't you just take negative g of x over the inequality? So you're going to have f of x and then greater than, and that now comes over and becomes positive g of x. This is actually what they're asking you. They're asking you for the values of x for which f of x is going to be greater than g of x. So remember they refer to y values, right? So because we're speaking about y values, if we're looking for places where f is greater than g, the only places where f is going to be greater than g is where the y values of f are higher than the y values of g. Okay, so you're really looking for places on the graph where the graph of f is above the graph of g. Remember, you can use a vertical line. Okay, a vertical line, very helpful. You carry it around with you. It's like a ruler. So in an exam setting, you just use a ruler. So I'm going to look through and see the places where f is above g. So here, is f above g? Yes, it's above g here. Is it above g here? Yes, see? There, this is on top of that. It's above that. And then if you keep going, you'll see that where they now meet at the same point would be at this point. And then after you get here, now you see there's an issue here. G is now above f and we don't want that. So the first place we can see that this is actually working out would be here. So it would be here and here, right? So we'll find the values of x for which that exists. Now, that would be, let's look at where that is. Where is f always above g in these? The x values for that would be all these x values that we have here. And it starts off where? It starts off here after this intersection. If you move to the left, you see that f starts to go above g. So where exactly, what x value belongs to this starting point? It would be 0. So after 0, when we move to the left, f is constantly above g. So we're going to write that down. That's actually where x is what than 0. It's moving to the left. Left numbers are numbers that are less than 0. So that's what we're going to write there. If we know now that, it means that x is less than 0. Okay, so we're not really done yet. We need to still use our vertical line / ruler. Hold this. And when we keep moving here, you see that g is above f. That's not what we want. We want where f is greater than g. Keep moving, still above, still above, still above, not working here. Then here, now your f is above g. Okay, so all the way here, g was above f. So now we have f being above g here, and it keeps being above g as they shoot till infinity. So what we're going to say is, where does that start? That starts, you see that just here, g was above f. So it starts here at 3. So since we know it starts at 3, we're just going to go ahead and say, okay, fine. It starts here and it's working for all these values. What are the x values that belong to this? Everything after 3 moving to the right-hand side. So that's where x is what than 3? Greater than 3. Okay, it's moving to that side. So that would be our answer there. So it's either where x is less than 0 or where x is greater than 3. And we don't need to say greater or equal to in any of these cases because they specifically just want where it's greater than g of x, not greater or equal to g of x. Okay, so that's our answer for 6.2. Moving on to the next question. Okay, then 6.5 says, determine the maximum vertical distance between h and g if h of x is equal to negative f of x for where x is an element of -2 to 3. Okay, so they want us to find the maximum vertical distance, a maximum kind of question, between h and g. So because they say between h and g and they say h first, we can just assume that they want us to find this distance by taking the graph of h of x and subtracting it by g of x, okay? Because you're trying to find the distance. These are graphs. However they look on a Cartesian plane, even if they were straight line graphs like that and that, which is not possible, but it's just an example. If that was the case, because they're saying the distance between them, if you wanted to find the distance between two graphs, okay, you're going to have to say, let's say you have that point, okay, and then go vertically in line, and that's why it's a vertical distance, okay, to that point, and you would have to say that one minus that one. So that's what we're trying to do, find a distance. And so you have to subtract naturally. Because we're saying h first and then g, let's go ahead and find out what they said h is. They told us that h is negative f of x. Okay, so we know this is to find the distance, right? Then they tell us that h is equal to negative f of x. Let's just speak about what that means. You see, if they say negative f of x, this is actually a reflection. So let's understand how reflections work. If you say this, take note of what became negative in f. Is it the x value that became negative or the y value? It would be the y value. Because remember that f of x stands for y. Okay? If I said y is equal to x plus 2, and I said f of x is equal to x plus 2, if you graph it, it's going to be the same graph. So y stands for f of x. Okay, so we know that now. And so, since y was made negative, this is how it's going to work. It's a reflection, right? But it's a reflection in a specific axis. We have two axes. We have an x-axis and we have a y-axis. If they make y negative, this is a reflection in the x-axis. Here's a brief explanation why, okay? It's a reflection in the x-axis. If I had a point and I called this point 1 and 2, right? And then I said, reflect this point across the x-axis. Like a mirror, you're going to just expect that this point is just going to be reflected across that x-axis. So here's your x-axis. Your x-axis is now behaving like some sort of like a mirror, right? So if this is the point here, it's going to be here. So the coordinates of this point will now be, I'll call it the image of P. The coordinates of this point would be what? Think about it. Did the x value change? No, the x value is exactly the same, still 1. What actually changed? It was the y value. The y value will change from what it was, and it will actually just get multiplied by a negative 1. So it would be negative 2. And so that's what happens. Now do you see that when you reflect something in the x-axis, it causes your y values to change. In other words, it causes your y values to get multiplied by negative 1. Okay, so keep that in mind. So now we can even find out what this graph of h is going to look like in our diagram. So let me pull the graphs down so that we can draw it down, just so that we can have an idea of what it's going to look like. Okay, so this is our diagram. Our graph of f is this. H is a reflection of f in the x-axis. So what's going to happen is this graph, if you reflect it across the x-axis, all the y values will change. So it means this point over here, it's still going to have exactly the same x value, but its y value is now going to be here. And then this point over here, its y value is going to be here. And if you keep doing that, you'll notice that your graph is going to do something like this and kind of do that. Okay, so let me just actually draw it properly because it's not supposed to intersect here. Let me draw it properly. So like this, that's what's going to look like. Okay, so we're going to go ahead, and that is h. Now there's a reason I'm drawing this. It's actually going to come into, there will be a reason. Okay, it has a need really. Okay, so now we know this is the graph of h. Let's go ahead and actually expand it, that equation of h. Let's go ahead and find out what it's going to be. Since we know it's h of x is equal to negative f of x, it just means whatever f of x is, you put negative in front of it. So I'm going to input f of x equation, which was x squared minus 2x minus 3. And so when you distribute in, you're going to get negative x squared plus 2x plus 3. That is the equation of h. And we also know what it looks like as well. So back to the question. Now that we have some things figured out, the question said determine the maximum vertical distance. We now understand you have to find maximum vertical distance by subtracting h from g, since they said between h and g. We know what the graph of h looks like. We also have the graph of g already completed. But then they say, after this, they say for where x is an element of negative 2 to 3. So what does that mean? Well, they're just saying you need to find the maximum vertical distance. But that distance is going to lie within the range or the domain of where x is going from -2 to 3. So we already know that this is -1 that we found here. So it's going to be between the points, the x values of -2 all the way to 3. It's somewhere within there. But there's a way we will know how to find it because they specifically asked for the maximum vertical distance. So let's go ahead and start finding the distance first. Okay, so let me put down the graph of G, which we already have. The graph of G was this. Let me put that down. So our vertical distance, we're going to find that by saying, I probably need some space here. We're going to find that by saying our graph of H minus our graph of G. So that is our negative x squared plus 2x plus 3 minus, now you see that you're subtracting by G and G has two terms, so you need to protect it with brackets. So minus x minus 3. So our vertical distance, not maximum yet, just the vertical distance. So our vertical distance, not maximum yet, just the vertical distance is negative x squared plus 2x plus 3. Then you distribute here minus x, and that becomes a plus 3. Okay, so distance is just negative x squared, and we have 2x minus x, which gives you positive x, and positive 3 plus 3, which gives you positive 6. So this is what we have. Do you see that the distance, right, of h minus g is expressed as a parabola? They want you to find the maximum vertical distance of that. Because we were able to subtract those graphs and they gave us a parabola, right, and specifically a concave down parabola, the only way to find the biggest vertical distance between those two graphs is by using this graph and actually finding out what its maximum value is. I know that sounds weird. It's like, how does that make sense? It's really just that you took that graph. It's kind of like you're taking H, you're minusing it by G, and we're looking for the biggest space, the biggest distance between these. Now, mathematically, it formed a parabola, which is very helpful. If we just find the maximum value of this parabola, that will tell us the maximum vertical distance. It will tell us the line that is actually the longest when you take that minus that. Okay, so that's really what's going on there. So in order to find that maximum, you have to think about how do you find the maximum of a graph, of a parabola, a concave down parabola. The maximum of that is always going to be the y value of your turning point. Okay, and here's just a brief explanation. You're looking at a graph. This is the highest that this graph can reach because it's concave down. The lowest it can reach would be infinity because it's going down forever. But the highest it will ever reach would be that y value. Okay, so there, we can go ahead and find that. So how do we find that y value of the turning point? Well, you have to find the x value first. And the only way to find the x value of the turning point is by using this equation because this is in standard form. It's not in turning point form. So you say, first of all, x is equal to negative b over 2a. And that will give you the x value of your turning point. So x is equal to, we have negative, and then we have 1 as our b value over 2 times negative 1. Okay, so that's really just becomes positive. X is equal to a half. Okay. And here's the special thing about it. You see that? A half. And look at the hint they gave us. This was a hint. That's all this is. They told us that x is an element of -2 to 3. Meaning your x value, right? The x value you're going to substitute into your equation to find your maximum vertical distance. That number is going to range between -2 to 3. And a half really does. It is between -2 to 3. So we're going to take that half to find that maximum vertical distance. We're going to go ahead and take it and substitute it into our equation because a half right now is just the x value at which this parabola will be at a maximum. So now we find the distance itself. So the distance, I'll say d max, distance of the maximum. So we have negative and then substitute a half squared plus a half plus 6. And you just find the answer to this, and that would be your maximum vertical distance. And for that, we get 25 over 4. That would be the maximum vertical distance. I apologize for the long explanation, grade 12s. I'm just really trying to make sure that you do understand the topic. I don't want to just go through it and then say, okay, that's the answer, okay? But please do let me know if the explanations are long, then I'll try my best to shorten it. So that is our maximum vertical distance, and we move on to the last question of question 6. Okay, 6.6 says, given k of x is equal to g of x minus n, determine n if k is a tangent to f. We need the graph. So I'm going to get the graph first, and let's go ahead and look at what this means. Okay, our graph is here. So they say given k of x, this is a new equation, new graph they're introducing. Given k of x is equal to g of x minus n. So we have a straight line graph, because remember that g of x was already a straight line. That was the equation x minus 3, right? I just want to make sure that I have that down. So k of x is really just equal to x minus 3 minus n. So given that n is a constant, a positive constant, it would mean that you're just taking that graph of g and you're just pulling it down. That's all, right? So given that that is the case, they want you to determine the value of n if k is a tangent to f. So since we have k being g of x minus n, they have the exact same gradients. So it's really like k comes from g. If let's just say that this was k, we just have a straight line like that, and that is k. So since we have that this graph is moving down, they want us to tell them the value of n for which this graph is going to be a tangent to f, meaning it must only pass n at one point. Okay, so all we have about this graph k is that its equation kind of looks like this. K of x is equal to g of x minus n, which is of course x minus 3 minus n. So it has the same gradient as this. We need to find now the value of n for which this graph is going to be a tangent to f. So first and foremost, for it to even be a tangent to f, it needs to touch f once. Okay, so how do we actually prove that this is going to be a tangent to the graph of f? First of all, we can start with the fact that this line, this graph of k, is parallel to g. And since they are parallel, we know that they share the same gradient. So if the gradient of g is 1, then the gradient of k must also be 1. So why don't we just find the place on f, the point on f, where it has a gradient of 1? Okay, because since this is a line, its gradient is the same everywhere. Here, the gradient is 1. Here, the gradient is 1. But that's not the same thing for f. The f graph has different gradients. It has a different gradient here than here and then here. So we just have to specifically find out where the gradient of f would be equal to 1, because that would be here, since that is the only place that intersects with f. So that's what we're going to do. We're going to go ahead and find out where is the gradient of f1. So start off by writing down your graph of f. F is just f of x is equal to x squared minus 2x minus 3. So we want to find out where their gradients are both 1, where their gradients are the same. So how I'm going to do that is I'm going to take the graph of f and find its gradient first. The way to find the gradient of f is to derive it. So f prime of x is equal to, you say the coefficient times the exponent, which is 2, then you leave x, and then you subtract 1 from the exponent, which is 1, and we don't have to write that. Then again, negative 2 times the exponent of 1 is negative 2. You have x to the power of 1, and you subtract 1 from that, which gives you 0. Anything to the power of 0 is 1. Negative 2 times 1 is negative 2. So this is what we have. This is the gradient of f. Remember, we're trying to find out where is the gradient of f exactly the same as the gradient of g. Well, we know the gradient of g. The gradient of g is 1, because it's x minus 3 minus n. So why don't we just equate their gradients, because we know they need to be the same thing. They both need to be 1. So we're going to therefore say that the gradient of f, which is 2x minus 2, we should make it equal to the gradient of g, which is 1. Okay, so 2x is equal to, we leave 1 there, take the negative 2 over, it becomes a positive 2. 1 plus 2 is 3. And then divide both sides by 2. X is equal to 3 over 2. So this is the x value for which their gradients would be exactly the same. Okay, now we can go ahead and find the y value. Why are we going to find the y value? Because it's ultimately going to help us to find n. Since we will have the full equation and only one thing missing, we can just go ahead and substitute that point, the only points we know about k, the only point on k that we have, and it will help us to find n. So let's go ahead and find the y value of this point. Remember, the y value of this point, sure, it lies on k, but it also lies on f. So we can find its y value by substituting 3 over 2 as the x value into the original equation of f. It will give us the y value. So we're going to say f of 3 over 2 and substitute that into the equation. Okay, so this is what we have. And then on the calculator, what do we get? Our answer there is negative. We have 15 over 4. Okay, so that's our answer. Negative 15 over 4 is our y value. So I'm going to put that there. Okay, so negative 15 over 4. So now we can use this point because we know the only way that this can be a tangent to this graph is if this is the point, okay, of intersection between the graph of f and the graph of k. So we're going to take our equation of k and substitute this point into that because we're saying that this is really a point on k. Okay, so we found that, and now we can just go ahead and say k of x is equal to x minus 3 minus n, and substitute this point in as our x and our y value. So that is, the y value is negative 15 over 4 is equal to, and then our x value is 3 over 2 minus 3 minus n. Okay, let's just be careful here. So we have negative 15 over 4, and these two can subtract. So just subtract them. 3 over 2 minus 3 gives us, well, that is just 6 over 2. Negative 6 over 2 is negative 3. So 3 over 2 minus that. 3 minus 6 is negative 3. And then 2 stays the same because we're subtracting by equivalent fractions. You can also use a calculator. Then you have minus n. And then we can just take that. Well, we'll just take the n over since it's negative. So positive n is equal to, and you have your negative 3 over 2. And that becomes a positive 15 over 4 when it comes over. Okay, we can change that. You can use a calculator as well. I'm just going to say times 2 to make the denominators the same. N is equal to negative 6 plus 15 over 4. Okay, and 15 minus 6 is 9. So our answer for n is 9 over 4. You can use a calculator. Okay, so that is the explanation of that. That's the value of n for which k would be a tangent to f. Hey guys, welcome to the function section of the grade 12 November 2024 Mathematics Paper 1 exam. Okay, so this is question 4, and question 4 says, given f of x is equal to a to the power of x minus 1. So we have an exponential function over there, and a is greater than 0. And then they tell us that b is a point on f. Calculate the value of a. Okay, simple. You can see that a is the only thing missing in the function. So if f of x is equal to a to the power of x minus 1, and b is a point on this graph, then you can substitute this into this function. So this is the x value, and that is the y value. So we can substitute as negative 5 over 9 is equal to a to the power of, and in place of x, we'll put in 2, and then minus 1. So there we go. We've put our y and our x value. And now you see that we can actually use this to solve for a. Okay, so let's go ahead and take negative 1 over. When negative 1 goes over, it becomes positive 1. But here's the thing about positive 1. It can be written as, because this denominator is 9, I'll write it as 9 over 9. You can use a calculator. And then it's minus 5 over 9 is equal to a squared. And 9 minus 5 is 4. So this is 4 over 9. The denominator stays the same since we're subtracting. And we have a squared. Okay, so this is actually a quadratic equation. So to solve for this, to get a alone, the 2 is disturbing us. So we need to get rid of the square by square rooting both sides. So with equations, you need to remember that plus or minus. And therefore, a is equal to, but here's the thing, they say that a is greater than 0, so you don't have to take the negative one, of course, because it's exponential. So that is going to be 2 over 3. So a is 2 over 3. Okay, moving on to the next question. The next question says, write down the range of f. Okay, and this is just for 1 mark. So now that we have a, it means that your graph looks like this. F of x is equal to, and you just have 2 over 3 raised to the power of x minus 1. So remember that the range is all the possible y values of the graph. When you're looking at this graph, a rough sketch on what it's going to look like is, you see that you have 2 over 3. And I would actually want to explain this more when we're sketching the graph. But the thing is that you need to focus on what is in front of this 2 over 3. You see, I know that they call this a, but really this 2 over 3 is a base. So you know in your exponential equation or function that says a times b to the power of x minus p plus q. That b, that's the base here. Okay, that the a is the coefficient of that base. Now, what is that number right now? It's actually an invisible one. So we can agree that it's positive. When your graph is positive, regardless of how it looks, whether it is increasing or decreasing, it will lie above the asymptote. So the asymptote here would be y is equal to, as you can see, you have a negative 1 there. That is the horizontal asymptote. So this means that this graph, all the y values it will have will be values that are greater than negative 1, because you have negative 1 on the y-axis, and then you don't have any graph below negative 1, only above. So all these parts of the graph, they're going to be above negative 1. So our answer here is simply just that y is greater than negative 1, not equal to negative 1, because the asymptote is a line that the graph will never touch. So negative 1 is not included there. Okay, and that is the answer for that question. Moving on to the next question. The next question, 4.3, says, sketch the graph of f, clearly show the intercepts with the axes and the asymptotes, if any. Okay, so let's go ahead and see. What do we need in order to sketch this graph? It is an exponential function. So here are the things that we can look at. First of all, we can look at the shape of the graph. Now, when I'm referring to the shape of the graph, I'm really speaking about where it is. First of all, is it above or below the asymptote? Is it increasing or decreasing? Okay, so when we look at this graph, we know, first of all, it is definitely above the asymptote because of the a value being greater than 0. But is this graph increasing or decreasing? Look at this part of the graph. So just this part with the exponent. It's 2 over 3 to the power of x. What happens with 2 over 3 to the power of x? The way you can just test whether a graph is increasing or decreasing, take that part that has the base, right? And substitute 2 values in it. Substitute x is equal to 1 and substitute x is equal to 2. Because you're supposed to read graphs moving from the left to the right. That's why I'm looking at a value like 1 and 2, because I want to see what it's doing. When you substitute x is equal to 1, you know that an exponent of 1 doesn't change anything. So you'll still have the 2 over 3, meaning you have 1, and let's just say this is 1 here. So you would have 2 over 3, which is round about here. Then what happens when you substitute 2? Well, the 2 gets squared, the 3 gets squared, and you get 4 over 9. Now you'd have to see between 2 over 3 and 4 over 9, which one is bigger? As a decimal on your calculator, you could check 2 over 3 is like 0.6 recurring. Then what is 4 over 9? 4 over 9 is 0.4 recurring. So you can clearly see now that the 2 over 3 is bigger. So what does that mean that this graph is actually doing? This one got a bigger y value than this one. So this graph is generally decreasing. Okay, so that's just an easy way to put it. It's generally decreasing. But really the idea behind it is what you have as a base here is a proper fraction. And a proper fraction will always have the numerator being bigger than the denominator. Because you have an exponent, these numbers are going to grow. But the thing is, because the denominator is bigger than the numerator, it's going to grow more than the numerator. So it's always going to be bigger than the numerator, therefore making the fraction smaller and just gets smaller and smaller as it progresses. Okay, so that is one thing you guys need to really look at. Okay, so we know that the shape of the graph, it is a decreasing function that lies above its asymptote. Okay, so first of all, we know it looks like that. Then the next thing that we can look for, well, we have a point on the graph, that's good, but we can go ahead and look for an x or y intercept. Let's go ahead and start with the x-intercept. So to find an x-intercept, you need to make y equal to 0. So our graph looks like that. Let's make y equal to 0. So that is 0 is equal to 2 over 3 to the power of x minus 1. And now that we have this, we can solve. So take the negative 1 over, it becomes positive, raised to the power of x, and you have 1 is equal to this, right? Remember, you have to make the bases the same because right now this is an exponential equation. So to make 1 a base of that, it's 2 over 3 to the power of 0 because anything to the power of 0 is 1. And now you see that our bases are the same and therefore we can equate the exponents. So x is equal to 0. What that point is 0, and remember we already made the y value 0. With that being said, you don't have to look for a y-intercept because this graph is going to pass 0 and 0. Remember, the x-intercept is where y is equal to 0 and the y-intercept is where x is equal to 0. Your x is already 0 here, so that means that your x and your y-intercept are at the same point. So we don't have to look for a y-intercept in this case. It's actually just 0 and 0 as well. Okay, so that's all we need. And now we can just sketch our graph. So you don't have to be too fancy with your graph. It doesn't even need coordinates too much. You don't really need stuff here. So just label, this is my x and this is my y. The first thing and the most important thing to do is first put down your asymptote. So your asymptote is -1, right? That's your horizontal asymptote. So we're going to put that down here. So let's just say it's here. And then it's of course going to be a dotted line. So that is y is equal to -1. So we have that down. And we can also just put down any points that we have. We have the x and y intercepts that are being shared at 0 and 0. So that's over there. And then another point that we have, just in case it's important, we'll put it down B. Okay, so we'll just give a rough estimate of where that would be. 2 and -5 over 9. So +2 and -5 over 9. So it's down, but it's not touching the asymptote. And you can just label that B. And of course, put the points down. So 2 and -5 over 9. And then you have to draw your graph. Remember that your graph is a decreasing function. We saw that. So it's going to go up like this and then down and connect and move like that, but never touch the asymptote. Okay, so there we go. That is our graph of f. And we can just call it f. And there we go. That is done. Moving on to the next question. The next question, and really the last question for question 4 is, it is further given that C is a point on f at y is equal to 19 over 8. Okay, so there's a point on f and it's called C. Determine the coordinates of C prime, the image of C. So C prime, when C is reflected about the line y is equal to x. Okay, so this is textbook knowledge. You need to understand what it means for a graph to be reflected about a line y is equal to x. The line y is equal to x is that line that is perfectly diagonal, okay? Y is equal to x because every single point is really just repeating itself on the x and the y value, okay? So you'll have 1 and 1, 2 and 2, 3 and 3, 4 and 4, and so on. Now this line, if you reflect anything across this line, in this case, we have a decreasing exponential. If you reflect it across this line, the reflection will be the inverse function. Okay, so now that we know that C is just the original and C prime is the inverse, you also have to understand the relationship between the original function and the coordinates there and the reflection. You see, if you have an original function and it has x and y, the reflection, all that happens, the reflection across the y is equal to x. In other words, the inverse, what happens there is the x and y value swap. Remember when you had straight lines and they'll tell you find the inverse function of this, then the first step would be swap x and y. Well, that's actually what happens with all the coordinates. The x and y values swap. So that would go here and that would go here. They just switch places. So let's look at what we have. They told us that C, right, is a point on the graph of f at y is equal to 19 over 8. So they didn't tell us what the x value is, but they told us what the y value is. So since we know the y value is 19 over 8, clearly we only need the x value. And once we find the x value, we will know that we'll just switch these around and that would be the inverse's coordinates. Okay, so let's go ahead and do that. First step is find the x value of the original on the original function. So to find the x value, why don't you just substitute the y value in? We already have the function, right? The full, that is it. Okay, f of x is equal to this. And we're just going to substitute that y value so that we can find out what exactly the x value is. So substitute the y value. Now we're going to have there 19 over 8 is equal to, and we have 2 over 3 raised to the power of x minus 1. And let's go ahead and just solve for x. So to solve for x, we can take the 1 over. That really just becomes a positive 1, which we can write as 8 over 8. See, I'm trying to do that because the denominator is 8. And it's plus 19 over 8, because that's positive, is equal to 2 over 3 raised to the power of x. And so 19 plus 8 is 27. So we have 27 over 8 is equal to 2 over 3 to the power of x. Okay, so this is something we can solve. Yeah, it looked like we could actually just make the bases the same, but I can see that we can't. If the denominator was 27 and the numerator was 8, then you could have done that. So in this case, I would advise that you just use log. Okay, that's the best thing to use here. So log makes the exponent the subject. So we make the exponent the subject and we say log of our base. So our base is whatever was carrying the exponent, which is 2 over 3. And then the answer we put here, so 27 over 8. Okay, so let's just go ahead and find out what exactly that would give us. On your calculator, make sure to use that log, the one with the base. Okay, so 2 over 3 and then 27 over 8. And we get... Okay, so we get negative 3. Good. You get a nice solid number, negative 3. And so now that we know the x value is negative 3, what it means is that C is negative 3 and 19 over 8. And so C prime is going to be 19 over 8 and negative 3 because they just switch places. And that is your coordinate for C prime. Okay, so that is it for that question, and we move on to question 5. Question 5 says, sketch below is the graph of f of x is equal to, and this is a hyperbola. But the thing about this hyperbola is it's not in its original format. Remember that the original format is this. So they're clearly just trying to make you think a little more there. And then they say having the domain where we have... Okay, so it's going from negative infinity to 1 and then union 1 to positive infinity. So they just chose a different way to write it, but it's really ultimately saying that you're going from negative infinity, so negative, infinity, and then you're going all the way to 1, meaning there's an asymptote there. And then after that, they're going from 1 to positive infinity. It's really just exactly what is here. The only difference is, do you see that we have round brackets, especially by the 1? So they are showing you that 1 is not included. X is not equal to 1. That's really what they're saying there. And then they say the graph of f cuts the y-axis at 0 and 1. So, okay, that's a y-intercept. And then we have a line of symmetry of f, okay, is given by g of x is equal to x minus 3. That is very helpful. So they already gave us an axis of symmetry, okay, for this hyperbola, and that is g. And we have the equation. Okay, the first question is to write down the value of p. Where is p? Okay, so p is this value. Okay, so this is where you really need to think about that. Remember, the original function is supposed to look like that, where you have x minus p. Okay, you know that the vertical asymptote is what we call p. So if that is x is equal to 1, right, positive 1, when you have it in the function, what is that supposed to look like? It's supposed to be a over x minus 1. Okay, that's why it's supposed to look like that. And then, of course, whatever the Q is. So now compare what it's supposed to look like with what they presented you with. And now what does that mean about P? What is P? P is actually equal to -1 because we have X plus P. Okay, if you're substituting P as -1, you're saying plus -1, which ultimately becomes X minus 1. And that's exactly what it's supposed to look like. So P has to be equal to -1 for that to happen. Okay, so that is the value of P. The P is equal to -1, not +1. Okay, don't get confused by that. Okay, so that is it for the first question. Moving on to the next question. 5.2 says determine the equation of the horizontal asymptote of F. So this one is what we need to find now. Okay, is there any hint that helps us to find the horizontal asymptote? So you see that they gave you this point 1, 0, and 1, but you can't really just substitute it to find that horizontal asymptote. It won't work because right now A is still missing. So you have A and Q missing. So 1 point is not enough. Okay, so what other thing did they give us? Well, they told us about the line of symmetry, which is a very good piece of information that we can use. Because the thing about the line of symmetry, do you see that it also passes your asymptotes? Meaning here at this point, the X value is 1 and the Y value is whatever the horizontal asymptote is, that Y value. So how do we find it? Since this is 1 and whatever that Y value of the horizontal asymptote is, why don't you just substitute the X value of 1 into the equation of G? And that will give you the Y value that we're looking for, that Y value. Okay, so let's go ahead and do that. So I already have G of X, so I'll just say G of 1. We're substituting 1 in place of X, and it's X minus 3. So that's 1 minus 3, which gives you -2. So now we know it is -2, and so that would mean that the equation is Y equals -2. And there we go. So Y is equal to -2. Moving on to the next question. The next question, 5.3, says calculate the value of A. Okay, we have P, we have Q, only A is missing. So all we need is a point on the graph. So f of X is equal to A over X minus 1 minus 2, because we have that horizontal asymptote. And now you just need to substitute a point, because if you have a Y value and an X value, only A will be missing, and we can use that to solve for A. The only point they gave us on this graph was this 0 and 1. So we can go ahead and use that. So substituting 0 and 1 in place of X and Y. So that means we have 1 is equal to A over 0 minus 1 minus 2. Okay, let's take the -2 over. It becomes a +2, and you still have a +1 there, which gives you 3 is equal to, and A over 0 minus 1 is -1. So that is A over -1, which A divided by -1 is -A. Okay, so the A is there. You can just multiply both sides by negative to get rid of that negative, and therefore positive A is equal to -3. There we go. So A is equal to -3. Moving on to the next question. The next question, 5.4, says, for which values of X is f of X greater or equal to 0? Let's look at that. Where is f of X greater or equal to 0? So this is our graph of F. You see that this wing over here, yeah, that's not greater or equal to 0 in any way. It's not even greater than 0. When they say greater or equal to 0, they're referring to the Y values of the graph. So if you look at the points on this graph, right? Look at the Y values. That's a negative Y value. That's a negative Y value. That's negative. It's negative all through here. So we can't even use that wing. It's not greater or equal to 0. But when we look at this part of the graph, see that over here, look at these. Look at the point here. Look at the Y value there. It's a negative, it's not -2, but it's negative something. And then that's negative, and that's negative. And then what happens? Once you get to this point over here, the x-intercept, what is the Y value at this point? It is 0. And then after that, you see in this line over here, what are the Y values here? They are all positive Y values, okay? Over here as well. these points have positive y values. They're in the positive part of the y-axis. So these places are all the places with values that are greater than or equal to 0. So the first most important point, the key point here, would be at that x-intercept, because before the x-intercept, everything was negative. So we need to find exactly what that x-intercept is. So find the x-intercept of the graph of f first, trying to find that. So we'll just put down our graph first. So it is negative 3 over x minus 1 minus 2. And then to find the x-intercept, you make y equal to 0. So that becomes 0 is equal to negative 3 over x minus 2, minus 1, sorry, minus 2. And then we can just take this over instead, so that it just becomes positive. So that's 3 over x minus 1 is equal to negative 2. And then we can cross multiply to get this, the x on its own. So we're going to multiply here. But you see that you're multiplying with two terms. So the negative 2 must multiply to the x, giving you negative 2x, and multiply to the negative 1, giving you positive 2, is equal to 3. Okay, so because the 3 is just multiplying by a 1 here. Okay, and now we can just take that negative 2 over. I should have left it the other way. And this is equal to 2, positive 2 still here. And then the 3 comes over and becomes a negative 3. 2 minus 3 is negative 1. So divide both sides by 2. And therefore, that means that x is equal to negative a half. Okay, we've got our key point. That's what we needed. And we can see if this is a half over here, negative a half, then the values of x for which this graph is going to have values greater or equal to 0, first of all, will be at negative a half. And then do you see, we're just trying to look at the x values now. Do you see that the x values here always line it down to the x-axis? So highlight the point of the graph, the part of the graph that you found is correct, and then line it down to the x-axis so that you can understand which x values it's referring to. So that would be values starting at negative 1 over 2, and then it's values that are greater than negative 1 over 2. And do you see that they will not go past 1 because there's an asymptote there? So how we can actually say that it's greater than negative 1 over 2, but it's less than 1. Okay, so we can write that as x is greater than, but not just greater or equal to negative 1 over 2, because at negative 1 over 2, your y value is 0, but less than 1. And that will be our answer over there. Okay, so we can just put that down. Our answer is x is greater than or equal to negative 1 over 2, but less than 1. Okay, moving on to the next question. Question 5.5 says, graph f undergoes a transformation. We don't know what happened to it. We don't know if it gets shifted up, down, or reflected, but it undergoes a transformation to h. So it becomes h. Then they tell us where the domain and range of h are the same as that of f. So sure, it gets transformed from f to h, but the domain and range don't change. Okay, that is an interesting point. Domain and range stay exactly the same. And then they tell us that h prime, okay, so that is the derivative, aka the gradient. Okay, so that's another thing you need to remember when you see things about the derivative. They're really just speaking about the gradient of that function. Okay, so the gradient of the function is negative on its domain. So they're saying it's negative for the x values. Okay, let's actually speak about the first point first. Okay, so the domain and the range have to be exactly the same of h and f. Let's look at our graph. I'll really just bring the graph down and let's actually look at that. Okay, so them saying the domain and the range don't change just really means that it's going to stay exactly what it is. Okay, so it doesn't change. Doesn't mean the graph is just going to look like that, but the domain and range stays exactly. So if this starts at a specific point and ends at a specific point, then that's what this transform graph is also going to do on the domain and the range. Okay, how can we actually get that? Can we transform this graph so that that never changes? You see, the thing about this is if you try to shift the graph, that's not very helpful because the domain will change. Okay, if you shift it up, for example, what you're also doing is taking your asymptote and shifting it up. So it's not going to work. So shifting it, up or down or left or right is not very helpful because it's going to change the domain and the range or either one of it. Okay, so shift it up or down, it's going to change that horizontal asymptote, which changes your range at the end of the day. So that's not a good idea to shift it. How else? What other types of transformations are there? Well, there are reflections. So can we reflect this? Okay, so looking at this, it can be reflected across, for example, the y-axis or x-axis. If it gets reflected across that axis, all it does is that it becomes a mirror image of whatever it was. So you see, it looks like this here. It would really just do this. I would love to do that, but that's actually going to change the domain. Here's the reason. If you reflect it, what happens is that you're reflecting across the y-axis. If you are reflecting it across the y-axis, all your x values will change. If this looks like this now, your asymptote is going to be here. So see how that's not helpful? That will end up changing the domain because this is an x value. It changes the domain because this is the vertical asymptote. Okay, it's a very important point in the domain. Normally we would say, okay, the domain of this is x is an element of all real numbers, but x should not be equal to 1. What will happen if you decide to change it is that the red graph's domain is now going to be x is an element of all real numbers, but x should not be equal to -1, because that's what's going to happen here. That is going to become -1. So that changes the domain. We don't want that to happen. We want the range and the domain to stay the same. So how else can we actually transform this? Okay, so I'm thinking of another way that you can actually do this. Is actually two ways. It's not just one way that we have. There's two ways to do this. You can decide to actually reflect this, but not across the y-axis because it changes too much. You can reflect it across this vertical asymptote. You can also reflect it across the horizontal asymptote. So what happens is if we're looking at this line as the line that we're going to reflect it across, this graph is really forming a mirror image here. So this, it gets reflected. You see how this point over here is this far away from this asymptote? Well, the reflected one is also going to be as far away. They are going to be the same distance apart. So you're going to have that point over there. Over here, for example, right? The distance between the graph and this line is going to be exactly the same as your new graph and this line. And then here as well. So that ends up creating a graph that is reflected like that. But the good thing about that is that the domain will not change. The domain is exactly the same because it's still never going to pass 1. Neither is it going to pass -2. Okay, so that is a good way to do that. So of course that would happen to both wings, also this side as well. The way we have that going like that, if it gets reflected across the line x is equal to 1, it's also just going to do this. Okay, and like that. So that's basically what's going to happen. So there's two ways that you can do this. The first way is you can reflect f across the line x is equal to 1. The second way is that you can reflect f across the line y is equal to -2. Because the thing is, you see, the thing about a hyperbola is that it's really just symmetrical. If you find, okay, we have the axis of symmetry. You see, we have this one. But if you drew the -1, you will notice that. You will notice that what it does here, it does the exact same thing here. And that's why that's called the line of symmetry, because it's going to cut it symmetrically. So if you reflected it across the line y is equal to -2, that's actually what's going to happen as well. As far as, because this is the line of reflection, you see the distance between the graph and this line is going to be exactly the same as the distance between this new graph and that line. So that's why I say you can actually reflect it in through that line x is equal to 1 or through the line y is equal to -2, and that will work perfectly. Okay, so that will maintain that. Now, what do they mean by this? H prime, the derivative, is also negative on its domain. Let's actually check whether that's true or not. Is the gradient negative? Here's how you can find out where the gradient is positive and where it's negative. When you see derivative, it means gradient. What gradient really means, to be positive or negative, is this. If a gradient is positive, it means that your graph is going to be generally increasing. Okay, so it's going to be moving up. And you always read graphs moving from the left-hand side to the right-hand side. If your gradient is negative, your graph is going to be decreasing. So they told us that the derivative, it should be negative on its domain. So our gradient, this graph really just needs to be decreasing through the domain. So when we're looking at the domain, they just mean the x-axis really, or all the x values. Is it decreasing? Yes, look at what it's doing. This graph is decreasing. Look, reading from left to right, it is moving down. Reading again from left to right, it is moving down. So that perfectly fits what we are speaking about. So those are your two answers. You can use either that or that and it should be fine. Okay, so that's an extended explanation. Remember, on this channel, I don't like to do quick explanations because if I explain something and you don't understand, I see that there's no use of you even watching it because you just saw me do it, but then you won't understand what I did. Neither would you be able to actually do the same thing in an exam setting if that same type of question was asked. Okay. And I also encourage you guys to ask questions in the comment section. If anything doesn't make sense, also just point out things. If you see anything that didn't, make sense, because I'm human, I can also make mistakes. Okay, so that is it for that question. And we finally move on to question 6. We are now on question 6, and question 6 says, in the diagram below, the graphs of f of x is equal to, and as you can see, it's a concave down parabola, and g, which is a straight line, are drawn. Then they tell us that c, which is 3 and 8, is a point of intersection of f and g. Okay, so there. Then EH is drawn parallel to the y-axis, with E a point on F and H a point on G. Okay, so that's what we have. And the first question is, calculate the coordinates of B, the turning point of F. Okay, so just find the turning points. But as you can see, the graph of F is in standard form. So finding the turning point in standard form. Okay, so how we find the turning point in standard form is, since our equation is f of x, I'll just leave this as black, f of x is equal to negative x squared plus 4x plus 5. You can use this formula. Okay, the turning point formula is, to find the x value, is x is equal to negative b over 2a. So substitute your b and your a value. Your a value, as you can see, is negative 1, and your b value is the 4 that we have there. So x is equal to negative, and b is 4 over 2 times negative 1. Okay, so that's negative 4 over negative 2. Negative 4 divided by negative 2 is positive 2. Okay, so that is the x value. Then we have to find the y value. To find the y value, simply take the x value and substitute it into the original equation, and that would give you the value of y. Okay, so you can check out what that is on our calculator. Okay, f of 2 is 9. So that point B they were asking for is 2 and 9, and that's our answer. Okay, moving on to the next question. The next question, 6.2, says, show that the equation of the line through A and C is given by this. So through A and C. Okay, so it's going to pass through A and pass through C. So the only thing we need is, we just need the point of A. We already have C. And then it's really just finding the equation of a straight line. So how can we find the point A? Well, it lies on the graph of F, which we have. It's specifically the x-intercept. It's one of the x-intercepts. So find the x-intercept and we'll know what A is. To find the x-intercept, you simply make y equal to 0. So we're saying f of x is equal to negative x squared plus 4x plus 5, and then make y equal to 0. Negative x, I'm just going to say 0 here. And then you can choose to multiply by negative 1 on both sides, but I'll just see it as taking everything over. So it's now positive x squared minus 4x and minus 5 is equal to 0. Then let's go ahead and factorize. So we've got x, and then we need factors of negative 5 that can give us a 4. 5 is a prime number, so 1 and 5 are your factors. And then we need this to stay negative. Remember, one of it needs to be negative so that it can become -5. So we can give the negatives to the 5. So 1 minus 5 is -4. So that works out perfectly. So that is +1 and -5. And then solve for x. X is therefore equal to -1, or x is equal to +5. Okay, now we need to find a, right? We're not looking for the other one, just a. So which one would be a, -1 or +5? It would be -1, because you see where a is, it is on the negative part of the x-axis. So the coordinates, because it's an x-intercept, it will be -1 and 0. So we already know what that is, -1 and 0. And we can use these 2 points now to find the equation of this line G. Okay, let's go ahead and find it. So we're working with the point A, -1 and 0, and the point C, which was 3 and 8. So C is 3 and 8. So first you can find the gradient, and the gradient is y2 minus y1 over x2 minus x1, which is equal to, and let's just subtract. So that's 8 minus 0 over 3 minus -1, which becomes a +1. So that is really just 8 over 4, which is 2. 8 divided by 4 is 2. So our gradient is 2. And now we can find the equation of that line. I'll just use the quick method. There's the y equals mx plus c, but I'll just use this formula. Y minus y1 is equal to m times x minus x1. So we're saying y minus, now the y1 and the x1, they just stand for a point on your graph. So I'll take the easy point, which is a. A is an easy point, -1 and 0. So that's your x1 and that's your y1. So y minus 0 is equal to, our gradient is 2, times x minus -1, which becomes a +1. And so y minus 0 is still y, which is equal to, distribute, that is 2x plus 2. So therefore, g of x is equal to 2x plus 2, like they said it was. Okay, so that is it for 6.2. Moving on to the next question. Then question 6.3 says, calculate the maximum length of EH for where F is greater than G. So when they say this, they're really just telling you where the graphs are and what you need to really subtract. So if they're saying F is greater than G, it just means that we're going to make sure that this is where the graph of F is above the graph of G. And you can see it happens here. So here, the graph of F is above the graph of G. But everywhere else, as you can see, look at F, it's below the graph of G. Okay, so we just know it's this side. And they really just want us to find, they say the maximum length. Okay, that's not bad. Maximum length. So them saying F is greater than G is just telling us which one to subtract first. So this could have been seen as f of x is greater than g of x. See, if you take g over, they're really telling you to say f of x minus g of x. And you know that it's f of x minus g of x because they said f was greater than g, meaning f needs to be above g. Subtract these two graphs where f is above g. So f of x minus g of x. That's what we'll say. We know what f of x is, negative x squared. And then, so we're going to say that is negative x squared and then plus 4x plus 5. Okay. And we're going to subtract that by g, which we just got. Remember, that's to find the length of EH. That's how we're going to find the length, by saying that graph minus that graph. See them as y values. This y value minus this y value would give you the length of EH. Okay, so that's really what we're doing there. So EH is equal to this, and then minus g of x, we already found that to be 2x plus 2. So you can say minus 2x plus 2. And then, of course, when we distribute, you will see what that becomes. So this is the length of EH, first of all. The EH is equal to negative x squared plus 4x plus 5 minus 2x minus 2. Let's just simplify further. So EH is equal to x squared, and then those two go together and they become positive 2x those two go together and they become positive 3. Negative x squared. Sorry about that. Okay, so that's a very important point there. Now, they want you to find the maximum length. This is the length only. This is the length of EH. But now we need to find the maximum length. So see it like this. The length of EH creates a parabola, specifically a concave down parabola. If you have to find the maximum value of this, the maximum length, okay, then you're really just trying to find the point at which it is at a maximum. It is only going to be at a maximum at the turning point, because at the turning point, this is the highest y value you can get for this graph. So that is the y value we're actually looking for. That value will tell you the maximum length of the graph, because the length is being defined by this parabola or this function. Okay, so how can we actually find that highest point? Okay? Since we know it's the turning point, and the y value is really the y value of your turning point, which we usually call q. So to find that, we first need to find the x value. So how do we find the x value? Well, we already did this. How do you find the x value of the turning point of a function? If you're given the function in standard form, you use the formula x is equal to negative b over 2a. Okay, so that is going to be x is equal to negative, and our b value is 2 over 2. Our a value is negative 1. So that gives you x is equal to, that's negative 2 over negative 2, which is positive 1. So x is equal to 1, right? That is the x value, not the y value yet. So we just found the x value. So how will we find the y value at which it is at a maximum? That would be the maximum value, of course, we're looking for. You take the x value and you substitute it into the equation of EH, and it will give you the y value, which is your maximum value. So EH is equal to, and we say negative x, and in place of x we say 1 all squared plus 2 times 1 plus 3. Okay, this one is something we can actually just calculate. That's 2 plus 3, which is 5, and then this becomes minus 1. 5 minus 1 is 4. So the maximum length is 4 units, and we can just conclude, of course. Okay, so the maximum length of EH is 4 units. Moving on to the next question. The next question, 6.4, that's the last question for functions. And it says, given k of x is equal to f of x plus m, which is equal to negative x squared, and then minus, okay, a lot going on there. They want us to determine the value of m. First of all, k of x is equal to f of x plus m. This is being shifted. M is not a variable. Well, it's a variable right now, but it's actually stands for a number. Okay, it is being put here as a number. There's some sort of shift going on. Now, you know that when a shift is affecting the x value, what it means is that this graph is either being shifted to the left or the right. If it's shifted to the left, right, our m value would be positive, and then if it's the right, it's going to be negative. Okay, so just a back story on that. Then they tell us when they do this, it gives us this entire thing. Yeah, I feel like we can put this in some sort of a standard form, because what I'm trying to think about is don't get intimidated by the m. It's just a constant. That's what I keep telling myself. It's just a constant. So we can actually put it in standard form. Okay, but the question is, determine the value of m such that g is a tangent to k. That seems like the main point here. So what is the value of m so that g becomes a tangent to k? I've spoken about this whole thing with something being a tangent in my past videos as well. When you think about something being a tangent to another thing, they're really just trying to hint to you that their gradients are the same. That's really it. Okay, if you ever got lost there and you start seeing they said something is a tangent to another thing, they're really just telling you the gradients are the same. And if the gradients are the same, it means when you derive them, their gradients should be the same. That's kind of the main point here. But of course, I still want to understand it like graph wise, just in case there may be anything we need to actually look at. So let me bring the graph down. Also, let me just See, when we're saying that something is a tangent to another thing, the reason their gradients are the same is because the only way something can be a tangent or a line can be a tangent to a curve is like that, okay? And at that point of contact, their gradients would be exactly the same, okay? Okay, so here's our graph. First, want to understand it logically before we start working on the algebra of it, because definitely there's algebra. This thing is for 5 marks, so it's not something we can solve by just observing. They would never give you all of this so that you can just observe, okay? So let's just try to understand it first, looking at it with the graph, and then we can go into the algebra of it. So determine the value of m, okay, such that g is a tangent to k. Currently, the graph that we have is f. And they told you how this graph of k gets formed. K gets formed by taking f and translating it. So we either shift it to the left or shift it to the right somehow. Okay. So, and then when it gets shifted, it becomes, g becomes a tangent to that graph. So I'm going to actually just draw the outline of this graph just so that we can like control it more and just see where it goes. Okay, so that's what we have there. What they're telling us to do is this graph is going to shift. Now it could shift to the left, but as I shift it to the left, I start to realize how much of a bad idea this is. This will never ever be a tangent to G. Do you see? It's always just going to intersect G like that at 2 places, here and here, because that's going to extend down and it's going to eventually meet that one. So it's a bad idea to shift the graph to the left. So the only thing we can do is actually shift it to the right. Okay, so we shift it to the right and eventually it will be a tangent. Do you see how it is touching? Now, of course, the diagrams are not necessarily drawn to scale. So I can't just go, oh, it's a tangent here. I don't know yet. I have to find out. Okay, so that's basically what they're saying happens. Graph of k gets translated. Clearly, it's been shifted to the right. And then it becomes a tangent to the graph of G. Okay, let's get into the algebra of this. How can we do that? Remember that the main idea is for something to be a tangent, a line to be a tangent to a curve, their gradients must be the same. Let us focus on finding their gradients, in other words, the derivative of each graph. So we can start with G, simple one. G of x is equal to, they told us what G of x was. G of x was, okay, 2x minus 2x plus 2. Let me not get that wrong. So 2x plus 2. And if you find the gradient of this, it's going to be, so derive, that's 2 times 1 is just 2. And then the x is going to fall away, of course, because 1 minus 1 is 0. Anything to the power of 0 is 1. 2 times 1 is 2. Okay, so that's what that becomes. Then let's look at the graph of k, because we need to find the derivative of k. So let's look at the graph of k. Funny looking graph, but don't get intimidated by the m's. The m's are just constants. They're just normal numbers. They're not variables. So let me just rewrite k of x first. However, they did say it's f of x plus m, and then they expanded it. Okay, so I'll just write the expansion here. Okay, so this is what we have. Again, don't get intimidated by the m. So it's still a parabola, just doesn't look like one, because you see that the highest exponent is 2. Highest exponent on x is 2. So all we have to do here is put it in its standard form. So in its standard form, it will be in the form of ax squared plus bx plus c. Let us just put everything that has x squared together, everything that has x together, and anything that is a constant together. So the only thing with x squared is this right now. So we can just rewrite that. So negative x squared. Then we need everything with x. Do you see that this has an x? This also has an x. So we can write them together. Negative 2mx and then plus 4x. And then everything else is a constant. Even if it has m is just a number. So minus m squared plus 4m plus 5. Okay, so we're still trying to put it in standard form, just in a way that we can easily see what these coefficients are. So it's equal to negative x squared. There's nothing we can do about that. A is just negative 1. That's all we can do there. But then what can we do here? Okay, so the whole point is I just want to see what the coefficient is, because if I'm able to do that, I'll be able to derive it. The whole goal is to derive k prime of x. So let us just get x on its own. Okay, so to get x on its own, I'll just take x out as a common factor. So I'll say plus x, and what is left is, here in the first term with x, we have negative 2m that is left. And then in the second term with x, we have only positive 4. Okay, so there. Now I know exactly what the coefficient of x is, which is b. And then c is just everything else without x, because that will be considered as the constant. So that is just the negative m squared plus 4m plus 5. That is c. Okay, everything looks fine now. So now we just have to derive that. So this is k of x. Okay, so let's derive. So k prime of x is equal to, and the whole point is you take the coefficient times the exponent, which is going to be negative 2, and then leave the exponent, and then exponent minus 1, which is 1, and you don't have to rewrite that. Then in the next one, again, this is your coefficient, and you can see your exponent here. Maybe I should have written it the other way around, but okay, that's still coefficient, this, and then the exponent is what is on top of x. Okay, so it is negative 2m plus 4 multiplied by the exponent of 1 that we cannot see. So that stays negative 2m plus 4. And then if you still had your x, it would be, it's raised to the power of 1, right? You'd subtract the 1 from it and it becomes 0. X to the power of 0 is 1. 1 times anything stays the same. So that's what we have. And then what happens when you derive a constant? It falls away, and that's what's going to happen to that part. Because m may look like a variable, but it stands for a number. It stands for that f of x plus m, that number that shifted the graph of f. So we can just cancel it. Okay, is there anything that we need to add here? No. Okay, so this is fine. This is what we have. And remember, the whole goal is to find out where are the gradients the same, because the gradients are the same. If the gradients are the same, then that's where it is a tangent. So we're going to say g prime of x is equal to k prime of x. And we can just equate. So that one is 2. So this one is 2 is equal to negative 2x minus 2m plus 4. We need to solve for m. That's the whole goal. So let's just take that over, and becomes positive 2m is equal to, and here this is negative 2x, this is a 4. Okay, so we have a positive 4, and we're taking this 2 over and becomes a minus 2. 4 minus 2 is positive 2. Okay, still need to solve for m. You can divide both sides by 2 to get m on its own, and m is equal to, so that's going to give you negative x plus 1. Negative x plus 1, which I will just leave as 1 minus x. Okay, so it's still the same thing. Positive 1, negative x. Okay, so that's what we have for m. Now, let's just see what other information can we actually use to find this. And it has to relate to what we have. The fact that g is a tangent to k. So it must still be that. Well, because it's going to be a tangent, I know I just put it here now. I don't know where it is a tangent. I can't assume anything. Because it is here, if it is a tangent, right, to the graph of k, then it means that the graph of g and the graph of k, that at some point they're intersecting, meaning at some point they're equal. Their x and y value are exactly the same. So why don't we use that? So with that being said, we can actually make g of x equal to k of x. Okay. So that's, and the reason I'm going to do that is because you see here, this is not very helpful. M is equal to 1 minus x. You still have 2 variables missing. So we need one more piece of information. Okay, so let's go ahead and equate g of x with k of x. So we're saying that g of x is equal to k of x, and this is just going to be a very long equation. In fact, I'm starting to think about it now. If I am equating these two, the goal would be, well, let's just start and then we'll see. I really think x should be the subject here, but we'll see. Okay, so we're equating these two together, and then let's go. So g of x, remember, is 2x plus 2. And then k of x is that long thing. And right now, I don't think it will help to take the factorized version of it because you see things are going to have to go over and things like that. So that's just going to make us have to start breaking open brackets. So let's just take that entire thing first. Okay, so let's go ahead and equate. So we have, first of all, we can take x squared over just to make it positive. So x squared, negative x squared is over, and I'll just cancel when I'm done. So because there's a lot of variables here. So that's done, and it's the only thing with x squared. Now we can start with things with x. So there's still the positive 2x that is on the right hand side, and we're done with that one. Then there's this 4x. We're going to bring that over and it becomes minus 4x. And then there's this, of course, with the x as well. And so we're bringing that over and becomes positive 2mx. And then everything else is really just the constants with the m's as well. So that is this negative m squared comes over and becomes a positive m squared. That comes over and becomes a minus 4m. And we're done with that. And then our constants. Remember that on the right hand side, we already have a positive 2. So positive 2, and then this 5 that we have here comes over and becomes a negative 5. So minus 5 and then is equal to 0 because everything has been brought over to the left hand side. So the left. Okay. So let's simplify. We have x squared. Those can already subtract. So that's going to give you negative 2x and then still plus 2mx, or factorize if need be. And then plus m squared minus 4m, and then 2 minus 5 is negative 3 is equal to 0. Okay, so at this point, let me pause and just think about this. You see, the thing about this is we're trying to solve for m. If you want to solve for m, you need to substitute a value in place of x. So it means that this equation has to change so that x is the subject. So we're going to take this x over. So that was just me. Should have actually thought about that. And then it's 1, and then the m comes over and it's minus m. So we have 1 minus m. X is equal to 1 minus m. This is kind of like our equation 1. Okay. And then this is our second equation, and we're really just, working on that now. So what we can do here, if we don't need to simplify any further, we can simply just substitute the value of x into this equation. Okay, so we can do that. Let's substitute wherever you see x, we're going to put 1 minus m. So there's x squared. That's 1 minus m squared. And then we have minus 2x. That's again the 1 minus m. And then again, we have plus 2m times x. That's 1 minus m. And you see the whole point is to get everything to say m. Really just solve for m. And then we have plus m squared minus 4m minus 3 is equal to 0. Okay, so let us distribute here. So that's really just these two. They're the same thing. So you can rewrite it twice, but it's unnecessary. Square the first term, it's 1. Square the last term, which is m squared. And then first term times second term is negative m. Then times 2 is negative 2m. So we have plus m squared. Okay. Then distribute here. That is negative 2. Distributes. It's positive 2m. Keep going. We're going to distribute here. That's positive 2m again. And that's going to give you negative 2m squared plus m squared minus 4m minus 3 equals 0. Okay, and then let's bring everything with m squared together. So this goes with this and this. But here's the thing. Okay, we can just add it. See, if you say m squared plus m squared, it gives you 2m squared. Then that's going to subtract with the 2m squared. So you see that they will cancel. So that's gone. And then we're only left with the m's and the constants. So that is a negative 2m and a plus 2m. Those would cancel. We're done with that. And then here we have 2m minus 4m. So 2m minus 4m is negative 2m. And now let's just deal with all our constants. We have a 1, minus 2, and then a negative 3. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. Okay, so we have minus 4 is equal to 0. And then we have negative 2m, and we can take that negative 4 over, then divide both sides by negative 2, and therefore m is equal to negative 2. There's our value for m. So the question was, remember, determine the value of m such that g becomes a tangent to k. Okay, so the whole idea I used was the fact that if they're tangents, their gradients are exactly the same, but also if they're tangents, they are touching at that point of contact over there. Okay, so they're equal. So yeah, it's a long one, something that you really just have to focus so that you don't like make a mistake here and there. But that's what I get. M is equal to negative 2. Hi again, grade 12s. Okay, I noticed that this last question, there was actually a very quick way of doing this. So I saw that while editing this video. You see, because this, and the thing is, I already said it, but the problem is I started with this whole g prime should be equal to k prime. We actually didn't need to do that. What we could have done is actually start from here, right? Make g of x equal to k of x, since at this point of tangency, they intersect, right? So because of that, we could have already said g of x is equal to k of x. And then at the end, when we get to this point, instead of substituting this point, okay, instead of substituting a value for x, what we could have done is actually first put it in standard form, just like I did with when deriving, the way I structured it here, okay, so that it has an a, b, and a c value. And then we could have just used the discriminant. So we could have actually said, because we need this to have a point of intersection, okay, a tangent. So for that to happen, remember that tangents only cut a graph at one point. So you want one intercept or one solution, really. So to do that, you make delta equal to 0, because this will give you equal roots. Equal roots really just means it's the same root. See, it's like this. X is still equal to 3 in this case. So you would make delta, or the discriminant, equal to 0, and then you have b squared minus 4ac is equal to 0, and then you would have substituted your b value minus 4, and then your a and your c, and that would have become an equation where you can actually solve for m, because there would be no x in this equation. Okay, so you guys can actually try that and see if you arrive at the same answer. Okay, so that's it for that part. Okay, so that is it for the function section of this paper, and I'll see you guys in financial maths.